Welcome to APEC. It's April 20th, and I'm your moderator, Tim Ventura. First, I want to thank everybody for joining us on this call, along with everyone watching us on YouTube. I want to start out by apologizing to everybody for having to reschedule last week's conference. I spent a few days at the Asilomar ENC conference with Mark Sokol, Michael Perrone, and David Chester, covering Falcon Space research into dynamic nuclear polarization. And a short trip back from San Francisco to Seattle turned into an 18-hour marathon of delays. So again, let me start out with an apology there. I shot some great interview footage at Asilomar. I am working on putting together kind of a documentary on that. And I am hoping to do a bit more traveling in the future to spend time with some of our other presenters in the community. I'm anticipating a trip to visit Jared Yates on the Graviflyer team in mid-May and planning a trip to visit Jack Sarfati and Raymond Chow down in San Francisco in late June. So that is what's coming up for me. Now, I want to give a big shout out and an enormous thank you to Chris Plain over at the Debrief for his work on a new story about Charles Bueller and Drew Arigma's work on propellantless propulsion over at Exodus Technologies. The story is called NASA Veterans Propellantless Propulsion Drive that physics says shouldn't work, just produce enough thrust to overcome Earth's gravity. That title is a mouthful, so I'm going to drop a link into chat, and I will urge you all to check that story out. So today I am really, really excited. We have some amazing presenters and a couple of last minute changes as well. Before we begin, though, today's event is on StreamYard, broadcasting through the Alt Propulsion channel. If you haven't subscribed, please visit our channel online and do that. You can ask questions using the live chat feature on the right-hand side of the page, and we will ask them to our presenters depending on time constraints. Those chat, they come in and go pretty quickly. So we don't always catch them, but we do our best. You can also view conference replays, details, and speaker info on our website at altpropulsion.com. I believe this is our 59th webinar, and we have the open mic sessions as well. So we have a ton of material online. Pretty much anybody who's anybody in the community who is working on warp drives, gravity modification, inertial propulsion, UFO reverse engineering, anything along those lines has presented at one time or another on APEC. And I am so proud and excited to be able to showcase all of that. This is a community effort. This belongs to all of us. So thank you for being part of this community. So without any further ado, here's what's going on today. Ned Popovich will discuss space elevators. Tom Valone has given us a video because, again, he has some time constraints that I'm going to be playing on the development of ufology and astrosociology. And Nathan Bunten will be discussing Graviflyer experiments. So Dylan Freeman of the Rafos Network was not able to reschedule to discuss UAP phenomena from A to Z, but we are anticipating a new announcement later by John Brandenburg on black hole research. So a little bit of a switch up there. Today is going to be exciting. Dylan is probably going to come back in May, and actually next month in May, I'm also looking at some more stuff on the Searle effect, and we have a couple of other exciting things as well. So we will also be hearing updates from our lab partners and finishing off today's event with an open discussion by conference attendees. So without any further ado, thank you again to everyone. I am going to bring Ned onto the stage. There we go. Ned, how are we doing?
Good. Thank you, Tim. Really pleasure and an honor to be here.
You know, the pleasure is all mine. So do you have a presentation? Do you have a presentation, a PowerPoint that you want to load?
Yes, I would like that, please.
Okay. And so there are a couple different ways to do that. It looks like it's not loaded yet. Do you want to load that, or do you want to try and display that in a window?
See if you can see my presentation. I'm sharing it right now. Can you see the
There
presentation?
we go. Perfect. Yeah, that looks great.
Yeah, perfect.
Okay. Well, Ned, why don't I do this? I
Great.
will mute myself out and
Okay, I guess
disappear into the woodwork and go ahead and take it away, sir.
great. Thank you. Thank you, everyone. I just want to say thank you, Tim, very much for this opportunity. I am the founder and CEO of Futurecraft Innovations LLC, a leading consultation firm in practicing sustainable innovation and disrupting industry with breakthrough, pragmatic, and new product development solutions. I have over 15 years of expertise at a company called Bacardi, and I established the first Asia-Pacific R&D center in pioneering cellulosic conversion for its first-of-a-kind Tang green tea spirit drink. I was recognized by NASA for exceptional ability to blend creativity with sustainability in order to tackle some global challenges. And I have a multidisciplinary mastery spanning areas of chemistry, biological sciences, product development, strategic innovation, and I, of course, specialize in empowering companies such as CPG, cannabis, medical devices, and even space technology to drive market disruption while advancing positive impact to the world and our society. So with that in mind, I am really honored to showcase a novel solution to an age-old problem of the space elevator technology. So, ladies and gentlemen, esteemed APEC members and APEC-loving community, big dreamers and passionate visionaries and pioneering heroes, I thank you for joining me today. I'm really excited to be here. I'm grateful for this opportunity, and I'm honored to share with you a novel solution for space elevator technology, the space train. It's the only solution for overcoming the barrier of traditional cable design with magnetic levitation. Now, have you ever had a nightmare? A recurring one that maybe got you scared and kept awake at night? I had one of those when I was a kid. It was a heart-pounding and body-clenching fear of an incoming ginormous tsunami that was coming for me. And no matter where I hid, which building or tower I climbed, it was a futile attempt to escape. It always led me to waking up in cold sweat at the nick of time. Today I have 3 kids that keep me busy and tired, so I really can't afford nightmares. But it does inspire me to dream up solutions that afford them a better chance of future survival. And with the ever-changing and escalating global politics and environmental climate, what is their option to escape, to climb a tower, or to ensure a continuing civilization? So Victor Hugo famously said that there is nothing more powerful than an idea whose time has come. My goal today is to inform you, entertain you, and inspire you with one very realistic solution for a better future. Now, the purpose of this presentation is to introduce the space train, a novel technological solution for space elevator design that removes the barriers of cable operation and replaces it with magnetic levitation, which in turn makes the construction feasible, and it opens up the travel and leisure of space to individuals of all walks of life, not just the rocket billionaires. Now, let me start with a little bit of history first and how the space elevator actually concept came to fruition. Now, the first inspiration and imaginative invention for the desire to connect heavens and inhabitants of our planet started almost 500 years ago. They might not have had the words for space or even elevator at that time, but they used inspiring stories relevant for those times. Now, the Tower of Babel, which was first published in 1563 by Peter Bruegel the Elder, is a fascinating story from biblical literature. It was recounted in the book of Genesis about, I think, Genesis 11:1. And it tells of a story for a structure built in the land of Shinar or Babylonia after the deluge. Now, the whole purpose of this tower was to actually reach the heavens and make a name for its builders. Now, another work of aspiring art was Jack and the Beanstalk, which first appeared as the story of Jack Spriggins and the Enchanted Bean in 1734. And I am sure you're familiar with that story, right? Everyone knows Jack and the Beanstalk. But the first concept of the modern space elevator originated from a brilliant mind of a Russian scientist and space pioneer, Konstantin Tsiolkovsky. That was in 1895, where Tsiolkovsky drew inspiration from the iconic Eiffel Tower in Paris. And he envisioned a remarkable structure of a spindle-shaped cable extending all the way into space, culminating in what he called the Celestial Castle. Now, as our knowledge and technology progressed, so did the imagination of modern-day space elevator, which started even during the Cold War era. In 1960, Yuri Artsunatov wrote an article, "V Kosmos na Elektrovoz," which translated means into space with the help of an electric locomotive. And in this article, he discussed the concept of space elevator as an economic, safe, and convenient way to access orbit and facilitate space exploration. Now, on the other side of the world, Jerome Pearson, an American engineer and space scientist, best known for his work on space elevators, including a lunar space elevator, in 1975 published a detailed analysis titled The Orbital Tower. Now, he was the president of Star Inc. and has developed aircraft and spacecraft technology for US Air Force, DARPA, and NASA. But perhaps the most notable modern-day space elevator appeared and published in 1979 is The Fountains of Paradise by Arthur C. Clarke, which was a captivating science fiction novel set in the 22nd century. Now, the novel obviously centers around a visionary scientist and his ambitious project to construct an orbital tower known as the space elevator, and we hope that together we can accomplish this feat sooner than Mr. Clarke's vision of the 22nd century. Now, even though the political tension from the Cold War era hid ideas from both Jerome and Yuri, and they independently published their works more than 30 years ago, they finally met together in 2006. Now, since the dawn of space age, humanity has dreamed of breaking free from Earth's bonds and exploring the vast mysteries of the cosmos. Now, for too long, this dream has been reserved for a privileged few, billionaire visionaries with the resources to fund ambitious rocket programs. Now, as their spacecraft continue to pierce the sky, leaving trails of fire and smoke in their wake, the rest of us remain earthbound spectators, excluded from the ultimate journey of exploration and the final frontier. Now, what if a single catastrophic event threatened to extinguish the human spark entirely? Now, the world history has recorded stories and evidence of such events. What if a massive earthquake or a mile-wide asteroid hurling through the blackness of space set on an apocalyptic collision course with our fragile blue planet? In such a dire scenario, our dependence on volatile rocket technology could seal our fate. It would leave us powerless against the destructive force barreling towards us from the heavens. And please bear in mind that not all of us have millions of dollars to secure an escape seat on the rocket to safety for our family. Now, Hollywood has done an incredible job in imagining the possibilities of various threats. And yet, we are regrettably reminded of the memories of those brave few that have taken the risk to expand our knowledge and development of the only technology that can get us to safety from extinction-level disasters. We will never forget the rocket failures of Apollo 1st, 1967, Soyuz 11 in 1971, a Challenger in 1986, and Columbia in 2003. Now, here are the examples of some real-time Hollywood movies imagination in real life. Now, this is a map of meteorite fireballs reported by sensors around the globe from 1988 to February of this year. This is provided by NASA. Now, needless to say, this unpredictable and devastating phenomenon affects all corners of the world, in all countries, and literally everywhere. Now, perhaps you might recall some popular media coverage regarding these meteor fireballs, like the one in 2013 where the Chelyabinsk meteor in Russia thundered lightning-fast damage and fear among unsuspecting residents. And I still wonder how much time they actually had to duck for cover. Now, in February of last year, the Center for Near-Earth Object Studies predicted where another small asteroid impact happened near France, and luckily, without much damage. Now, there is not there's so much to tell about this image. You can just have a look. It portrays 1,000 words all on its own. The world tsunamis are a direct result of earthquakes like the 9.0 magnitude of the coast of Japan in 2011 that ricocheted its effects along the west coast of the US and Latin America. That's what you see in that image in the upper right corner. Now, even the volcano eruption, the one right below that image, 2 years ago sent a massive shock wave that was captured by our modern technology, of course, the satellites, from the safe observational distance in no other than space. And the images below to the left are real-life images of the tsunami aftermath caught by cameras on Earth. Now, the dangers of environmental cataclysm and the escalating political turmoil around the globe and the world are real, and they are terrifying. So, however, there exists a brighter path, a bold vision, first conceived over a century ago, yet still unrealized. Imagine a towering edifice anchored to Earth, reaching up through the clouds and into the star-streaked sky above, a celestial stairway providing safe passage to the final frontier. This is the dream of the space elevator, a revolution in space travel that could open the galaxy to all of humanity. But seriously, let's leave the imaginative dreams on the side just for a moment, and let's take a closer look at the principle of operation for space elevators. Now, there are 4 key components to this. Okay, there is the anchor station, the counterweight, the cable, also known as tether, and the climber vehicles. Now, the anchor station serves as the foundation. It is securely attaching the elevator to the Earth's surface, and it provides stability and prevents the cable from drifting away. Now, beyond the geostationary orbit, which is about 35,000 kilometers, a little more than that actually, a massive counterweight is positioned. Now, the gravitational pull or the centrifugal force balances the downward force from the Earth's gravity, and it allows the cable to remain taut and upright. Now, that means that the third part, or the tether, also known as the elevator chute, is the central component. It extends from geostationary orbit to the surface of the Earth and into space attached to the counterweight. Now, this cable is key, and it must be incredibly strong to withstand the immense forces that are acting upon it. And of course, the last piece to this principle of operation is the vehicle climbers. These are specialized vehicles, and they move along the tether up and down by mechanical means. And they shuttle cargo, they can shuttle people and space to between Earth and space, and they release payloads into orbit or help bring them back to the surface. The greatest challenge here is that the manufacturing this material would take an insurmountable amount of material, and it needs to be extremely, extremely strong. Now, this material and the choice that it's available today, the space elevators because of that, has remained an elusive vision because it is, due to traditional design, it has relied upon an enormously long cable tethered to Earth, and the construction is what strains it from the limits of modern material science. Now, we can think of some very commonly known choices. Diamonds, for instance, fullerenes, even carbon nanotubes first come to mind as the strongest materials of choice. But the amount of manufacturers for these advanced materials has actually increased over the years. I have provided here a list of about 7 of those. Alas, they still produce very, very small quantities of scale. And as global research and development of material science improves over time, there is another material. Graphene seems to actually hold great promise to solving the traditional approaches to space elevator dilemma. And the greatest challenge among the available choices is, of course, the technological difficulty to manufacture these large enough quantities. And in contrast, some rather popular materials, candidates like of the past, like Kevlar and Xylon, are too heavy, and they're not strong enough to be used as the material for tether. But what if there is another solution that does not require an obtainium tether? And we'll address this question, or the answer to this question, in just a moment. Now, building a space elevator tether presents a formidable engineering challenge. It includes selecting materials capable of withstanding high tensile forces, radiation, micrometeorite impacts, and the necessity of it being enormously long. Now, advanced composites such as carbon nanotubes, graphene, are very promising candidates due to their exceptional strength-to-weight ratios, but we do need them in these extremely large amounts, and they're nowhere near the capability of being manufactured. Now, a technical paper published in Acta Astronautica presented a feasible solution with currently available technology, but its radical recommendation was that it needs to be built on the moon. Now, of course, we have to get these materials there first, right? But because of these material limits, a company well known for the longest existing space elevator concept, Liftport, originally intended to build an elevator from Earth, but has since pivoted to Moon as a potential for the solution in overcoming these material quantity and strength requirements. Now, in addition to the speed and the payload capacity of climber vehicles, which are critical factors in optimizing space elevator operations, they are also required to have enough power to be supplied for traversing the climb to orbit, and where there were many solutions in the past. Now, most notably, some of the solutions from the past was a company known as Laser Motive, but they experimented with laser-powered climbers from the ground, and ever since has, probably due to technical difficulties of maintaining the target in sight, has pivoted to power light technologies. And it intends to use the laser power for space applications instead. Now, these challenges are delaying space elevators from coming into existence. Now, advancements in material science and even propulsion technologies are still too slow in enabling the development of lightweight, high-strength materials and high-performance climbers. Now, only the Obayashi Corp has a significant technological plan, and it continues to pursue traditional space elevator development with the anticipated operation by 2050. Now, I need to go through with you just really quickly about the current monopoly on the available technology and the only option to have access to space, which is dominated by a very, very inefficient mode of travel, which I'm sure you guys are familiar with, is the rocket. Now, before we get into the benefits of space elevators versus rockets, I just want to look at a quick look at an ideal rocket equation. This is going to help us understand the critical and key rocket limitations, and also expand on the space train or the space elevator benefits. The Tsiolkovsky rocket equation is a mathematical expression describing the motion of the rockets. It defines the maximum change in velocity that's indicated by delta U in the upper right-hand corner of the graph that a rocket can achieve. And this equation tells us that the necessary initial mass with the propellant grows exponentially with the desired delta U, or the change in velocity. Now, this means that as the payload mass increases, the amount of propellant required to break free of Earth's gravitational grip also increases. And this phenomenon is often referred to as the tyranny of the rocket equation. Now, I'm going to quickly just walk you through the most famous example of what is meant by this equation. And that is the example that we have recorded in history, which is the moon landing. The Saturn V rocket was the rocket that took us to the moon, and its mass at takeoff was 2.8 million kilograms. From that, an Apollo lunar module mass was just over 15,000 kilograms. Now, what that means is that 95% of that rocket payload mass was used only for liftoff. And the remainder of that, 1.6%, was used to get us from the low Earth orbit to geostationary orbit. An additional 1.5% was used from the insertion into lunar orbit, and 1.4% for the lunar deorbit landing, which means that about 0.5% of that total payload mass was actually what made it to the surface of the moon, and why we call this the tyranny of the rocket equation. Now, the space elevators are a simple solution to the rocket equation, They simply just avoid it. And here we have a rather busy but a very important slide comparing benefits of space elevators, or the space train actually, versus the rockets. Now, the launches do offer improved safety because they operate on electricity compared to traditional rocket launches, which are inherently risky due to potential for catastrophic failures during liftoff or even ascent. Now, in addition, they operate within Earth's atmosphere and are not subject to extreme forces. There's no subject to extreme noise, pressure, nor velocities experienced by rockets during launch. And while safety improvements are actually really difficult to quantify in terms of direct cost savings, mitigating the risk of launch failures can lead to significant indirect cost reductions. For example, insurance premiums for space missions could decrease, and the need for redundant mission planning and contingency measures may be therefore reduced, resulting in overall cost savings. Now, as we look to the environmental impact, it is no surprise that rockets emit chemical pollutants. Now, these include soot or black carbon, which is labeled BC in the upper right graph. And it also includes chlorine, which are both contributed from these solid rocket boosters. In addition, the re-entry of space debris from rocket launches and re-entry capsules leads to heating that produces nitrogen oxides and alumina, whose values are also shown in the graph above. Now, all of these pollutants are bound to affect the ozone layer. They're bound to upset the energy balance in the atmosphere and adversely affect the stratospheric chemistry. One would hope that this is the main driver or the main reason why the current design of reusable rocket systems is at play. I'm not sure. The simulated projections, or the anticipated increase of SpaceX rocket launches, is anticipated to be about 1,000 launches per year within the coming years. This was all based on the calculation upon Elon Musk's vision to colonize Mars. And that's what's necessary. They have concluded that with the finding that the soot emissions from 1,000 launches per year will increase stratospheric temperatures by 1.5 Kelvin. That's about 2 degrees Celsius, and it's enough to affect the global climate. Now here, we can look at the commercial drivers and the opportunities for the space economy. This is an old image, unfortunately, from the Economist article dating far back to 2018, but I just love how it's showing a graphical representation of total space launches since the inception of 1957. So since the year of Sputnik made the news around the globe. And if you observe the steep decline of state launch providers since 1990s and the increasing amount of commercial launch providers, the lunar race of nations and the private companies has been well on the way and has seen actually significant growth. I'll briefly just run through these very important facts and the developments. Now, ESA, or the European Space Agency, established a lunar village program since 2015. And Amazon in 2017 announced that it will provide package delivery to the moon. Now, the new space entrants have already landed on the moon, like China twice in 2013 and 2019, and India in August of last year. In 2019, Vice President Pence directed NASA towards the moon first by 2024. That's this year, the year we're in now, and then to look on to the Mars. Last week, the White House has actually directed NASA to establish a unified standard of time for the moon and other celestial bodies. And it is no secret that Jeff Bezos desires to move hazardous manufacturing off planet, while SpaceX is already working on larger reusable rockets to deliver people and supplies not only to the moon, but also beyond that. Now, we believe that the best and fastest way to get there is with a space train, not rockets. Now, since we like to be inclusive, we want to kind of briefly list some of the competitors in the currently available technology for space access. Now, the first group, it's by no surprise, a reusable rocket launch vehicles such as SpaceX Starship, Blue Origin New Glenn, Rocket Lab Neutron, and even NASA's ginormous Space Launch Heavy Lift rocket. Now, some other concepts that are propelled, but more of a space plane type of a concept, are Skylon by Reaction Engines and Spaceship Two by Virgin Galactic. Now, all of these currently available technologies, they have their limitations. And none of these can actually transport large amounts of payload nor masses of humans to space as efficiently. That is a given. There are some other options that do circumvent traditional rocket fuel alternatives to space. These include categories of propulsion systems such as the hypersonic air-breathing engines and mass accelerators. For example, spin launch is an accelerator that spins payload to orbit, and the Boeing's Pegasus is an air-breathing orbital launch concept, just like Sabre by Reaction Engines. Now, on the other hand, and perhaps the most environmentally friendly options out there are high-altitude balloons, such as Worldview Space and also the Space Perspective. Now, once again, we are reminded that even these technologies have their limitations, and none can transport large amounts of payload nor masses of humans to space as efficiently. Conceivably, the only technology that has a promising access to space but is yet to start development is a Canadian space and defense company called Thought Technologies and their inflatable and segmented space elevator. They have a patent. They don't have it built yet. But we are therefore reminded that once again, the rocket technology dominates space flight. If you look at the economies of scale for just a moment, in general, rockets do cost more per kilogram of payload. And the space elevators or the space train, the primary driver behind reduced launch cost is the elimination of these large expandable rocket fuel systems, and also the energy that is required to transport payloads into space, primarily provided by Earth's rotational energy and the green electricity. Now, this reduces the need for expensive rocket fuel. Traditional rocket launches require immense amounts of fuel and complex propulsion systems. I think you recall the tyranny of the rocket equations, right? This requirement contributes significantly to the overall cost. And in the last few years, you can see here on this graph, is that it appears that the size of the rockets is constantly getting larger in order to bring the cost of payloads down. There are numerous papers showing that space elevator's tether structure enables it to support much larger payloads compared to traditional rocket payloads. In the case of a space train, we have no need for the tether and expect similar performance of delivery. Now, recall that the rockets are limited by their size and the structural constraints of their launch vehicles. Now, this limits their payload capacity, and in contrast, a space elevator can theoretically transport payloads that are several metric tons or even more with each climb. Additionally, increased payload capacity opens up new possibilities for large-scale space infrastructure projects, and it also provides an opportunity for better protected habitats. Beyond these cost savings, space elevators offer significant economic benefits. They provide benefits such as increased access to space for scientific research, for resource utilization, and for a variety of commercial activities. Now, exploring these potential revenue streams, this includes satellite deployment, space tourism, space-based manufacturing. It will be crucial proof for the economic visibility and positive global environmental impact for this project. Now, we dare to dream and imagine many scenarios of disasters and fears, and unfortunately, a very few inspiring solutions. We imagine the stories we tell today as seeds we plant for tomorrow. The world needs diverse voices, unique perspectives, and inspiring stories to navigate the complex challenges that lie ahead. Now, innovation and progress are born from reimagining the status quo, from daring to ask, what if we tried something different? Albert Einstein said that imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution. Now, the space train breakthrough magnetic levitation could revolutionize space access for all of humanity, and not just the privileged few. It eliminates the need for traditional rockets, or at least it opens up a collaboration for the two. Okay, it offers a more sustainable and environmentally friendly approach to space travel. Our vision of the space train is to deliver a feasible solution for various levels of space utilization. Again, Obayashi Corporation portrays a detailed plan and has an amazing concept on various altitudes that contributes greener solutions, and it deploys satellites to low Earth orbit, geostationary orbit, including affordable travel to Mars and even Jupiter and beyond. Now, even though the centripetal force of the Earth's rotation is the integral part to the space elevator concept, the space train, on the other hand, enables climbers to ascend without the need for tether, with minimal energy expenditure, and its length automatically adjusted to various heights. Now, this completely eliminates the need for further extension or expansion into the beyond low Earth orbit. And this, in turn, opens opportunity for a variety of individuals and industries to join the space economy and, furthermore, the moon race. Now, imagine a future where response to natural disasters is readily enabled by magnetic levitation technology, where individuals who are in distress step onto the platform that immediately uplifts them above the danger and then safely deploys a floating platform to descend. Perhaps first responders and firefighters would not need to risk their lives. Now, we also imagine that the same principle of magnetically levitated platform would enable rapid fire and active defense systems against imminent threats from, let's say, missiles or meteorites alike. Now, while we believe that such platforms, when strategically placed and deployed across the nation, can effectively create a real-life force shield, and the Space Force will definitely benefit from this concept design for sure. Now, we also we imagine the future where the path to the stars is no longer dictated by wealth of privilege, but open to all who dare to explore it. We imagine that the space train would enable a deployment of a Skyline airport station, and which will be situated at altitudes of 10,000 feet and higher. It alleviates contrails in the sky and easily implements green airplane solution. For instance, solar-powered sailplanes for long travel destinations, and the myriad of aerial mobility vehicles like the autonomous eVTOLs, vertical takeoff and landing vehicles. We imagine a future where space tourism becomes an affordable reality, perhaps equal to the price of today's airplane tickets, where ordinary citizens can gaze upon the curvature of the Earth from the starry darkness of low Earth orbit. Now, space tourism would flourish because the space train would democratize the opportunity for new entrants. For instance, hospitality industry, restaurants, and perhaps even ultimate serene wellness centers and health spots, not only in the Earth orbit, but also on the moon. With the magnetic levitation technology of space train, even the most ambitious endeavors become feasible. We see a future where the boundaries of scientific exploration are pushed ever outward, unshackled from the constraints of conventional rocket propulsion, with no limits to the size of the payloads and opportunity for large construction material delivery. Now, we imagine possibilities with the Starline space station to have a transportation platform for massive payloads and complex machinery off-world for construction of habitats and research outposts, which would expand our reach further than previously thought possible. We also imagine that space shuttles would be deployed from orbit instead, from the bottom or from the ground. We also envision a solution for helping to make our planet healthier by moving heavy manufacturing into space and thus avoiding polluting the environment and our breathing fragile atmosphere. We can ferry valuable resources extracted from the moon, the asteroids, and even other celestial bodies back to Earth, and therefore fuel an expansive and growing space economy. Now, with so many opportunities to further space exploration with this breakthrough solution, we provide here a summary of the primary benefits of the space train. Now, compared to rockets, number one, the space trains are safe. They're safer. Number two, they overcome the material strength and length requirements by utilizing magnetic rotation. They're economically feasible for construction and a variety of commercial industrial activities. They're environmentally friendly and green, and they enable large payload delivery and scalable design. They also, it also democratizes space for us all. Now, if there is at least three things that you could get from this, please try to remember that number one, they overcome the material strength and it uses magnetic levitation. It's environmentally friendly and it democratizes access to space for all individuals and nations. Now, for decades, this material science challenge and limitation has confounded the world's brightest minds and stifled progress towards making the space elevator a reality. But what if a breakthrough solution could cast off the shackles of the past? What if we could revolutionize space access without the need for a gargantuan cable strong enough to defy the awesome pull of gravity itself? Now, it is with this bold new vision that inspired us to seek a different model for the solution, a technological model of human ingenuity triumphing over traditional seeming impossibilities, a future where the universe is open to all who dare to explore it. Prepare to be inspired, for we are about to unveil the science of a modern solution and a tale of innovation, perseverance, and a novel approach that could forever change the way we access space. Buckminster Fuller said, "You never change things by fighting the existing reality. To change something, build a new model to change the existing model." The discovery of magnetic levitation by rotation and the theory of the operating principle was first made by Hamdi Yukar in 2019, an independent researcher who found that rotating a magnet at speeds greater than 200 hertz can entrap another magnet. And this work is mostly Newtonian physics. It incorporates great insight and detail about magnetic momentum and inertia necessary to achieve the desired effect of levitation. This groundbreaking paper describing the effects and the physics behind it was published in Symmetry in 2021. I reference it for your perusal right there on the bottom. 2 years later, another paper titled Magnetic Rotation by Levitation, published in Physical Review, Dr. Bjork provided further insight into the levitating behavior and made measurements with high-speed cameras and software to greatly illustrate the relationship of this novel effect. Once again, both references are cited for your perusal right there. Now, the basic principle of the magnetic bound states and the mode of operation aligns with classical mechanics and effects of the Newton's second law of motion. Now, simply force, which is equal to mass times the acceleration, can be converted to torque and rotational inertia from angular acceleration. This study explores a dynamic autonomous magnetic interaction that defies conventional polarity-based behavior. Now, unlike typical magnetic forces that depend on polarities, this interaction results in short-range repulsion between one or more inertial magnetic bodies. Now, what that means is that, notably, this effect is novel and has not been previously reported in the literature. Now, the basic components of this system is what Hamdi termed the floater and the rotator. The rotator is a permanent magnet that is rotating by means of an electric motor, and the floating permanent magnet, the floater, is a rotating freely and basically becomes trapped body, in other words, bound by the equilibrium force of attraction and repulsion of the system. This study provides qualitative reports based on experimental results, trapping bodies with magnetic moments using rotating fields, spinning at very high speeds from 10,000 RPM up to 100,000. Now, the intriguing part is that the inertial body, or simply the spinning magnet, can experience a net force in the direction of the weak magnetic field, regardless of the position or orientation. That means that there's two distinct effects emerging from this interaction. First, the polarity-free magnetic repulsion, which is demonstrated when the inertial body experiences repulsion without polarity dependence. And the second, where the magnetic bound state is demonstrated by the body achieving a stable equilibrium and autonomically being entrapped within the magnetic field. Now, additional work and analysis by Dr. Bjork, Frederick Durhus, and Joachim Hermansen analyzed the levitation effect even further. They used high-speed cameras and have shown the behavior of motion with varying degrees. Their paper actually is the operating the magnetic levitation via an attractive and repulsive force, spinning at different speeds up to 450 hertz. They also demonstrate the physics behind balancing the torque between magnetic bodies. Now, as the levitation occurs, the work demonstrated that the floater magnet frequency locks in place with the rotor magnet. Now, surprisingly, the floater's magnetization aligns close to the axis of rotation and towards the like pole of the rotor magnet, contrary to magnetostatic expectations. Now, if you observe the two graphs above in the upper right corner, it was found that the larger the magnet, the smaller the speed required to achieve levitation, and vice versa. In addition, it was also determined that the levitation distance is higher with smaller floater magnets. The levitation is therefore achieved by floating magnet orientation, which changes with distance, and also the forces of attraction and repulsion that scale differently. These differences allow for mid-air equilibrium point to be achieved, and to us, the best and most intriguing finding is that the gravity is unnecessary, and the phenomenon works in all directions. Let me repeat that. Gravity is unnecessary, and the phenomenon works in all directions. Now, for the sake of time, if you wish to dive deeper into this magnificent study, below is a link to a fantastic YouTube video explained by the researchers themselves, and you can watch this in your own spare time. Now, everything finally clicked for us in place when this magnetic levitation research was published and the concept of the operating principle became modeled. It was kind of like our own eureka moment, which sounded more like, now that's interesting, instead of eureka. Now, we were inspired by these works, and it motivated us to develop our own designs. Perhaps you have actually seen these images before. The researchers who published demonstration videos that exhibit the proof of the concept, and we are now in the process of developing our own lab prototype for further research with, of course, right partners and interested universities. This is our CAD design of the experimental prototype that consists of the levitating platform, the magnetic rail or the magnetic bound bodies, the transporter, which is what we call the train that will travel up and down, and the loading dock. In this manner, we completely eliminate the need for an unobtainium cable tethering. And as of right now, we're only at the beginning stages and excitedly look forward to taking our works to the next level. This is the vision of the future that drives us. It's inspired by sci-fi movies and fear of future cataclysmic events that we cannot foresee. We dreamt about a disruptive solution for many years that will bring salvation for the humanity, for our planet, and for traveling beyond. We waited for the right time for the technological solution to be unveiled. And now, due to some intriguing scientific work and the discovery of magnetic levitation by ingenious researchers, it finally gave us the ingredients we need to succeed: the computer modeling, the simulations, and the feasibility of rotating magnetic fields to make cable-free design for space train possible. But before such lofty dreams can be realized, there are practical challenges to be addressed. Scaling up the space train prototype to a fully functional system spanning thousands of kilometers presents an immense engineering hurdle. Ensuring the safety and stability of payloads traveling along this unconventional pathway is of paramount importance, and it requires rigorous testing and fail-safe mechanisms. We will need assistance from NASA, DoD, and other research organizations to assess the space train operations in different environments, and especially addressing the space debris, which seems to grow faster and more dense than ever before since the beginning of space age back in 1957. And we also look forward to collaborate on possible active defense systems. We plan to partner with interested universities and research institutes to develop a better quantitative model. And in the meantime, we are actively working on and preparing for further experimental trials to better understand the effect of rotating magnetic fields, including their vibrational modes and how to control them. Eventually, the calculations for the economies of scale and transporter design will be crucial in order to garner support worldwide. In addition, we are evaluating plans to launch crowdsourced funding initiatives and public-private partnerships. And while research and development efforts are actually already underway, we are only on the first step to bring the magnetic space train from lab bench to large-scale reality. Emerging technologies such as advanced materials, robotics, and AI hold the promise of further enhancing the efficiency, safety, and affordability of the space train systems. Our vision is grandiose and undaunting. There's no doubt about that. Our goal is to complete the first step, the prototype testing, by end of the next year, if not sooner, and ambitiously further the development of a longer tower platform, eventually reaching the altitude of the sky and the stars by 2050. And we have faith to accomplish these plans even earlier. And in conclusion, to briefly reiterate the space train solution that was presented here for you today with a focus on some main points. We now know that magnetic levitation is a sustainable cable-free solution compared to old space elevator technological hurdle. We have experimental and theoretical operating principles modeled and analyzed. And in addition, the initial proof of magnetic levitation concept has been demonstrated and the provisional patent pending. We are also convinced that space train technology offers a safer and environmentally green solution versus rocket propulsion. We have plans to do further work, which includes assessing the magnetic levitation modes of control and scalability. We want to do some additional experimental trials for transporter design and load-bearing evaluations, assess alternative modes of magnetic rotation and better quantitative models, as well as perform tests and assess applications in different environments and related elasticity operation. And so, as the first functional segment of the space train takes shape, a new era of space access begins to dawn. An era where the universe becomes not just a destination for a privileged few, but a vast playground open to all of humanity. Where the boundaries of exploration are limited only by our collective ambition and the audacity of our dreams, we gaze upwards. Dreamers and visionaries, for the path to the stars has been forged anew. The future of space travel has arrived, and it is the future without cables, without rockets, and without limits. As Carl Sagan famously said, all civilizations become either spacefaring or perish. And now, if we ever have a nightmare of a tsunami or some other cataclysmic disaster, we can all sleep better knowing that there is a solution that can uplift us to safety. This is the future we can create together, a future without limits. Let your imagination soar alongside the space locomotive traveling through our electromagnetic highway to the stars. It will take audacious vision, relentless innovation, and collective ambition to turn this dream into reality. So I call upon all of you here today to join us on this journey to redefine humans' relationship with space. Will you join our efforts and the revolution to propel humanity into its spacefaring future sooner rather than later? The stage is set. The time is now. Choose to be part of this historic moment. The stars await our arrival. I thank you for your attention. And remember, you saw it here first at the Alternative Propulsion and Engineering Conference. Once again, thank you. Thank you, Mr. Tim Ventura, for the time and the opportunity. And I would also like to thank my associates, Klaus Hure and Anna Sipusic-Plese, for all their insights and help with this endeavor. I'm ready to take any questions if we have time. I hope it was okay.
Well, Ned, that is awesome. That is absolutely wonderful. Thank you so much, man. Thank you so much. So let me take.
Thank
I'm
you.
going to take down the presentation. We are actually at the top of the hour, so I don't think we have a lot of time for questions. But again, you know, if you want to stay until later, we could try and do that. What I'm going to do is bring everybody up on stage. We absolutely need to give you an enormous applause.
You're
Ned
the best. You're the
Popovich.
best. Thank you.
Thank you so much. No, it was so cool being able to see. I mean, there was so much history there and so much technology. You went through every single aspect of space elevators. I loved the comparison to rockets. There was so much, and that is something that we haven't covered enough at APEC. So, you know, it was wonderful being able to have you there. Does anybody else? Do you guys have any comments for Ned, real quick? Anybody else who's up on the screen?
I got a question.
Yeah, please.
Yeah. Well, let's squeeze it in real quick, Drew.
Yeah. Well, first of all, amazing presentation. But let's say you got a base, and doesn't the base still have to carry the weight of everything above it? However, you spinning magnetically levitate the individual strings of your pearls, the total weight still being suspended by the ground. How do you keep from crushing the base?
But that's the best part, because the weight is actually distributed among the repulsion and attractive forces of the magnet. So
Yeah,
what
but the
we've
last
done,
one on the ground's got to take them all.
it's true, but it's interesting because it doesn't matter which direction you put it. It holds levitating and stable, whether it's 90 degrees, upwards of 180, or 0 degrees, all the way in the bottom.
The thing on the ground's still going to take all of the reaction forces.
You know, it's
how do you
interesting.
plan to not do? I mean, you're talking about materials that would crush. It would have to be made out of diamond.
I love the question. I'd love to take this with you even deeper, Drew. If it's okay, please reach out. I'd love to continue and explore your concern here. From what we have seen, and this was all done on small laboratory scale. If you look at a small 20 millimeter magnet, it will lift. We have enough material to make one to the geostationary orbit, and it can do it no matter what the position or orientation is, which means it does not depend on the weight being crushed. There is no tension in it. It's not the same as a regular cable. There is no tension in it. There is no push and repel force. It's bound in the magnetic force itself. I know a lot of folks in our community have done some magnetic rotating fields experimentation. I would love to reach out to you guys as well, but there are other ways to entrap the body in there. And that's why it's so novel. It's counterintuitive because there's nothing to push back. It's just two bodies and more being attached, holding each other in the magnetic rail, basically, like a tractor beam. You can look at it that way.
Well,
Super
and again,
exciting.
space elevators are so exciting. So we are at the top of the hour, but Ned, thank you so much. Again, I want to give you a tremendous applause. And you know, if you have more, if you want to elaborate on this in the future, let's talk. Definitely come back and present more. It was absolutely wonderful.
Appreciate
so let me see. I'm going to take almost everybody out, but what I'm going to do now actually is I have Nathan with me, Old Man Builds. So Nathan, I'm wondering, would you be up for presenting now? Would you be up for going about an hour early?
Yeah, it's fine.
Okay. Well, and the reason I ask is, and again, this is why I apologize at the top of the conference. When I bumped everything forward 1 week, so one of our presenters wasn't able to join, and then Tom Valone has an awesome video, but it's just a video presentation. So I figured, why not get like the live real people, you know, like taken care of first. So if it's okay, let me put it up there. And so you're going to run us through the Graviflyer. I mean, you know, if you have an hour, just go through videos, experimental work. I know you're working with the team. You're working with Jared and Charlie and Mike Gamble, and I think like half the planet is getting involved with this at this point. So
I sent you a video. Did you want to play it, or did you just want me to explain it?
Oh, do you have, let me see. Did you just send it?
I sent it last a couple weeks ago.
Ah, okay. You know what? Let me see if I can find that. Okay, sorry about the delay. I did not know that you had one queued. Where is it? Oh, okay. You know what? It's saying it's saying that it can't play. Now we can do YouTube. Do you have those up on YouTube? Do you want to share some of those? And
Yeah, I do. I don't know how this
okay.
conference thing
Y-
works. So
Yeah, so okay, so go down to the present button down at the bottom of your screen. There's a button called present, and then there is a share screen. And what that will let you do, when you click that, it'll bring open a little window that'll let you share any Chrome tabs that you have open. So you already want to have your YouTube open, but once you share that, you can just kind of go back and forth with it.
okay, give me 1 second. Let me look real quick.
Yeah, no worries, man. No worries.
That's just a quick 5-minute video. It's real simple. Let's see where it is.
Yeah, I'm gonna blame Bernie for StreamYard. He's in our studio. Although in a weird way, StreamYard kind of
It's my fault. I should have gotten it preloaded. I'm sorry.
no, Bernie, StreamYard grows on you. It over time. Once you start to get used to it, it grows on you. It's just a lot easier and more fluid than Zoom is. So
Okay.
Another thing that could work if you have the YouTube links, Nathan, if you post it in the private chat, then Tim could open them.
Yeah.
If you're unable to figure it out the present button way.
Yeah, I found it. Let me go back to you guys.
Okay, yeah, no stress at all. No stress at all. And let me apologize to everybody for the delay.
There you go. I posted it in the chat thing there for the link.
Oh yeah, okay. So here we go. Graviflyer far more than you think. So let me do this. I am going to okay, and I'll put that in theater mode. Do you want me to just play the whole thing through?
Yeah, it's like 5 minutes. It's not a big deal.
Okay.
Isn't it? When we saw this Graviflyer lift, we all couldn't believe it.
Perfect.
Did this guy
I will be right
really
back.
create anti-gravity? What was he trying to do when he made it? Is there something more here? Well, most people have a misunderstanding of this. They simply think that you build this, you spin the disc, and you put voltage in it. I can tell you, the understanding of this is way more complicated than that. So let's get into it a little bit and let's take a look at it. And I'll do my best to demonstrate exactly what he was thinking and the processes going on here, because it's really more than you ever thought it was. Let's go ahead and start at the beginning with this project. You built your Graviflyer. You found every part that you could that matched what Alexi did. You built everything. You 3D printed files and you put it all together. You tested out your motors and saw that everything was running properly, counter rotation. Everything is in sync like it's supposed to be. You then bought every component you can think of that he put into this, including a flyback transformer, a ZBS driver, to make high voltage. With that finished, it's time to look at exactly what you built. You put everything into it you thought you knew. All the wires are connected here. Everything's starting to look good. We have our ultrasound disc in the top. We have our little tabs here to put in the high voltage on the disc. They're on the bottom as well. And all the wires are run through exactly the way Alexi did it. And without any understanding of the physics behind it, you ran this thing. And it just sat there. It spun and sat there. So what is it that you missed? You got every part. Was there something more to this? Well, let's understand the physics behind it and see exactly what Alexei saw and what he was thinking when he built it. He knew that by removing most of the amps from his flyback coil, he knew that he can get a static volt. So he charged the plates with those static volts, and it created a toroidal on the top and the bottom. Then he added a Tesla coil to create a field around the whole craft. As he turned on the ultrasound machine, it collapsed the top toroidal, taking all the positive charge from the disc on the top and placing it all on the bottom. However, it didn't stay positive as it was placed on the bottom. It all transferred into negative charges. Where the craft was once in balance, it now had an imbalance. This is how he created lift. But how did he break gravity? Let's take a look at the Graviflyer one more time. On the bottom, he put 6 magnets on there. On the top, he put no magnets. The magnets on the bottom created an eddy current that transferred into the center plate of the aluminum and also to the top disc. It made the motors go in sequence together. And because both discs had static charge on them, the motors would increase or decrease depending on where the charge was. The combination of all these effects would create a resonance in the center disc and allow the magnets to make a song. Alexei had put 6 magnets on the bottom. It forms a honeycomb structure, and like any honeycomb structure, it creates resonance. Resonance was what he was using to break gravity. What Alexei had done was nothing short of genius. He actually figured out how to break gravity, how to make things lift when you break gravity. This has far more implications going on than a simple lifter. He's actually creating a structure to make a magnetosphere, far beyond what anyone else on this earth has come up with yet. As we see his Graviflyer lift, it should give us all hope. Hope that one day we can all figure this out. Hope that one day we can reach the level that he did already. This is our future. This is exactly what we should be looking for. Some people see this as a small little flying object. I see it as something far greater. Alexei has changed this world for the better, and we all owe him a debt of gratitude. If you like what you saw here today, please like, share, subscribe, do all those fun things, and have yourself a great day. Thank you.
Okay, awesome. So Nathan, was that the only one you wanted to share?
That's it. Basically, if you don't mind me talking about it for a few minutes.
Yeah, no, actually, that was the whole idea. If I could set this up a little bit for the audience. So, I didn't even realize that you were involved with this project, right? I've been talking with Jared and Charlie for, and getting more and more excited. I think all of us have been getting more and more excited. And I keep asking Jared, I'm like, is this for real? Is this for real? And Jared's like, oh yeah. Oh, it's real.
Oh, yeah.
You know, and so it sucks you in, right? And so now we've got 4 of you. There's you, Jared, Mike Gamble, who is working diligently on it, and Charlie, and like all of you guys are just getting in so deep. So when I learned that you were involved, I was like, you know what, that'd be awesome. So yeah, take it away, man. I will remove myself and I'll give you the spotlight.
Yeah, so what it is just recently I just did this, and I'll just share this with you. I have my Graviflyer here. I blew out my upper motor here. And what I was doing was I changed the field on it. So on these discs, it's usually high voltage. So what I did was I put my Tesla coil here, and then I put my high voltage here. Now I work with high voltage a lot, and I like to transfer fields into a static volt. So I'll use 2 flyback transformers to create a static volt. What I found was by changing the two, I could push this field here, the high voltage field or static field, completely out from it in seconds. I mean, it's probably faster than seconds, probably milliseconds. What it does is the Tesla coil here on these discs is creating the frequency that matches these frequencies here. This right here is matching the power source to the high voltage. So it's pushing this out. What it does is it creates a field that takes everything that's in your garage or wherever you're at, and it actually just lights it up. So if you got lights that are going on in here and everything, they'll start lighting up. My toolbox you see behind me on this side right here, it just lit up and it started blowing everything that was touched on it. And it's because the field itself is expanding out and it's going to everything else. Now, traditionally, you want that field to come in. So I put the positive wire of the high voltage to it instead of the negative, which is my fault. I should have used the negative so I can pull that field in. What it's doing is it's magnetizing the center plate. I got aluminum to have a magnetic value and stick things to it. That's just not normal. It's not something you'd see every day. So it was a really cool experiment on this. Now, most of the Graviflyer stuff is you see it spin, you're not doing very much, and you got to have a lot of high-tech equipment to actually see what's going on. What I did here was I created something that you can actually visibly see and see things that are going on. So I've been doing this for a while, and I could tell you that fields, you have to change fields once in a while to see different effects. It doesn't just happen normally. You can't just plug things in. You have to see every effect. I did a paper lifter experiment where I lifted paper between two fields. And what it does, it tells you how much force is directed in one direction, and it'll force that paper lifter up to the field. Now, it has to be a bigger disc on top, smaller on the bottom. The cool thing about that is you don't have to put any distance in between. It's like a capacitor that's set, and it creates pressure. So that's what I'm trying to do here. I'm looking for a force that I can use. And finally, I found one in this thing that actually produces a great force. Now, the amount that you get out of it is way higher than what you're putting in. And when it expands out, it doesn't just stop at 4 feet. That's about where I unplugged it within the few seconds that it came on, is it pushes throughout everything. It'll electrostatic your whole garage door, your big garage door, from about 15, 20 feet away. It has no problem pushing it out. And it's actually kind of gets to a point where it's uncontrollable, the power that it puts out. So I think when Alexi described this, I'm getting the same thing, even though I changed what he was doing. It's completely different. He was changing the fields. He wanted the Tesla coil on the outside. The problem is the Tesla coil field, it doesn't react the same to the atmosphere that the electrostatic field does. And I think the electrostatic field is necessary on the outside just to break the gravity. And the problem is you're going to break everything in between to do it. And that's probably why you went in the middle of a field, in the middle of nowhere to do it. That's probably why his camera went really bad, no matter which camera you gave him. I know that Jared and everybody gave him an iPhone, and it destroyed it. So I got this idea to switch the fields from his actual, what do you want to call it, a circuit diagram that he gave. They actually crossed over. He didn't draw the little thing that went over, and he kept saying, no, it was this way and that way. And everybody clarified to me, but I'm telling you, it's probably reversed. And it's because of the way the fields operate that makes it that way. Static fields are different than regular fields. So it's going to incorporate a lot of things around it. And when it started polarizing the aluminum is when you know you had something special. So you get the magnets on the bottom and they're creating the eddy current, but it's still, that's what's causing the interference here and pushing things out, because it actually has a magnetic field on the center plate now, and it's aluminum. So it'll just drive you nuts. This thing, way more potential in it than most people see in it. And I've tried just about everything on this. I've electrified the living daylights out of it. You know, I put a Tesla coil with 300 volts of DC into this thing, man, and it created one big light show, but it didn't work. It's only when you get the harmonics right that it works. My upper and lower disc, they actually run way lower than everyone else's. I want to say I'm like 900 RPM on the top and about 350 on the bottom. These motors, I'll show you again here, if I get a better picture of it. These motors here are fan motors. And what happens is they cannot take the torque that a regular motor gives on a DC motor. The actual DC motor blows past the RPM that I'm at in the first click of the dial. And if you don't have the right one, you're going to go way, way higher. These can't go that fast. The bottom one here is especially hard to get up to 350 RPM. And it has to do with the magnet's weight will not allow it to push past it. And then the this one actually here is 24 volts that I put in here instead of 12 because I needed to initially get it to go faster. And then any interference like this right here, this is a little tab. I don't know if I can show it that well. Little tab that goes up in here, and all it has is little wires attached to it, so little brushes. And anytime that interferes in it at all, it slows it way down. So you don't want to touch the fields on there, but you have to touch the fields on there. So you have to have it just a little bit on there, and it shouldn't be sparking at all. But in what I was doing, it wasn't sparking, and the resonance of the discs themselves interfered with the resonance of the plate here, and it created a field that touched into something beyond anything I ever thought it would, and it started pushing. Now, I had the experiment running for about, I don't know, maybe 45 seconds, and it made a massive, massive field, so it didn't have time to build up static on anything. It was immediate. It was intensely immediate, and it was taking my web browsers and changing in between them. It was like an alien was on my computer changing things. It was bad. So, yeah, it's a complicated piece of machinery, even though it was made out of junkyard parts. It's got a lot more to it, a lot more potential than most people would think it would. And I think there's more into it. I think the people with all the scopes and everything see the harmonics in there. I got it to make sounds out of it by simply putting the wire underneath the magnet as it rotates. And what it does is it puts out a frequency into that magnet and makes a song. So every time you go around, it would be the same thing as taking a rotor and a stator. And as they hit each other onto the magnet directly, it transfers the frequency directly in the magnet and makes a sound. It's not unlike a speaker. As it goes in, it'll go back and they hit it and it'll make a sound. That's where you get that weird sound that I talk about. So it's really intriguing, the different things that you can get out of this when you change positions on things. Sometimes, man, like you'll see in my early experiments, I was using a lot of high voltage. On the newer ones, I'm using very low speeds, very low voltages. I think the most it's in there is 30 volts going in my Tesla coil. And my motors themselves are 12 volts. The one's 24, but it stays at 11.5 is what the number is on it when I run it. And the number one on the top is, I think it was at 9.5 I run on there, and then Tesla coil is 33.3. Those are the voltages going into it. So it's relatively low, but I'm telling you, the field I got, had I hooked something up to it, I could have run any light I wanted to in this garage and had zero problems doing it. All my fluorescents light up like crazy. So anyway, that's kind of the Graviflyer and what it's doing for me. The coolest thing is to work with everybody else and see where they're at in it. They are on a completely different level than I was getting out of it. I mostly deal with the physical, what action, reaction things are doing. And then they got me into a little bit more, so I bought some more equipment. And yeah, I'm seeing the harmonics in it a little bit. I'm seeing the different frequencies that it's creating, and a lot higher frequency than I ever thought it would. And that piezo disc works way different than what I ever thought it would do. I thought it was just going to dump a single, wave into it, and it's actually stopping it. So it's changing the waves in a different way. It's changing the frequency, all 3 discs all together. So kind of odd, but I like it. I mean, it's probably the neatest thing I ever did since I started retiring, man, and had enough, man. But it's really cool. Yeah, one thing I will say though, I get a lot of people telling me that the Tesla coil AC. Just understand this: in order for fields to interact, it has to be a transistor or a MOSFET that actually is in there, and it has to be DC voltage going in. You can't use a spark gap on this. So it's almost a misnomer to say it's AC. So what it is, it's a pulse DC. It's simply a pulse wave, and that's all that's going into it. So it's not necessarily as AC as you think it is. And because of that, the high voltage DC and the Tesla coil are interacting in the field. That changes things. That means that one can push upon the other and change the actual value of it, whether it be positive or negative. And that's the interaction I think people miss the most, is they constantly see this thing as like a spark gap Tesla coil. It's going to fly off everywhere. Even when I built the circuit for this thing, I put the resistor on the other side because I wanted to reduce the sparks coming out of it in the Tesla coil, and I wanted a more resonant value. If you ever see my experiments, the actual amount that comes out on the end of the wire is almost nothing. And it's pushing a different type of field than you think it is. That interaction is just so important. I try to show it with the light bulb that it increases the amount of energy that it puts out when you put it in that light bulb. And I don't think people really see it as much as I do when I'm experimenting, but I'll tell you today, that interaction is probably one of the most important things that you get out of this, because one field has to interact with the other and interact with the bottom one in order to couple together and to make something. So even running it traditionally with the correct things in there, it'll light some stuff up, but not anywhere near the runaway state that I got this last time out of it. And it gave me a lot more hope for this thing because I finally found the field that Alexi was getting. And it only happened in this way. So it's a strange occurrence when you start changing things. And yeah, I like to stay traditional. And you notice my Graviflyer is pretty traditional, but the fields out of it is way better the other way. And I mean, just all my experimentation over this. So just so you guys know, I'm not an electrical engineer or any kind of engineer by trade. That's not what I did. I used to own a cabinet shop, and then I worked, for a soda industry for a little while. But I retired, and this is what I like to do. I've been building circuits for my mom and what she did when when we were younger to make money. So I took this up in kind of a fun thing, and I got more into it, and I created every experiment that I could throw at this thing. I don't care if it was high voltage. I don't care if it was Tesla coil. I don't care if it was anything, static electricity, anything I could throw at this, I did. And, some things stuck, some things didn't. And that's kind of how I got into it. That's why you don't see a whole lot of oscilloscopes in my experiment and stuff like that. I generally like the reaction, and I know if it's working based on how it sounds and the reaction that it makes. So it's an interaction thing with me when it comes to this. And then the rest of it, I have to pull for putting the scopes and stuff on it to see it. But it's really the reactions that make this thing drive and make it worthwhile to work on. So yeah, it's produced a lot more than generally everybody else has probably looked at in this thing. So most of it just say, hey, let's put some high voltage on the DC flyback, and they don't realize, hey, DC flybacks are different, every single one of them. Not every one of them is the same at all. And how they make high voltage is how much they can reduce the amps out of it. So anyway, that's pretty much what I have on it, man. It's a cool project and it's fun. So I keep doing it. And that's it.
I'm muted. That is awesome. That is awesome. You know what? Let me bring everybody in here. I'm going to bring everybody else back in. We'll bring Ned back in. We'll bring Drew back in. let me see. We got a pretty good crowd. Everybody, please, Drew, thank you. Please put your hands together for Old Man Builds, Nathan Bunten.
Thank you, guys. Thank you.
Yeah. Hey, I'm wondering. So we have about probably half an hour. You want to open up for talk, discussion, questions, anything like that? Yeah, Jared. Jared has a question.
Observations. I'll wait until it puts his headphones back on, though. So Nathan, the big expansive EMF that you were getting, do you know about how far the farthest away something was that got affected?
At 4 feet is where about say 4 to 6 feet is where my TV was, right? So my garage door is probably about 20 feet away, and it hit that. And that's where my fluorescent bulbs are. So I have a pack of them sitting over there, and they were lit up like Christmas trees. And it was like, it wasn't just a little bit, man. It was a lot. It was like full-on Tesla coil sitting right next to it is what it was. So it was really big.
And you said that the RPMs that you were running at when that happened was just a couple hundred?
Yeah, it was probably about 800 on the top and about 350 on the bottom. It didn't give me time. I set them at what I normally set them at. Go ahead.
The magnets. It looks like the magnets that you have are kind of larger. What's the diameter of those?
It's 1 and 1.50.
Okay.
Is what it was. So 1.5 inches, and they're rare earth magnet. I didn't even use. Yeah.
In 42 or in 52?
No, they're not neodymiums.
Oh, rare earth.
They're rare earth magnets.
Gotcha.
I brought the actual plate from the bottom up. So I'm about 1.5 inches off the bottom on the rare earth magnets. So it has not so much eddy current in it, but it's there enough just to touch the plate and get into it, but it won't get into the top rotor.
Gotcha. So the observations I wanted to share, the fan motors that you're using, those have a tiny little chip in them that operates in like the 80 to 250 kilohertz range. And it's very susceptible to EMI, which is interesting that that's what Alexei chose to use, because, EMI like crazy in this thing, right?
Yeah.
But that little thing, it'll burn out if you get arcing, which is what Alexei says, if it arcs, you got to turn everything off and start over. And part of the reason for that is because an arc is likely to burn that little chip on the fan motors out.
Yeah.
Also, the Tesla coil, the frequencies of the Tesla coil can interfere with that little PWM in the motor, which is part of the reason why I'm not a fan of the fan motors, because, anything that is interfering with that natural wave cycle of the chip is going to interfere with the RPMs of the discs, which is, affecting everything else. But
it gets worse. The shielding on the wires they use, they're telephone wires. So the ones you unplug your wall and they're in there, that's what they are. So there's almost no shielding on it. So the EMI gets right into there. So that's probably why it's affecting these fan motors much more than it would a DC motor, is we actually use thicker wire with the thicker shielding. These right here, you can hook your oscilloscope up to these wires and about fry out your oscilloscope from them, because there is absolutely no shielding in it. So he created this device that is, everything's interconnected. From everything that I've seen, it doesn't just do one operation when it comes to one part of it. It has to perform 2 to 3 different operations, and the center plate does 4. So you're getting resonance everywhere. You're getting resonance in your upper disc, you're getting resonance in your bottom disc, you're getting in your center disc, you're getting a frequency coming into your center disc from a Tesla coil, or in my case, the high voltage was in there. And then you're getting one in between, which is causing this motion. And then the center is just seriously, it probably has like 6 different frequencies put into it at one time. And that's what drives you nuts, because it's like hard to control it.
I have one last question. On the outside edges of your spinning discs, when you run at certain frequencies, those will like, right? They have this wobble, really fast flutter. If you had to guess, what's the total millimeters that is the maximum from, stationary? So like plus minus 1 millimeter, plus minus 2 millimeters.
It's probably let's see, it goes from 1 millimeter to probably about 4, and then it'll start to really even out and it'll flatten out hard. And my best point of getting anything out of this thing is when you have it a little off balance. So the lower one is running a lot slower. So if you keep it in balance, it won't shake at all. I like to put it just a little bit out of balance where it starts shaking just a tiny bit. And then as you hit the resonance points, it'll flatten out the disc and it'll start straightening it out completely. And it won't be able to go back to the state that it was in before. It won't be able to start vibrating at all anymore. There's nothing you could do about it. You have to shut it down and start over if you want to get that thing to vibrate at all. It'll completely lean it out.
The reason why I ask about the flutter is because last night I was putting together a block diagram for how I'm thinking this thing works. And it's suggesting that all of the EMI and fields that you're getting, when you get those all phased together and synced up, so you're getting these big EMI spikes, that the flutter itself might be combined with those spikes to extract, asymmetrically damp that flutter. So you're extracting lift from half of the flutter cycle. So it means that the stiffness of those spinning discs and the amount of flutter that you're getting, indicating how much force is being applied to the outside edges of those discs, might be an important characteristic to consider. Even though Alexei's, it doesn't look like they're fluttering much, he's getting maybe plus minus 1.5 millimeters of flutter on his. The ultrasound dampens that flutter. And he says that he increases the ultrasound frequency to increase the height. Well, when you increase the ultrasound frequency, it might be that that's changing the efficiency of the lift energy extraction from that flutter. So my calculations for that are suggesting it's like he was running at maybe 2.5 to 5% extraction efficiency. And that the heavier your Graviflyer gets, the more flutter you're going to have to get, and the more efficient the extraction of that flutter is going to have to be. So right now, Big Bertha is weighing in at like twice of what Alexei's was, which means that when I do the lift forces on the edges of that thing, it means that those discs are going to be like bending really hard if I want to get this thing to lift, or I'm going to have to be extremely efficient at extracting a lot of that lift energy very quickly. Something to consider.
One thing I would tell you is by reversing the fields, it tells you that there's an explosive energy in this. So even if it's the Tesla coil wrapping around it like an original process, it still means that you're having a very big explosive energy from that static volt that's coming in from the high voltage. So if he's getting it to reduce on the top and expand on the bottom, it means that it's pushing against something. It has to break the actual field on the outside. The more ironic thing is he has a cone on the top and he doesn't have one on the bottom. There's no metal on the bottom. And that would explain why he's forcing something down. You know what I mean? He's forcing an explosion down. He's not forcing it up, that's for sure. He's forcing it down. And that would be why he has the field that goes like this all the way around the top and none on the bottom.
You weren't running, sorry for all the questions, you weren't running the ultrasound when you did that reversal test, were you?
The ultrasound wasn't working. I couldn't get it in fast enough.
So it looks like to me that the ultrasound might be helping to align all of these spikes together. And it seems like when you remove the ultrasound, you get a release of that syncing. So in your case, where you had this, big wild thing going on with all these electronics wonking out on you, it might have been that those fields were coming together and they weren't being held together and they just kept exploding out, right? So something else to consider might be if you are going to do that again, make sure that you have your ultrasound working so that you can try to see if you can get the fields to sync up. Also run at lower power so you don't zort your electronics.
Yeah, well, I'm going to do it outside and I'm going to blast this thing, man. And we're just going to find out one way or the other. I think that ultrasound is going to make a real difference in directing it down. And I think that's what I need. And I don't think I could do it in here again. That field was just too much right away. It was intense. It was not. It was. I walked out of my garage and I did not want to come back for about a day and a half. I didn't want to see it. I didn't want to do nothing about it. It was too much, and it makes you physically sick.
Awesome, Jared. Thank you. You know what? Before we do more questions, let me do this. If it's okay, I want to put up, because we have a lot of new members in our audience. People are not familiar with the Graviflyer. Let me put up some Graviflyer clips, if that's okay, or if you guys are cool with that.
Yeah, go for it.
And let me see. Here we go. There we go. Okay. So I'm going to go over to my other window. I can't really see you guys. So Charles Crawford III, Charlie, put together this collection of clips. This is 38 minutes long. So I think what I'm going to do here is go to a couple of his. There we go. Okay.
Долбанется. Не так быстро, правда, медленно. Все убрал. Сейчас ждем минутку.
If you don't mind, we'll talk over it if you're okay.
Yeah, go for it. Go for it.
Есть.
One of the things I found was a translation into English from what he said in Russian, and it was a good translation. And I went ahead and I just put it on an AI voice and put it on my channel. And he described what he was trying to do in detail. He said he was trying to repel the forces of the earth. So when I got the magnetic force in the center plate right there and I magnetized the aluminum, that's what told me I was on the right track of where he's at.
Yeah, well, so this collection right here is 4 different clips that Charlie has spliced together, and he has a couple of these. These are all kind of up shots. You can see, I mean,
Oh, this is the best one. The lower left one, he just made an adjustment, stands up, walks away, and then you get a delayed lift. That's one of my favorite videos of all time from Alexi because it tells you so much about what's going on.
It was him causing the interference, wasn't it?
No, I asked him about that. He said that he had just made an adjustment to the ultrasound and a tiny adjustment to the Tesla coil because that's what you need to do to make it go up higher. That was how we found out that it was the ultrasound being used to adjust the height. And there is a delay of about 3 to 10 seconds between an ultrasound adjustment and Graviflyer response.
okay, you know what? Here, let me fast forward to this one. I think that I actually put this clip together. I think that Charlie used my clip. So Alexi uploaded a 4K. It was a rare 4K for him, right? So super high res. And the color was way, way too dark. And so I remember this is 3 or 4 years ago now. I had to download a special, so the videos that he puts up use some kind of a special Russian MP4 wrapper. It's some kind of an open source thing that none of our video editors like. So I had to download some converter, convert it back to an MP4, get the whole thing set up. And I got to look at this in super high detail as I was working on it. And again, I don't see any evidence of strings or poles or anything that people have accused him of.
Well, just the way he manipulates it shows you that he listened to everybody and he's doing everything he can to touch it in every way to show you it has nothing.
So the only question I've had, the only thing is, this is high voltage, right? So how is he not getting shocked while he touches it?
He is getting slightly shocked. We asked him about that too. He said that when he touches the frame at all, he is getting a little shock from the Tesla coil. But we're getting ready to see one of the other best parts is where he kind of leans back and drop kicks the thing and it stays in the air.
Okay, that I can go along with. I've worked with Tesla coils too, and if you've got a high frequency and most of them have, really low output, you'll get a little zap, but it's just an annoyance. It's not like a real shock. So I'm down with that.
Even the high voltage, when you put it in static mode and you get it to really do static, the high voltage is gone. So it's more of a field than anything on there.
So when he touches it like that, does he notice a force on his hand or anything
Yeah.
like that?
Just the repulsive force against the lifting, like pushing down a helium balloon.
Okay, so it's not like a contagious force.
No, the thing is only lifting itself, which is part of the reason why I am slightly skeptical about the anti-gravity force-esque thing that he claims is creating. He says that the anti-gravity force is only in between the discs, which might explain why, nothing above or below it is getting affected. But I will choose the easy explanation of mechanical and electrical interactions over the hard explanation of anti-gravity any day.
Yeah, it's intriguing. So again, and this comes out of Drew and Charlie Bueller's article that we did on the debrief. We have a ton of new folks who are joining the conference today. Like the mailing list has just been piling up. We've got probably at least 100 people have signed up in the last 2 or 3 days. So for a lot of them, I'm sure the Graviflyer is new, and so we have to run through the confusion of this thing all over again. But they will get sucked in.
But
and then,
Hey, how come when he lifts up on the cables, it doesn't go up higher? He's relieving it of the weight of the drag cables, the power cables and stuff. But he lifts up on the cables, that thing should shoot up like a balloon.
That's a great question, Drew. When he has in the previous parts of this video where he has it 4 or 5 meters off the ground, he says that there it is. Oh, there's the drop kick. He says that the only thing that's really preventing it from getting higher and higher is the weight of the cables and the length of the cables. So you do have to think that it's not just lifting its own weight, but as it goes up in height, as the lift efficiency goes up, that it is lifting more and more weight of the cables. When it's down this low, close to the ground, its overall lift output is not very much because, the weight of those cables beneath it is not very much. So he lifts up the cables and you'll get like a kind of little bounce thing there, but it's not like it's producing enough lifting force to, start shooting skyward now.
yeah, that's something I'd wondered too. And if you look closely, and again, I'll drop Charlie's thing in a chat for anybody who hasn't seen it yet. People have
If he
accused
walks
him
over
of
to that thing and lifts up on that cable, it's not going to go up any? It's just going to stay at that same height?
It weighs 1.5 kilos. At 1 meter high, it's producing 10.5 newtons of thrust, right? So if you lift those cables, you've only removed maybe 100 grams, 200 grams, right? So the overall extra lift that you're going to get from the removal of that weight is an extra, 1 Newton. I don't know. I'm bad at math.
let me ask, this is muted for you guys, right?
Yeah.
Okay.
Yeah.
I just wanted to make sure.
I think he creates a pocket is what's going on. I don't think that those wires affect it that much. I think he creates a pocket around this thing in the field he creates, and it only moves when he wants it to move. And you see it bounce up back to where it goes because he's in a pocket. And I think that's what the field is for. He's creating a pocket of energy that stays in. And until he imbalances that, it won't move up. And that's probably why the cables themselves right there aren't having much effect on it.
Okay. What keeps it dynamically stable? He kicked it, and it should have changed the vector. So I understand it's got some spinny parts, so it's got a little bit of centripetal stability. But what's keeping that thing dynamically stable?
Well, right now, you can kind of, once the camera stops moving, you can kind of see how there's a little bit of an angle to it because there's wind blowing. But here's the interesting thing. It seems like it's usually pointing slightly in the direction of the wind.
Okay.
I think it goes wherever that piezo disc is.
Stable? I mean, that thing's producing thrust in some way, shape, or form. It's counteracting the Earth's gravity. So that thrust is going down, or the thrust is going up and the forces are the weight's going down. So it's like having a jet engine on a pogo stick.
I don't think it's creating thrust. That's the problem. I don't think it's creating thrust. I've never gotten anything with any of the wind meters that I have to have anything that pushes off of this thing as thrust.
Alexi says that it's kind of like
you'd never see it.
Alexi says that it's kind of like a buoyancy force, right? Like the boat floating on water type of thing. He's suggesting that you're kind of creating this bubble, this field around it, that it's like sitting and riding on top of. But the fact that he pushes it down and then it kind of rises back up and it actually kind of goes above and then bounces back down below itself, I think that's somewhat telling as to what's going on, how it's producing lift. Because if it was producing an anti-gravity force, you would expect it to just keep going up, right? But because it only goes up as far as the cables kind of let it, and then he lifts the cables and you only get, a tiny little change, I think that is suggesting that there's some kind, it's suggesting that at a minimum you can measure the amount of force that is being applied to it to get it to that height.
Now, if I could jump in really quick. So I just rewound this to a part where he is trying to demonstrate that there is nothing holding this up, right? And I think that's kind of important to showcase. But in his videos, Alexi has repeatedly tried to show people that there are not cables or posts or wires or anything along those lines that are involved with this. You can see here that he is waving a stick over it. In the video that we played a moment ago, he was doing multiple different types of that. And so again, he's just trying to show people that there's nothing holding this up. Now, again, there are ways around that for someone who is dedicated to try and fake out a camera. But, it looks like it is the real deal. It's just a matter of kind of figuring it out. Now, so I should ask, especially because we're focused on Nathan's stuff.
Like right there, he's like holding it down. So it has just enough thrust to lift the weight of the cables at one spot.
Yeah, and you can see in this video that from the way he's adjusting the height of it dynamically, it doesn't look like there's anything holding it up. It doesn't look like there's anything holding it down. Artificially.
It looks like it's trapped in a magnetic bubble.
Yeah,
That's exactly what he's doing.
There's a video.
That's what it looks like. Whether it's real or not, I don't know. I wish one of you guys would get one of these things working. And I want to come see it.
There's a video.
It does look like there's a little like haze around it, like that it's distorting and like there's a bubbly field almost. And like there's several people in the comments saying, are they the only ones noticing that it seems a little blurry around?
Compression routine.
It is the compression. The live video that we saw over Zoom, it wasn't doing that. Also, one of his outdoor videos is really good because it's a higher quality one. And you can see that in the time that it's taking to lift and get to its, half meter to 1 meter height, the bottom disc is slowing down. So when he's pushing it up or pulling it down like that, he's affecting the gyroscopic forces on those spinning discs, and it causes speed changes in those discs. But once it's already up in the air and all the phases and everything are all aligned and everything like that, it seems pretty resilient against getting out of phase and getting out of resonance, because, moving it up and down like that, changing the speeds of those discs, that changes all these other parameters, but everything's locked in. And so those parameters all kind of change together.
You're saying it's maybe using the Earth as some kind of a frame of reference, and as it goes up a little bit, something spins down, and as it comes down a little bit, something spins up, and it's one ginormous self-correcting leveling system?
If you take a gyroscope and you spin up a gyroscope and you hold it by a string and you lift it straight up, it's going to, first off, the whole thing's going to want to spin faster, the whole cage assembly around it. But also the speed of the spinning part of the gyroscope will slow down and fight against that change in position, right? And so what I'm saying is the speed of at least the bottom disc, when you're lifting it up like that, that gyroscopic force that's fighting that lifting force, it slows it down until it reaches equilibrium, and then it speeds back up, and then it slows down and starts stabilizing the speed of the bottom again.
Yeah, I think the gravitational waves are moving around it. I don't think that it can move quickly through anything, not in a big force like a rocket motor would. I think it has to stay in that bubble, and I don't know if he's creating the bubble where it can move in a faster direction than what he's doing.
I'll say it again. I wish one of you guys would hurry up and get one of these things working.
It's gone faster lately.
I think the more people that come together and build their own and start testing stuff, kind of like Nathan did, where he's like, hey, what if I try this and try something different, right? The more people that start trying things on this, the faster we're going to be making progress on this. For a while, it was just Charles and me and Mike, and then Nathan comes on. And then I think for about a year, we had a WhatsApp group the first year of this, and that WhatsApp group had something like 20 members, and about half of those members had built their own and were testing them. But after about a year, most people got bored with it and just kind of stopped. So we kind of lost a lot of that, what if I try this? What if I try that? But during that year, a lot of progress was made where people were trying all sorts of different things.
Yeah, the only way to find a weakness in something is to try everything. And that's what I do when I build Tesla coil circuits. I'm going to fry a lot of transistors and MOSFETs, but I'm going to know exactly where every parameter is. And that's what I do with this thing. I try to push everything that can be pushed on it and to find out where everything is. So when you go to tune it, it's a lot easier to tune when you know every parameter out there, and you can know it as soon as you see it. And that's a lot better than trying to look at something. For me, is when I can rebalance something immediately because I know exactly where it is.
Has anybody tried feeding all of these parameters into a machine learning, one of those AI things, and see if that thing can come up with some algorithm that I don't know. I mean,
as soon as GPT came out, that was the first thing and the main thing that I've been using it for. So I have all these different Graviflyer GPT chats going, where I keep feeding all these new different things into it. And it's come up with some interesting observations that I wouldn't have made for a lot longer otherwise. We also have the finite element analysis or modeling, the ComSol stuff that our ComSol guy is writing up our report for it right now. He's on the tail end of finishing up his simulations for it. So hopefully we'll be able to take that and also feed that result into the AI models and try to come up with some more understandings of this.
Can you rewind that video just a little bit?
Oh yeah, I'm sorry about that.
No, it's okay. Just show the point where it's starting to take off the ground. I want to show you guys something. So when this thing gets going, I want you to notice the imbalance in it, and then right before it starts to lift, it just thins out and the balance comes correct. So you'll see it shaking just a little bit, and then all of a sudden it stops shaking and then it'll start to lift. That's why I set my motors the way I do, is because of that effect. So you see it right now shaking, and it's a little bit unbalanced, right? And then as it gets to the correct field, you start to notice right there, it just leveled out.
Well, and so Nathan, I want to point out for the audience too, because again, we have a lot of new people. One of the things that people may think is ion wind. This is not ion
Not
wind.
a chance.
Not
you
a
can't
chance.
create enough.
It's this is probably 1,000 times too heavy for ion wind to lift it.
So. Oh yeah, I made ion lifters, and I could tell you right now, what is it? 2.4 meters per second is the average, and it's not going above that.
Yeah, with ion wind, I mean, I built lifters for years, and you're talking about something that's weighs less than like a kite, right? If I mean, as an example, this thing, I mean, you look at those motors, this is heavy duty equipment because he's scavenging out of a junkyard. So
that's about 3 pounds.
Something else that's worth observing in this clip is how it's kind of oscillating clockwise, counterclockwise rotation, especially right before the moment of lift. It's kind of starting to go one way, and then it starts going the other way, and then it lifts up. That clockwise, counterclockwise rotation is related to the difference in torques between the top and bottom motors, but also it's related to the reaction force of the eddy current in the center disk. And that reaction force can be adjusted via the Tesla coil. So in one of my first videos that I posted, I show how I get it to do the same thing. It's kind of oscillating like clockwise. I have it a little over torqued, and so it's starting to counter rotate or auto rotate. And then as I adjust the frequency of the Tesla coil and bring things kind of in resonance there, the eddy current has changed. And so now the whole thing starts to counter rotate from that auto rotation. So the Tesla coil alone is enough to affect that eddy current in the center, which affects the reactionary forces of those spinning motors.
Also on the bottom disc, you could see it when it's uneven and it starts wobbling a little bit. It affects the whole lift of it. As it goes up and down just a little bit, you'll see the wobble change on the bottom. So that bottom disc has a lot more to do with it than you think. There's a pulse rate there. It's running so slow that the pulse rate in there, you can sit there and take a fluorescent lamp and put it next to it, and you can see the pulse rate. So it changes how it's actually in that bubble as well.
Okay. And I think we may run over just a little bit in terms of time here. Actually, what I'm going to do is call John Brandenburg, because he had a presentation also. What I have is I have an 1.5-hour video from Tom Valone, and so it's kind of an odd period. And Tom may actually show up in the studio. So let me mute myself out really quick. I'm going to give John a call and see if he wants to hop on, because he has a presentation also today. So let me do that.
This next Graviflyer clip is also a really good one. As soon as we see him start testing it on his garage floor there, on this one, he gets it to, instead of lift, it just tips over. And I think that also tells you a lot about what's going on with this thing. The two spinning discs are perfectly aligned above and below each other. And those magnets on those discs creates that eddy current in the center disc. And because they're kind of spaced far apart from it, the thickness, the width of that thin eddy current ring, if you offset the centering of those two discs, you kind of offset the above and below eddy current rings. And so now you have, instead of a linear lifting force, it's kind of offset, and so it kind of tips over. In Alexi's first Zoom call with us, that's what ended up happening. Was he had just finished building a new one to show us, and he hadn't tuned it or anything yet. He hadn't tested it even yet. And so those discs, I think they were slightly off-centered from each other. And so it does this tip over thing. So in this video, we'll see it do the tip over. But the part that I want you to look at is the feet, the bottom of those vertical rods where it's touching the ground. At the moment, it's only like 2 or 3 frames, but at the moment that it does that tip over, you'll see arcing occur. And that arcing is showing how all of the voltage from the Tesla coil and everything is going straight to the concrete floor ground.
Okay. And yeah, I just tried John. He's not picking up, but it's still early his time. So, if I could offer a quick thought on this, the Graviflyer is, in many ways, the Graviflyer is almost what you call like a stereotypical device in our community, right? And I think that's one of the things that makes it so challenging is, you start with a claim, you start with some videos, you start with trying to decipher what may or may not be happening. A lot of times, many times, the inventor has their own scientific model. And even if they don't, you've got 20 or 30 different people trying to apply that to whatever scientific model they're trying to sell for the day, right? And so when you get into stuff like the Graviflyer, this is a really good kind of primer for the experimental side of this, because you've got people all over the world who are building these devices, trying to overcome gravity, trying to build unique flying devices. It's something that, people get bit by the bug and they just can't let go of it. And a lot of that ends up as myth and legend floating around, right? And so I really want to hand it to the Graviflyer team for digging in and trying to decipher this, because that's what it really comes down to. I think it's not only scientific and engineering work, but it's also good detective work, right? And that's a big part of what you guys are doing.
Yeah, for everybody who does it, it changes how they look at things.
All right,
Yeah,
there
right.
it was.
There,
There
yeah,
was the
right there.
sparks. Also, I see people in the chat trying to say that the spacings of the discs is offset by phi or theta or something. No, it's root 2. And all of the spacings that he's provided for all the different Graviflyers he's made, it's like 0.65 or 0.71 is the ratios. It's 1 over root 2. 18 and 28 millimeters, or I think it was like 23 and 31 millimeters or something like that. Like
I see Bob Lazar in chat, but I'm not sure if it's the Bob Lazar or if it's
Definitely Troll Lazar. And Magnet Street TO starting one today. We've inspired another one and wants to be added to the community by all means.
Yeah, well, so we have a mailing list on the altpropulsion.com website. It's altpropulsion.com. Maybe I should give people kind of a bird's eye view. Again, we have a lot of new folks. This conference started, let me see if is our video still playing? Yeah. So the Alternative Propulsion Engineering Conference, or APEC, started in November 2020, I think, 2021, something like that. During the height of the pandemic, basically Jim Woodward did an Estes Park conference earlier that year. Mark Sokol and Jeremiah Pop and Jeremy Reese had been interested in that. They weren't able to present at that, but when they watched it, what was different there was, because of the pandemic, Jim Woodward took it online. And so when they were watching it online, they realized, you know what, we could do something like this that's larger and more inclusive. So they tracked me down because I had done American Anti-Gravity, and they said, we want you to moderate this for us. And I naively said at the time, I said, well, we're all going to die anyways. It's the middle of the pandemic. Why not? How many of these can we get done? So, we're pushing 60 of them now. And
it's getting to 600 before it's all said and done, Tim. You're simply the best, and APEC needs you.
Well, thank you. It's not an ego thing for me. I'm trying to do my best to serve you guys and try and present your ideas. And what excites me about it is the process of innovation. So, but that's kind of where our community came from. So we've kept things really loose and really open, but that probably means there are more bumps along the road for us than other presentations. But at the same time, we try and keep things very egalitarian and flat. It's not a big hierarchy, the whole 9 yards. So it's always a balancing act.
Right, I think part of the thing that makes Alexei so his setup so awesome to watch is that welder's helmet that he's covered in foil to make it look like a spaceman helmet for all of his tests. If you get too close to the RF coming off the Tesla coil off that Graviflyer, you start getting those RF headaches. And he started observing that, so he started wearing the helmet. And he actually has a wire going down to the ground so that he's grounding that helmet.
I've had a headache for 2 days now from that.
Is that from Mark Sokol said something about the wavelength matching the length of the optical nerve in the brain?
The diameter of your skull. It can start interacting with that, and the water inside your head starts vibrating. You're basically microwaving your brain. You got about, depending on the strength, usually got about 30 to 40 minutes before you start getting the headache. Except in Nathan's case, where it was so strong, it was like 30 seconds.
Okay, so that's our disclaimer. Do not microwave your brain.
Yeah.
I shouldn't have to say that.
On that note, you can buy these silver infused nightcaps on Amazon that are for RF shielding. If you guys want to be safe, they're about $50 or $60. I would recommend.
Yeah.
Although in our community, why not just do the full Monty and wear a tinfoil hat? You know, I mean, that's essentially what he's doing.
Well, that's what I'm getting at. Then, like, is this actually kind of showing that tinfoil hats really have a use of blocking harmful EM going to your head, and that potentially they've mocked them this entire time when it could be, you know, applied against us?
It only works for if the it's thick enough and if it's grounded. So
Yeah, I
if
was
it's
gonna
really
say it has
thin
to be
tinfoil,
grounded.
it doesn't work, and if it's not grounded, it doesn't work. So most of the people using it are using it wrong.
What
And
if
Look
it
at
was
that. It's going to
gold?
shock you. It's going to shock you when it does it. So
This
you're going to get
opens
this
up-
thing on your head, and it's going to start zapping you, and you think your hair is on fire.
This opens up a brand new market, you know, and different style variations too, right? I'm thinking like a little pirate hat. You can make those out of tinfoil.
Oh yeah.
Okay. So yeah, we're doing pretty good with this. And I have not, let me see. I have not heard back from John, but we're about an hour. So guys, if you want, why don't I shut this
Good
down?
question. Where does APEC get its funding? There's zero funding as far as I'm aware, right? Like everybody's just volunteering their time.
Yeah, but I mean the stuff that we do is cheap. So that, you know, I mean, StreamYard is I just pay for StreamYard out of pocket. So, you know, it's one of those
So if
things.
anyone wants to donate to Tim or Jeremy or anyone running their labs here, it is all out of pocket. So that just to let you know.
Don't donate to me. I donate to the guys building stuff. That I mean, they're doing the work. Okay, so why don't I do this? Why don't I stop sharing? And if you guys are open to it, you want me to do Tom Valone's thing? Okay, so it's probably about an hour or so, and we'll wait for John. So again, everybody, please put your hands together. Again, one more time for Nathan Bunten, Old Man Builds. And Nathan, now that you've been on, you got to come back on in the future, man.
Absolutely.
Okay. So let me take everybody out of the studio here. And let me see if I can pull this off effectively. There we go. Okay. And I guess you guys let me know in chat if there's no sound. We'll see if this thing goofs, we'll stop it. Okay, so this is a presentation. Tom Valone sent this to me by email. So again, his schedule, he was going to be here in person, at least for Q&A. Unfortunately, he's not able to because we had to push things back a week. So I am going to share my screen. Tom Valone mega presentation. Okay. Chat if you can't hear or if you have any issues with it.
Welcome back, everybody. Our next presenter is Dr. Tom Valone. He's a truly very special man. I've had the honor of knowing Tom now for several decades and following his work. He is a hard PhD scientist for sure, no question. But his heart is in everything ufological. And in looking at the mystery of everything ufological, his interest focuses on free energy or zero-point energy, if you prefer. How do they get from there to here? He's been working on these questions diligently for decades. He formed the Integrity Research Institute, which is a wonderful organization, and he uses it to disseminate all of the latest scientific information about those deep questions. And if it's solved, or when it's solved. I'll take the positive approach. I suspect Tom Valone may be one of the people that helps that to happen. He's here with us today to talk about something truly extraordinary. He has done the work. He has come up with a truly college level, accreditable course curricula for university study of ufology and astrosociology. This is going to be a wonderful presentation. It is the future right here with us today. Please welcome Dr. Tom Valone.
Thank you, Bob. Thank you, everyone. I'm glad to be here. Thank you for the wonderful introduction. And yes, since I used to teach college, community college for years, I'm familiar with the layout of a 13-chapter textbook and the format that's important for addressing students that basically are in the college level, but you aim it toward the last year senior level high school. And right now, I can't find a ufology textbook anywhere online. So I don't think the academic publishers have done their job. Ufologists themselves, I've talked to all of them, they don't seem to work in that direction. But let's begin, and you can see what the slideshow is all about. I hope they'll actually put the slideshow up on the screen shortly, and then we can let you know what the 13 chapters will be like. And that's basically what I'd like to present to you tonight, or today, is the outline of 13 topics. And each chapter will basically summarize events that I felt were the most documentable, the most credible, and having takeaway evidence that can't be contravened. And academics, as you will see from some of my slides, have the habit of denying everything. Their contrarianism is their way of life. They live in ivory towers. And so we're trying to address the most believable and interesting and credible evidence for this science. And that's what you people know are really a science of UFOs and ETs. So what you're seeing in the background here, which I did not include in the book, but I thought I'd show at least one image, is Paul Potter's wonderful drawings. And in fact, if you're interested, the gravitational manipulation of domed craft, UFO dynamics, oops, hopefully you'll see that cursor pointing around in the corner there, and there we go. That's the name of his book. It's a big, thick 500-pager, and it's an excellent rendition of the Andreasen affair. He interviewed the Betty Ann Andreasen for quite a long time before he rendered the images of the craft that she was on. So this does justice to really the physics of that. And he contributed one of the papers to our 10 years of Conference on Future Energy. So he'll be in print shortly as well. We know there's lots of galaxies out there. Let's instead concentrate on our own Milky Way galaxy for now. And this is important because right within our galactic orientation, and I'm starting chapter 1 for you guys to give you an overview of how this book should probably introduce the topic gradually and convincingly as well. Why a ufology book? Why a textbook on this strange, unusual, forbidden topic that no one believes? Well, first of all, our Earth is one of the younger galactic spiral arms, and you'll see what's labeled the sun here. It's in the Orion spur of our spiral galaxy, about midway, about 23,000 light years from the core, which is our Sagittarius black hole, as you guys know. And what's interesting is that there are older stars and there are younger stars a lot closer than you would imagine. The inner spiral arms tend to be older, and if you stretch your imagination that these older stars could be a few billion years older, then just think about it. If a star has planets, which most of them do now, astronomers now agree that 90% of them have planets around, so the Goldilocks zone is probably a good percentage of those, then civilizations that have grown up a billion years earlier than we have certainly must have developed warp drive. And of course, that means lots of UFOs visiting us. Well, luckily, I came across, after thinking this far for years, and so does a colleague of mine, Paul Murad. I'll show you his little email that just came about a couple weeks ago. They all think the same way, but then you stop because apparently there hasn't been any proof. Well, guess what? Astronomer Paula Jeffrey actually published in 2018 an article called Mapping Stars Across Generations. And what this map does is like a generic genealogy tree. And if you look for where our sun is, number 14, all the ones to the right are younger stars. Our sun is 4.5 billion years old. The universe is over 13 billion years old. So you can imagine, we're sort of the younger ones. And this genealogy tree proves it. Every star to the right are younger, 3 billion, 2 billion. 21 is about less than, it's about 0.7 billion. You can go online, and I'll show you the next page where you can, sciencenews.org, find all of these stars, their names, and look them up. However, if we go to the blue tree branch, guess what? Number 4 is only 11 light years from the sun. Well, most of you already know that Alpha Centauri and Proxima Centauri are about 4 light years from us. They're the closest stars. So 4 light years away is, hey, next door. You can fall over and bump into them, astronomically speaking. Well, if you go to 11 light years, that's only about twice as much, 3 times as much. So this is our local neighborhood, and already number 4 at 11 light years away is much older. And in fact, they're called middle-aged stars. They're between 7 and 8 billion years old. We're 4.5, they're 7 and 8. And it's only 11 light years away. So if they have warp drive and they're traveling to the nearest neighbors, which we are, then of course they've had lots of billion years, at least 3 billion years to work on their warp drive. And of course you can go further down. Guess what? Number 1, farthest away on this whole tree is 13 light years away. So this whole map is still within our local neighborhood of up to 15, 20 light years from Earth. So this is good news if you're into UFOs, which I presume you guys are, right? Yeah. Yay, okay, thanks for the response. And this is the last page of her articles in Science News, sciencenews.org. I just did it for you guys, so in case you wanted to look it up, in case you're taking notes, forgive me, I used to teach college. And of course, her quote, which is a takeaway, we could use these trees to learn something about the evolution of our whole galaxy. Wow, what a project that would be for a grad student. And there's all the names of them down here as well. Okay, well, why are we doing this? This is chapter 1, so I'm still introducing that question. Why bother with a ufology textbook? Well, guess who's in charge of the SETI Institute, Search for Extraterrestrial Intelligence, in case you don't know what SETI stands for. Guess what her quote says just in January of this year, a month ago? Although the search for extraterrestrial intelligence has drawn a blank so far, we are getting better at it all the time. Gee whiz, I'm so excited I can keep my job. But I'm still searching, I'm looking. Where's the ETs? I've been at it for years, can't find a single one. And of course, she just published a book, Jill Tarter and the Search for Extraterrestrial Intelligence. Well, we don't find any intelligence searching for it, so how can you find it out there? Ivory Tower professors, my God. I think they need a university textbook. And guess what she just did last month? 2 weeks ago, February 15th. She's at the AAAS meeting, Association for the Advancement of Science. When is the evidence sufficient to claim the discovery of extraterrestrial life? Gee, I don't know. What if ET came up to you? Would you think that's enough evidence? What if a UFO flew over your little ivory tower? Well, her little abstract says, are there likely to be any smoking guns at all? If future discoveries are nuanced or contain many caveats, How do we prepare for public disclosure and education? I'm glad she's thinking. At least she's thinking about it. But we have other people like her. Here's Stephen Webb. If the universe is teeming with aliens, where is everybody? Oh, he's got 75 solutions to the Fermi paradox and the problem of extraterrestrial life, though. He's sat in his office and thought about 75 solutions to the problem of ETs. Okay, and what is the Fermi paradox? Because I didn't even know. I had to go look it up. I should know it because I'm a physicist. Enrico Fermi thought of this big, huge paradox. The apparent contradiction, this is definition, by the way, from Wikipedia. The apparent contradiction between the lack of evidence for ETs and the various high estimates for their probability. Duh. That's a real contradiction. We can't see any, we don't see them flying over our office. So apparently it's a big contradiction. But he invented 75 solutions. So, and Springer Publishers did it. I really admire Springer because they're really academic, but this was over the top, I think, in terms of egghead type solutions. Oh, and then this guy, he was my favorite up till this alien book came out. I actually had one of his biophysics books, and I really liked it. I read the whole thing. I really learned a lot from it. Dr. Al-Khalili is a famous biophysicist. But then he gets together an anthology of various scientists, all of whom are skeptics. And his first cover is on the left side here with little subtitles and top titles. The truth is in here about aliens. And science asks, is anyone out there? And you even put green edges on the pages too. Okay, so now we get to the meat of things. Introductory ufology and astrosociology. I've attended lectures on astrosociology. This is a big word for academic study of
Tim, you got to hit play. Tim, Earth to Tim. It is dead air. We cannot hear Tom. His presentation is paused. Please bear with us while we get through this technical difficulty, ladies and gentlemen. All right, guys, I'm just going to... right. Well,
We should just have a discussion until Tim comes back, as he is currently missing.
we're gonna hijack this this intermission, even though as much as we're enjoying that little ditty.
I tried calling Tim. He's not picking up. The feds,
Yeah.
like everyone's saying, the feds got him. He was abducted.
Yeah, it's either the aliens or the FBI. So, hey, well, there he is.
Hey.
Oh, you're back. There we go. So
There we
Oh,
go.
sorry about that. Sorry about that. Did I screw something up?
it paused.
I don't know.
on its
Somehow
own
it
or
just
something happened.
went from play to pause.
Oh, I'm sorry about that. Okay, yeah.
No worries.
Well, let me start replaying again.
Cat must have stepped on the space
Potential
bar.
possibility that some way in the future we might meet an ET or see a
Okay.
UFO. And how do we interact?
Here, let me take
That's
everybody
what
back out.
academia wants. And I even asked the professor who was leading one of the graduate students who presented, what about UFOs? Do you include any UFO? No, of course not. We don't deal with those pseudoscience topics. You know? Okay, so back to the format we're following. You're going to see 12 left, 12 different topics. Recent Navy disclosures, Battle of Los Angeles, Bentwaters and Rendlesham Forest, Roswell, Betty Hill, Prop Circles, Billy Meyer, Bob Lazar, Electrogravitics, which I have 2 books on, Panspermia, Van Tassel, and of course the concluding topic to ask a few questions about it. And essentially it's the best UFO stories and end of chapter questions. They're well documented, convincing evidence and so forth. Okay, you ready? It's going to be kind of disjointed, so I apologize for the fact I'll introduce one topic and then immediately go to the next. So what are my credentials? Well, I was at the citizens hearing in 2013, and it was really well organized by Stephen Bassett, National Press Club, Washington, D.C., and I gave my UFO testimony limited to 10 minutes. So you guys are getting a treat because here's the entire 10 minutes. I'd like to start with my slides and show them exclusively as I go through them. What I'm about to say is my own personal viewpoint, does not relate in any way to the federal government. Nothing I'm stating is reflecting government policy, and they're my original thoughts as a private citizen. Next slide. This is a presentation of what I'm familiar with, and the beginning of my journey was back in. I think I just my microphone.
So we could hear you better. Thank you.
My journey began in 1980 with the book called Sunburst: Return of the Ancients by Norman Paulson. And the book was fascinating in the fact that there were a lot of very anomalous UFO details shown. This particular side-by-side photo, and the person who took the photo was a deputy sheriff holding the Instamatic photo taken in broad daylight over Giant Rock. This is fascinating because none of this has happened since then, and Van Tassel, George Van Tassel, was responsible for holding UFO conferences through the 50s and through the 60s. I even talked to Dr. Bob Beck, who witnessed one of these craft. And as you can see, there's some type of force illumination below the craft as well. So I went out to the community and found what they were working on was a homopolar generator. Next slide. The interesting part of the book described the propulsion system as being 12 magnets around the outer edge of a very large disk, size of the ship, carrying off electrical current. 2 disks in opposite direction provided the gravity force, whatever propulsion system they had. So this particular passage I reprinted in my homopolar handbook. Next slide. And also convinced my professor at the State University of New York at Buffalo to let me work on it as a physics project for my master's degree in physics. And I was very pleased to actually build a homopolar generator, test it for back torque, and unfortunately I measured back torque, which means it slows down as you draw current from it. So the mystery continued. Next slide. I basically found that Dr. Ed Mitchell, as you see here on the cover of Extraordinary Science magazine, was also interested in the same topic. Bruce De Palma was the source of the interest, and he was building homopolar generators like crazy, looking for investors one after another, which he succeeded in doing. However, Ed held on to his money, which is in his breast pocket there. And what was interesting about this particular cover that came out years later was that the Searle disc is also shown on the same magazine cover next to the homopolar. So I thought this was sort of a coincidence or synchronicity, and I ended up investigating the Searle disc. Next slide. And I met John Searle in 1980 in Germany, and he actually became kind of a curiosity to me. Even today, he still is. He's still a living legend. He claimed to have these discs, as you can see here, hovering, and he had a UFO experience when he was young, and then he started building these things. So next slide. I basically tried to help him, connected with different people. He essentially became a little more well-known when he gave a talk in Berlin in 1990. And then some Russians discovered him because of that lecture in the video and decided to build what they described as a single roller magnet assembly with 12 roller magnets around the outer edge of a ring. And so I started to think twice that, hey, this may be something related to what was called the Mu disk back in the Paulson book. And that's one of the biographies you can get off the shelf, Anti-Gravity, The Dream Made Reality by John Thomas. Next slide. So the long story short is that these roller magnets are individual homopolar generators, and they definitely seem to lend itself to voltage generation if the whole ring could somehow be propelled. And that's the magic and the mystery behind the whole thing. Well, the Russians had a whole grocery list, as you can see on the right, of all these anomalies that they supposedly measured. And so what I ended up doing, next slide, was to connect them to an investor, which I constantly do throughout these years, find an investor for the strange inventors, put them together. In this case, we went to the Department of Energy. The contact was very friendly to us, offered a Russian translator for us. We did due diligence for the whole day, and the investor was comfortable to throw his money at the Russian golden roast inventions. And the outcome was, next slide, the big prototype that cost a lot of money, which was built and completed in Moscow. And then it was retrofitted and completed again and again. And even to this day, it doesn't quite do what it's supposed to do, but it certainly looks interesting. Next slide. So back to the George Van Tassel story, since this is dealing with implications of extraterrestrial technology, George's story is that he had lots of UFO experiences, even rides on craft and so forth. And his, would you say his download or his conclusion from all of these experiences was, hey, I'm going to build a healing chamber, a rejuvenation chamber, called the Integratron. And it's right near Giant Rock. I've actually gone out there. Next slide. And it still is in existence today, Integratron.com. And it's all wood construction with no nails. Next slide. And it's very fascinating because it has these unusual die rods. The whole assembly of die rods was supposed to rotate. And it also has a primary and secondary coil inside that looks like an inverted Tesla coil. So you get the impression that it would draw atmospheric electricity. Since it's very dry there, it's feasible this would work, and then charge up the inside with some of this energy. Next slide. So that concludes the possible rejuvenation implications of ET contact. And what I'd like to conclude with is the zero-point energy, inertial shielding, and electrogravitics. Next slide. First of all, zero-point energy is very famous. I wrote a book on it. I wrote 2 books, actually, and it's been confirmed consistently even up to last week, where our Future Energy News announced some new polymer pyrrole that actually can't be explained unless 2/3 of it is due to zero-point energy. Next slide. And here we have the reason why zero-point energy may be important. And we'll see if she can insert the 30-second video that's supposed to actually start. There's Roger Lear next to me.
Sure, we're going to get a video
behind me. But, oh, maybe. Okay. Yes. Okay, this is an example of many. You've probably seen some of these already. The craft is spinning. It's up close. It looks like a legitimate, authentic video, amateur video. And right about now, you're going to see a very fast acceleration. And that's what we've been talking about, folks. Let's go back to the slides. The G-forces on that would be incredible. Let's go back to our slideshow if we can. And the important part is that this introduces a concept which I like to share with the panel, and that is inertia is involved. And as we get to the next slide, hopefully we can see that. Inertial mass and gravitational mass are totally different. I repeat myself, inertial mass and gravitational mass have nothing to do with each other. Einstein made a mistake years ago and called it the equivalence principle. I studied it even in grad school. I took relativity and I took general relativity. And so it's fascinating to me that it's sort of overlooked. Slide right after this. And the important part is that nowadays, inertia has been discovered to be a zero-point field Lorentz force by Hayes, Wetter, and Puthoff. This is a seminal paper that's so important that it opens the door to actually controlling inertia and understanding how any ET craft or UFOs could possibly have fast acceleration, right-angle turns, and maybe even travel through the universe. It turns out F equals V cross B, a simple Lorentz force at the bottom of the slide there showing how it works. So when we go around a curve and you feel that force moving you in the opposite direction, it's an electromagnetic interaction. Next slide. And this applies to relativity. I heard one of the gentlemen on the panel questioning special relativity. Well, that's inertial mass. That is the M in relativistic increase in mass as you go toward the speed of light. If you can shield inertial mass, miracles happen. And this is another demonstration. I showed this slide to the deputy director of the NRO, National Reconnaissance Office, in case you don't know what NRO stands for. And this was very important because, as you see, F equals ma, Newton's law can be modified. If M can be shielded and it lowers, then A could increase for the same amount of force. Next slide. Oh, and by the way, the NRO deputy director said, well, things like this tend to become more and more classified until they're out of sight. He says it's easier for us to reinvent it for a private contractor. And I said, you mean the taxpayers have to pay double for something like this? And he said, yes. So here's another proof of inertial shielding, and that is the right angle turn. That's photographed here with open shutter, 35 millimeter on tripod, 2 a.m. outside Stewart Air Force Base. The triangle craft started from the upper part and the shutter was open, made a tremendous right turn, then continued as if nothing happened. Red and green lights make it look like it's conventional. Next slide.
And Dr. Valone, you've got about 1 minute.
I understand, I see. And now the conclusion is electrokinetic equation helps explain how we can combine electrokinetics or electrogravitics and inertial shielding. A pulsed current will produce a force. Next slide. And I wrote a book on the electrogravitics effect that's even present in the B-2 bomber, thanks to Paula Violette's work and research, and originally starting with Townsend Brown's research. Next slide. And the conclusion is, and I have to give thanks to Mark McCandlish, who gave a testimony at Dr. Greer's 2001 disclosure project in DC, since we know once in a while such electrokinetic powered craft are put on display, as this one was in 1988 in Norton Air Force Base, which is also his entire testimony is reproduced thanks to Mark in my book Electrovitics 2. And this is also verified and investigated by Dr. Al Puthoff. And I talked to him personally about this story of Norton Air Force Base showing 3 hovercraft, and he did his due diligence with it, and he says he put it in his gray box of possible events. Thank you.
Thank you very much.
So there you go. That's the entire summary of my talk. You can go home now. But that was my introduction to kind of summarize, where I was in 1980 and how I got here 30 years later in 2013. Well, now let's go to chapter 2 and what has happened since then. And to give me more perspective to be able to write a textbook. Well, recent Navy disclosure, which was 2004, Navy USS Nimitz, finally disclosed over 10 years later that, yeah, they have a UFO and sort of looked like a Tic Tac. It was kind of round and did weird things. Well, more than that, it turns out, just recently, in the past few months and in the past year, they've now admitted there's been a lot of them. A lot more than just one. So this is kind of exciting. As I researched it, I found, oh yeah, 2007, 2008, the thing was going through the water, and it was similar afterwards to the Tic Tac that was captured on film. That was January, just last month. And then this other Aerospace America, which I happen to have here with you, with us, I'll show you a cover of it as well. It talks about the unidentified gauzy blobs, which obviously these pictures look a little bit different than the Tic Tac. So I was confused at first, but now I see that that was 2014, 2015, where the Navy FA-18s were chasing after something different. But they're all doing the same thing, flying around really quick, making right-angle turns and fast acceleration. So one of the reports that you see online is basically this lasted for several days in 2004. It wasn't just one event. However, it was solid white, no edges, looked like a tic-tac, 46 feet long, and guess what? The jet is 56 feet long. So their conclusion, the Navy says, the Navy admits it could feasibly hold more than one human-sized individuals. Oh my God, he's actually talking about ETs. I'm shocked. This is a government agency. Yeah, it's great. I used to work for the government. Thank God I retired. Okay, moving right on. Here's the cover of the magazine I just showed you, and it's November 2019. I was so pleased to see this, I thought, oh, let me order a whole bunch for our members. Our institute has members, in case you want to join, integrity-research.org. November 2019, if you read the whole article though, guess what? They tell you everything it can't be. Oh, I don't think it's a UFO. I don't think it's from ET. I don't think it's from another planet. Oh, it couldn't be weather balloons. It couldn't be this, couldn't be that. And it ends the article with all these denials. So I'm a member of AIA, American Institute of Aeronautics and Astronautics. Okay, so here's the real summary of the best video I found, 5 minutes summarizing the Tic Tac by the jet pilot. So, and you've seen a lot of this. Well, you can also go to the website strider21.com, and as you can see, he's got tons of information, lots of little videos and links to all of it. And also, this guy also did a great job of summarizing what he thinks are the best UFO stories, even though some of them don't have a lot of information. So what I thought was interesting is just a few weeks ago, about a month ago, I heard National Public Radio give Marion Rudnick a little interview. Turns out he was a NASA astronomer, and he worked for NASA for over 10 years. And under his floorboards, he finds canisters of the original Gemini photo film rolls. You wonder, what the heck are they doing there? Well, he asks his coworkers, and they come over and they say, well, these are the originals. And then as they look, they see deleted frames. And the deleted frames turned out to be, because this other coworker had the list, oh, frame number 25, from 32, those are all the UFO pictures we took out. And they recreated new film rolls with all of them together, so it looks like, oh, we didn't touch anything, and then stashed the originals under his floorboard. And of course, he had to hand them over, and even his boss, his managers, called him up. Did you hand over those canisters? And he said, yes, sir. And so that was the end of that story. Well, it turns out, beyond that, he went into Walt Disney Studios, he gave up on NASA, and he ended up finding an original jet plane video that had this annoying picture of a white orb just, bothering the jet plane and taking off and rapidly approaching the jet, pacing it, and then took off with bursts of speed. And he says, I was part of a cover-up. I had to delete the pictures of the UFO from this video so they would have an historic record of this original jet plane, U.S. Air Force. So he felt really bad about that. That was 2000. And then 2017, he said this was the icing on the cake. 4 UFOs show up right in his hometown, Monrovia, California, and then he starts getting harassed by sabotage. His website, by the way, is rudnick.com. It's really worth checking out and visiting. And here's some pictures from his book. And these are also online. So these are the 4 pictures he took, 4 UFO images. He enlarged them here. He said 4 was a little bit slower than the rest. He thought it was disabled. That's number 4 here. It looks a little bit different colors. Pretty cool stuff. And here's another one. And the reason I included this right after the Navy one is, guess what? Here's the Tic Tac. It moved into position right near this plane, started following the plane, and there's the image, and here's his drawing of the Tic Tac. And what you see back in the Navy image is it looks like there's little points on the bottom and top of the Tic Tac. Well, it turns out from Rudnick's drawing, it's some kind of ring around the center of it. And that's why it looks like it's not quite an oblong Tic Tac. Anyways, that's the story of Rudnick, except for the helicopters that showed up over his house. And the MIBs, the Men in Black he calls them, that showed up disabling his car every so often. You know, kind of, and this is 2019, folks. This isn't decades ago. This is like Men in Black are still operating. I can't believe it. He couldn't believe it. That's why he included pictures of the black helicopters over his house. And he said, I used to be a government worker. Okay, enough of that story. Now we move into chapter 3, and guess what? I have another video for you. And in case you haven't heard of the Battle of Los Angeles, I mean, how many people? Any? Yeah, a few people. Good, good. Okay. Well, here you go, a 4-minute summary, the best video on this topic. And I find this fascinating because this is historically true, and yet very few people.
As America was gathering its senses after the shocking attack on Pearl Harbor in December 1941 and the subsequent declaration of war, there was a heightened feeling of insecurity and anxiousness throughout the whole country. The skies were being watched like never before as a giant UFO was spotted moving through California, alerting the military and civilian watchers as well. This case became known as the Battle of Los Angeles and is one of the most important cases of ufology of all time.
And now for news of our own West Coast, we take you to Los Angeles and the report of Byron Palmer. Anti-aircraft guns went into action against unidentified aircraft in the Los Angeles area shortly after 3 a.m. Pacific wartime this morning. The anti-aircraft guns began barking during a blackout ordered by the 4th Interceptor Command at 2:25 a.m. The unidentified object, which some sources thought might be a blimp, moved slowly down the Pacific coast from Santa Monica and disappeared south of Long Beach.
On the morning of February 25, 1942, pandemonium erupted in a hail of anti-aircraft fire. Air raid sirens sounded throughout Los Angeles County on that crazy morning of February 1942. At 3:16 a.m., the 37th Coast Artillery Brigade began firing 50 caliber machine guns and 12.8-pound anti-aircraft shells into the air at an unidentified object hovering in the sky. Over 1,400 shells would eventually be fired from a defending county that were convinced this was an invasion. Pilots of the 4th Interceptor Command were alerted. The artillery fire continued sporadically until 4:14 a.m. when the UFO suddenly vanished. The Air Force searched but found no signs of the flying object, and the all clear was sounded at 7:21 a.m. after the Secretary of the Navy, Frank Knox, amazingly played down the event, even suggesting it was a weather balloon. None of the shells hit the UFO. In one picture of the event, it shows there was a type of defense shield where the bullets and shells simply hit with no damage being done.
Shells frequently could be seen bursting near the object, but none appeared to hit it.
This caused major damage to surrounding buildings, and people were killed as a direct result of falling debris and shrapnel, many suffering from hearing problems after the hour-long bombardment. A photo published in the Los Angeles Times on February 26, 1942 has been cited by modern-day ufologists as evidence of an extraterrestrial visitation. They assert that the photo clearly shows searchlights focused on an alien spaceship and explosions that were from anti-aircraft guns exploding to no avail. The first news of the attack led to the dispatch of pursuit planes to the area, and subsequently 3 bombers joined the attempt to destroy the raider, but without success. According to newspaper reports, eyewitnesses described the sight of the UFO like a surreal hanging magic lantern. One air raid warden describes the event. They sent fighter planes up and I watched them in groups approach it and then turn away. They were shooting at it, but it didn't seem to matter. It was like the 4th of July, but much louder. They were firing like crazy, but they couldn't touch it. This was an extremely important event, and one that should not be forgotten. Only the news of World War II kept this from becoming a major news event, and possibly the mind of Ronald Reagan when he delivered a stunning speech at the United Nations.
In our obsession with antagonisms of the moment, we often forget how much unites all the members of humanity. Perhaps we need some outside universal threat to make us recognize this common bond. I occasionally think how quickly our differences worldwide would vanish if we were facing an alien threat from outside this world. And yet, I ask you, is not an alien force already among us?
What do you guys think of the Battle of Los Angeles incident? Thanks for watching, and remember, the ways at which we arrive at knowledge are hardly less wonderful than the discovery of these things.
So I'm going to skip through some of these because I have more videos and I want to be sure to finish it all. Some of you probably already know about Bentwaters and Rendlesham Forest. James Pennison is famous for that. The long binary code was the takeaway. That was the interesting part of this whole adventure. He actually touched the craft. And here's his notebook on the right-hand side, with zeros and ones that for years he didn't know what to do with. He was embarrassed to even have downloaded that stuff from his event. And on the left is a memo from his commanding officer, deputy base commander, who admitted seeing the craft with landing legs, animals screeching and running away nearby, and a Geiger counter the next day that proved it was something weird that landed there. Well, here's the binary code decoded from ASCII binary, and it is probably the most unusual, strange message I've ever seen for the few that are available from translated binary. Some of them obviously are in English, exploration of humanity. It starts off with longitude, longitude. Who knows what continuous for planetary advance means? And then the rest of it is pretty obscure, more longitude, latitude coordinates, which were Giza Pyramid and Nazca Plain coordinates. And then who knows what eyes of your eyes mean. But you can go to binarydecoder.info if you want more detail. So this is something that has that capability of, evidence, documented, credible witnesses. A lot of you know about Roswell, July 8th, 1947. Well, the next headlines the very next day was General Ramey was emptying the Roswell saucer. Hey, that's pretty convincing. Maybe it was really a saucer. No, of course not. We're now looking at a cover story. This is what we got from the saucer. Right. Aluminum foil. However, years later, literally just a few years ago, 50 years later, say, or more, somebody decided to use some digital enhancement and say, what's that piece of paper that General Ramsey's holding in his hand? Well, let's go ahead and enlarge it and enhance it and see, oh, wow. Line 2 and 3 say something about, it's a teletype message, obviously, victims of the wreck, and the disk will be shipped. And then here's the rest of the lines on that piece of paper. Visitors in the disk will be shipped, the 8th Army, whatever, B-29 or C-47, Wright Air Force Base, Wright-Patterson Air Force Base, Airfoil or Roswell. And then the misstatement, this is interesting. Misstate the meaning of the story, send out the PR weather balloons, and photos are taken. That sounds good. Here's Ramey, and here's the top secret seal of approval. Very interesting. It's hard to deny that, but hey, we got a 3 year later in 1950 from Guy Hotel from Strategic Air Command in Washington to the FBI director saying, yeah, well, 3 years ago we had the investigator, 3 so-called flying saucers recovered. They were described as being circular approximately. Each one was occupied by 3 bodies of human shape, but they're only 3 feet tall, dressed in metallic cloth, bandage, and guess what? This is the interesting disclosure. Our radar apparently interfered with the craft and the controlling mechanism causing it to crash. So I found that very interesting because now we sort of know the mechanism that interacts with the electrogravitics that causes propulsion. Excuse me. Now, the interesting takeaway here too is the day after Roswell. I give my 100% endorsement for this book. Philip Corso suffered a lot of harassment and criticism for it, but if you do the research, the main points of the book within 1 year of IC micromineralization, semiconductor laser diode, fiber optics, this was his job. General Trudeau told him, you begin calling your scientist friends, make whatever appointments you want. He was given the 4-drawer file cabinet from Roswell, rolled it into his office, and he was told to disseminate the information, which he did. That's what the whole book's about. I went to DuPont, I went to Bell Telephone Labs, I went to GE Labs. You know, this is a fascinating book, and you can do the research and see, oh yeah, well the invention came out a year after Corso says he was meeting with that company, repeatedly. So to me, that's the way things should be going on with all of these technological discoveries from back-engineered craft. Moving right along to chapter 6, we have the Betty Hill story. How many people know about the star map? A few of you? Great. Okay. Well, here's a quick summary. The handwritten diagram is here to the right. That only came out years later after she was hypnotized. And she basically describes the fact that she saw the star map really big on the craft. They were grazed, by the way, which is interesting because she had this interaction with them. We actually sell the reprint of the astronomy magazine in the bookstore if you want one. I highly recommend it. It's such a fascinating astronomy magazine description of the event with lots of color. The whole thing's in color, by the way. And it describes, besides these two books that you see on either side here, the actual analysis of the stars. All the stars in the star map are the only solar mass-sized stars within 50 light years of Earth. And the astronomers in the astronomy magazine say 50 light years is our local neighborhood. So remember back when I talked about 11 light years and then 20 light years, that's small stuff compared to 50. But within 50, these are the only stars that are the size of our sun, which is a medium size, almost a small star. And the only ones give you the impression that maybe these will be Goldilocks type capable. And there's a newspaper, Betty and Barney, holding the headlines after their event. This is the actual star map rendered with all the light years between them. There's our sun, there's Zeta Reticuli 1 and 2. Zeta 1 and 2 turned out less than half light year away. But they were very close, so you can tell that they probably advanced their capability of travel through the space pretty quick. And Terence Dickinson, the editor of Sky and Star, said the fish interpretation is astounding, logical, and uniquely logical and sensible solution, and provocative in terms of ET technology. What is the fish interpretation? Well, it turns out that Marjorie Fish was an astronomer who decided to do a bead and string 3D model of the local neighborhood because, excuse me, because she realized that nobody could figure out the star map because it was from the perspective of Zeta Reticuli. So once you got this bead and string, then she started looking from another angle and said, oh yeah, now we can see the pattern. Because this pattern for years was discounted and debunked, saying this is impossible, these stars don't make any sense at all, and they don't correspond to a constellation we can see. Well, she solved the problem, and now they all have names. So moving on to chapter 7, we have the topic of crop circles. And I thought in this chapter what I would do, instead of doing, as you see, a collage of really interesting complex patterns, which are sort of difficult to decode. I don't know if any of you have decoded this crop circle, but it's pretty mystical. Instead, I wanted to concentrate just on Chilbolton. Chilbolton is incredible. We set the standard pretty high for crop circles that are real. The stalks have to be bent, not blown or broken. And this is a website picture of the difference. Because when they fake the crop circles, they break the stalks of the crops, and they're clearly been manually human-made. And the EMF high electromagnetic fields are much higher, even 10 times background. Well, in Chilbolton in 2001, a face appeared in the crops. And this face, as you can see, also had, as this close-up shows, a very unusual, first time ever, new screen technique to print a picture on paper. And cropcircleresearch.com has it. And you can see these rows of dots that have different heights to them. This is like a digital image that's, as they say, has never been seen before on Earth. A few days later, the answer to Carl Sagan's Arecibo message apparently showed up. And a year later, a year before, a symmetric scalar antenna appeared right next to the Chilbolton and aerospace antenna. And this radio telescope, Chilbolton, is kind of amazing. You think, well, maybe the ETs are trying to say something by launching this image right before it. And then, of course, this image here is the answer to Carl Sagan's original broadcast. I don't know if you're familiar with the 1974 digital broadcast that Arecibo blasted out into space. Well, you can imagine that some ETs may have figured it out and assembled this into the digital two-dimensional format that it was supposed to be, essentially to show the human condition, information about us, where we came from, DNA, and the message, and what planet we're from. Well, the response is on the right, also pictured up here. And essentially, what the response that was in the Chilbolton crop circle, fascinatingly enough, shows an image of the ETs that are sending it, and they look like little grays. 3 feet tall. And they actually state that in the digital information. They inhabit the 3rd, 4th, and 5th planet, which is right here. You can see the difference. 21 billion is on their planet. And here's another website, cropcircleresearch.com, showing the same information. And they're silicon-based instead of carbon-based. Fascinating stuff. I mean, a lot of research can be done just on this crop circle. And to figure out, you know, is this possible? What's a silicon-based life form even like? Lots of questions can be asked. And that's what's great about this. Well, moving on to chapter 8, Billy Myers probably is also familiar with the crowd here. Well, BBC just recently acknowledged the importance of Billy Myers' photos at the Sotheby's auction. And this was December 2019. And they're offering his original photos up for auction. I didn't know it, but Billy Meyer, I have both of his original books, actually Elder's original big color books. And he's published 40 of them in German, only one's in English. And then the X-Files actually featured the photos, actually one of these original ones. Well, these are famous. The important thing that I wanted to emphasize for the textbook is that Joe Tisk, a former investigator for the U.S. Air Force Office of Special Investigations, declared that these are deemed authentic. And Colonel Wendell Stevens, who you probably know, also conducted extensive polygraph tests on Meyer himself. Well, my favorite, besides the one that they're offering for auction, which is sort of a black and white linotype, is this from the book showing the Swiss Air Force jet chasing after the UFO, pursuing it. And what's interesting is not only does the photograph show the two of them in the same photo, but then the book actually shows the thermograms of the images of the two objects. And you can see clearly the heat signature coming out of the jet. Gee, there's no heat signature from the UFO. I wonder why. So that's a good analysis, scientific, worthwhile information. Well, I know Bob Lazar. I've met with him personally. I think he's one of my heroes. I've really researched a lot of the information, including the element 115, which you sort of get the idea should be in the gravity amplifiers here. He tells you as much as he knows. Dr. Edward Teller, actually, he describes the details of how he met him originally, and then later on, he sent him a letter and was hired at some mystical secret project, which ended up being S4. And here's a 1-minute Bob Lazar movie trailer, which actually the movie is pretty good. Mickey Rourke narrates it. And so you get a little teaser here.
The story is extraordinary, especially if it's true. And it all started in the desert, just north of Las Vegas.
A local scientist who worked at Groom Lake
said to be where top secret weapon systems have been tested over the years.
He has asked that his identity be shielded.
Exactly what's going on up there?
What's going on up there could be the most important event in history. Physical contact and proof from another system, another planet, another intelligence.
What would happen to you if the government learned that you were giving us this information?
He just wanted to stay alive. Maybe this has been kept from us for a good reason.
Sir, how do we know you are who you say you are?
My name's Bob Lazar. I'm known for working at a classified base and reverse engineered alien spacecraft.
It went all over the world. He put Area 51 on the map. Can we ever be made whole if we're not believed? We can't verify what was going on in his background.
I have no motivation to lie. The science and the technology can change us.
We've always looked to the skies for answers, instead of looking into ourselves.
That's from Los Alamos personnel list, which they found years later. So, and this is Bob Lazar, Area 51 and Flying Saucers, which you can find online, pay a couple dollars to rent it. And these are some of the drawings of the craft that he worked on. I was so impressed with sharing with you the details, and also in the book, I'd like to have links to the YouTube sites that these relate to, and maybe give a disc, a DVD disc that will contain all these videos. Because I think students need to hear and see these videos, because a lot of kids today are visually oriented. So besides the drawing of the craft that he worked on, here's a 3-minute excerpt from an interview of his just recently.
Where it came from. So I read through the documents.
Tim, we have John Brandenburg joining, so I paused that there and brought it up, or brought John on, as I know he was going to do a presentation or something.
Yeah, that was
wrong way.
I was told to do a presentation around 3 o'clock. I
Charge
thought
my
that,
AirPods.
Here we go.
I thought Tom
There
was,
we go. We got Tim back. Tim, there's John Brandenburg. So I stopped.
Well, I'll tell you what, we got. Hold on.
No. I'm sitting
Okay,
here
so
with my cup of coffee. I'm happy, and I've got my ear of the dragon
so
hat on.
let's do this. If it's okay, we got about 20 minutes left on our video. Is that cool, guys?
Oh, that's cool. That's absolutely cool. Very cool.
Okay, yeah, movie night, and I'll show you guys.
Always
my
like
new-
listening to Tom.
I am well, so since we're doing our little intermission here, maybe we'll do like a 10-minute pee break or something. I haven't even opened this up yet. It's just a tripod. But so one of the things I was with Mark, right? Mark and Michael and David Chester at Asilomar last week. One of the reasons that I went there is I want to get out and start doing more like interview filming, right? Like, and so that was kind of a test to see what equipment do I have, what do I need, all that kind of stuff. I've got extra batteries, memory cards, got the camera, got all of that. And my next journey here is I just bought train tickets last night to come down and see Jared Yates in Oregon. And so I think May 20th to 24th, I'm going to be down there, and I'm going to try and get like live and up close with the Graviflyer. Now, John, you're in the not Eugene,
Medford, Oregon, area, Southern Oregon.
Medford, yeah, so a little further south.
Yeah, it's near Ashland, Oregon.
Yeah, maybe there's a way to coordinate.
Oh, that would be wonderful. That would be wonderful.
And then David Alzafon, right behind the the Alzafon DNO stuff that Mark is working with. David is also probably going to meet with us there, and so we're just going to try and get more footage.
Hey, we could have a little mini conference.
Well, my hope is to start making kind of like documentaries, right? And I don't know what I'm doing here, but we'll see.
Hey, we're all making this up as we go along.
Hey, I saw
that's part of the creative life.
Danny Sheen's charging thousands of dollars. He's charging like $8,000 for like courses, and you can go to like UFO college and get a PhD in ufology or something. We ought to follow suit and start offering some kind of classes ourselves here.
Oh, I don't. Well, maybe through Alien Scientist. I don't know. With APEC, it's always been free and open. It's community resource. So I don't know. I mean,
the aerospace defense industry looks on this UFO thing as a gold mine in the future. It's already been a gold mine, but so if they're going to get paid, why not?
Yeah. Well, guys, let me do this. We've had a couple of minutes. I think anybody who needed to use the bathroom probably did. Let me put the video back up again. Let me apologize for all the interruptions here. APEC we're a little raw, right? We're definitely not super polished.
Hey, that's the way because we're on the move. We're on the move.
Yeah. Well, okay, so let me take you guys out and I will put this thing back up.
All right.
So if there's no load on the reactor at all, it shuts down. When there's a load present on it, it starts up again.
Load meaning?
You can consider it an electrical load. So although it doesn't necessarily operate electrically, there's no wiring that connects any of the subcomponents together whatsoever. They just have to be in the immediate vicinity. The stuff is borderline magic. And that's essentially where we left it, when I left the project.
So there was no progress made?
There was some progress. I mean, we did identify, at least we think, some processes and had a rough idea, we think, of what was going on. But I think this is a problem that they've had for a long time. And, I was replacing somebody that Barry worked with prior to me. And I think there was some horrific accident that I didn't have a whole lot of information on, but, Barry alluded to that.
A horrific accident, like where someone died, or?
Yeah, where somebody died.
Because they were trying to tamper with things or figure out how something worked?
Yeah, the reactor in particular.
But yet he let you touch it?
Yeah, I think what they were trying to do was cut into one.
Oh,
now,
Jesus.
they had more than one there, and that was supposedly there was an unannounced nuclear test, and that's what it was. At the time, remember, they were still doing underground nuclear tests at the test site. But from what I understand, according to Barry, there was an attempt made. Now, this must have been a pretty desperate attempt because it's not a very scientific process to analyze something that way. But it looked like they used a plasma cutter or something like that to cut into an operating reactor.
How many of these things did they have?
They had nine craft altogether. I only got hands-on with one of them, so I can't really say how the others operated.
Did you see the other ones?
Yeah, at one time, and only one time, the bay doors between the hangars were all open, and I could see all the way through.
And were they all exactly the same?
No, they were all different.
Different shapes?
Yeah.
But they were all from somewhere else?
Yeah, absolutely.
Now, did anyone make any attempt to explain or to tell you where they came from?
No one is the least bit interested in letting everybody know.
Which of course we all know is true as well. Well, the hangar doors that he talked about for years now have been found on Google Earth. And this is the image that is on the strider.com website, the Area 51 mountain hangars. And that's the image of where, and here's the longitude and latitude of those hangars for S4. Very interesting. And I found that to be corroborating. Oh, by the way, just this past year, a few months ago, Bob finally wrote his autobiography, and it's called Dreamland. So moving on to chapter 10, I'm just going to go through this real quick. Anti-gravity research has always been a fascinating subject of mine. This is my first book in 1994, second book in 2000s. It's been verified with various charts that Paula Violette supplied from Army Research Lab. So we do have a propulsion mechanism that seems to be possible explanation. Electrogravitics is an emerging science. And of course, lots of these cover pages from newspapers in 1955 ended up being very interesting to see where the Aviation Studies group actually did the examination of this. Well, chapter 11 I thought would be very interesting to focus on panspermia, because when you hear stories about hybrids and the origin of our existence, panspermia is a theory that Dr. Wainwright's famous for theorizing and speculating that cosmic phenomenon really was responsible for bringing life to the Earth. And so he, with another professor from India, ended up having enough finances to launch a couple stratosphere-level balloons with a collection plate that was sticky enough and, interestingly enough, had impact registration. And then he published some great journal articles essentially showing DNA substance oozing from a titanium vanadium sphere that was stuck to the collection plate. And this is the journal article, Journal of Cosmology, 2013. And he's from the Department of Molecular Biology and Biotechnology in the University of Sheffield. And so I contacted him, and we're going to have him as a speaker at our next conference on future energy, which is in August in Albuquerque, New Mexico. And these are some of the other biological entities, that's what he calls them, little biological stuff that he collected on the next balloon trip, 2 of them. And they produced impact craters because they were coming from space at a high velocity. So to him, this is proof that they couldn't possibly have originated from the Earth floating upwards. And they were too heavy and too big. So this is exactly 25 kilometers above the Earth. MiltonWainwright.com is his website. And here's a close-up electron microscope picture. FutureEnergy.org is our website if you want to learn more and see him in person in August in Albuquerque. I mean, this sphere was just a jaw-dropper. Look at the perfect spherical shape of something that came from space with DNA inside it, you know, and it's made of titanium vanadium. I mean, this thing is scientifically enhanced to make sure it makes its way to wherever it was supposed to go. Well, and the last 2 chapters here, this is the last chapter of ET UFO material. George Van Tassel, as you heard from my video at the Citizens Hearing, was how it got started in 1980. And this is a collage. Integratron.com is the information. Giant Rock was where he focused on. This is one of his books, When the Stars Look Down. And the space conventions he used to have were pretty interesting. And this is a short video.
In the Mojave Desert near Landers, California,
focus
one
on
of the
this guy
largest
right
freestanding
here
boulders in the world.
on that rock. And there's
In
Giant Rock.
1940, it was the home to a prospector named Frank Pritzner. He built a strange home under the rock, and many wondered what he was doing there. He even had a large antenna on top of the rock. During World War II, many looked upon Frank as a spy because he was German and he had this strange radio. In 1942, the police raided his home under the rock and used a gas grenade to get him to come out. The grenade set off dynamite he had stored in the room, and Pritzner died in the explosion. After Frank's death, his friend George Van Tassel took over the Giant Rock, maintained an airfield, and built a cafe. During his time working there, he had an encounter with an alien from another planet. Because of this, the area soon became a meeting place for those interested in UFOs. At one meeting, over 11,000 people attended.
11,000 people.
The meetings were fundraisers to build the Integratron, which the man from Venus gave George the instructions on how to build. But it's supposed to be able to rejuvenate human cells and enable time travel. He began the construction in 1953, and not a single nail was used in the building. He died in 1978 before it was completed. The Integratron is still there and it's open for visitors.
Yep.
Quartz crystal bowls are used to create a sound bath for a meditation experience.
That's the upstairs. And it's acoustically perfect hemisphere. It reflects all the energy back to the center.
Visitors for the sound bath lay on mats so that they can relax and enjoy the sound. The ceiling enhances the sound and makes it a beautiful place to have a relaxing meditation. Outside of the Integratron, there are many areas where you can relax before experiencing the sound bath. This small painting represents what it would look like when the aliens visit the Integratron. So far at this date, the aliens from Venus have not made contact.
And that's the strange and mystical and mysterious problem that Van Tassel had for the rest of his life. In fact, the video we just saw in the previous speaker had a similar problem. They seem to make contact, show you their ship, make friendly gestures, and then disappear for decades, never seen again. And that's what happened to Van Tassel. He literally got to go on the ship, and I'll show you another quick video, last one, that essentially got him to start building the Integratron, which I visited and took pictures of and made a lot of measurements, and also built a model. There's my model I did for Ancient Aliens, Prometheus Productions, to essentially show what possibly could be done to complete the Integratron. The Integratron was never finished. So I wrote a book by electromagnetic healing that's available, I think, in the bookstore, and essentially gives you the idea that if he completed a spiral coil and maybe a Likovsky coil, you could have this high voltage discharge upstairs and therefore rejuvenate people, in which you can see little people walking around downstairs. This model was about this 3 feet in diameter, and they loved it. They basically took it with them, actually. So here's a 2-minute excerpt of a half-hour interview that's online on YouTube.
And there are records in the 1898 Chicago newspapers that covered the front page for 3 days of a big ship setting over Chicago. When you realize we're dealing with a type of man that is almost as far above us in intelligence as we are above the lower animals, there isn't anything phenomenal in this at all.
Now, you say casually, because this is your life's work now, ships. Now, you mean flying saucer, don't you?
Well, a flying saucer was a name the press put on this thing. And actually, what they termed a flying saucer was nothing but a scout ship from the big carriers.
But I want to go back to that night in 1953. Tell me, where did this happen for people who haven't heard you talk or seen you yet?
It happened on my airport, which I've operated for the last 16 years, at Giant Rock Airport, 17 miles north of Yucca Valley in California, or 40 miles north of Palm Springs.
Now, this is a private airport for small aircraft, is it?
This is an airport used both by the military and private aircraft.
You own this airport?
I leased this airport from the United States government. I've operated it for 16 years since I retired from the flight test business in the aviation.
Right now. How old are you now, by the way, John?
I'm 54, Jack. Got 3 grown daughters, married, and 11 grandchildren.
You don't mind if I ask you the stock question? I know that you've been asked every obnoxious question that can ever have been asked. You've never been treated for any form of emotional upset.
I've never had an emotional upset other than women.
Except that night in Yucca Flats, not Yucca Flats, a Giant Rock, when this ship appeared. Now, give me the details, George, because I'm never tired of hearing the details of a man who says he has seen creatures from another world.
Well, actually, Jack, this was as simple as crossing a street and getting hit by a car. After it's over, you're the victim of the circumstance. And I didn't see the ship land. One of my son-in-laws, that wasn't my son-in-law at that time, saw it come down. Another man on the airport heard it, and he wasn't where he could see it. And the man got off of the ship and approached me before I even knew there was a ship down.
Where were you then? What time of day or night was it?
It was 2 o'clock in the morning and approximately a full moon, which is like daylight on the desert.
Were you walking about outside or what?
No, I was sound asleep when he awakened me.
This man awakened you?
Well, something awakened me.
So you got up out of your bed?
I got out of my bed and went aboard the ship at his request.
This man, in what language did he converse with you?
He talked to me in the best English equivalent to Ronald Coleman.
And he met you there and he said, what did he say? Come with me to my ship or what?
No, he said, I asked him what he wanted because we have a lot of people come in stuck in the sand and broken axles and whatnot. And I asked him what he wanted and he said, my name is Solganda and I would be pleased to show you our craft.
Solganda?
Solganda.
Was the craft visible to you at this time?
It was when he stated this. I saw beyond him the ship, which I hadn't seen before.
What did you see?
A bell-shaped type of anti-gravity ship that they operate as a scout ship out of the big carriers.
How big?
This was 36 feet in diameter and 19 feet high.
And where was it? On the ground?
No, it was hovering 10 feet off the ground.
And how did you go into this ship?
I walked with him to a spot underneath it, and an anti-gravity beam took me up through a hole in the bottom of it.
You're telling me at 2 o'clock in the morning in Giant Rock Airport, you walked underneath this hovering ship, and whammo, you went up inside.
No, you didn't go whammo. You went just about as slow as a local elevator run.
And when you got off the anti-gravity elevator, what did it look like?
I was inside of a ship about 18 feet in diameter and roughly 10 feet high to the domed ceiling, and there were 3 men on the ship, besides the one that had got off and invited me aboard.
You keep calling them man. What do you mean, man?
Well,
Little green man?
They were about 5'6". They came about to my eyebrows, and they could have walked in our clothes down any of our streets, and we wouldn't have paid any attention to them.
And did you bring any proof off that ship? Were you alone in the ship?
I was alone with the 3 men until the other fellow came up behind me, and then the 4 of them were aboard.
Was there any other earthly eyewitnesses to this?
Nothing, only outside of the ship.
And these people stayed outside?
On the airport.
And did you go anywhere in this ship?
Not to my knowledge. When I got off, it was the same place it was when I got on.
What do you mean, not to your knowledge? Had the door closed when you went in or something?
I don't know, because it was below the deck.
And did these people tell you where they came from?
They didn't say where they came from, but I've been in the air game since 1927, and their instruments were unlike anything I'd ever seen before.
Well, don't give me technicalities. What was different?
The difference was that we used dial instruments, and they used vertical instruments, like fluorescent tubes with marks on them.
What color were these people?
The instruments were marked in symbols similar to hieroglyphics. They were not in any language or number system we use on the earth.
What color were these people?
They looked like they were white people with a good, healthy tan.
Did they give you any indication of how old they were, or what they ate, or where they came from at all?
After we got off the ship, the man who invited me aboard, who didn't look a day over 28 years of age, told me that he was over 700 years of age in our time.
Oh, come off it, George.
That's right.
Was this the guy who gave you the formula for the time machine?
That's the man.
And what form did the formula take? Did he implant it in your mind by telepathy, or did he give you something written in English?
He spoke it to me verbally.
And you remembered this?
There's nothing to it to remember.
Will you tell me now? The formula for a time machine.
F equals 1 over T.
F equals 1 over T.
F being frequency and T being time.
And this enables me to go back to the time of Caesar's armies conquering Britain.
Well, it would enable a mathematician to work this out, yes.
Why hasn't this been acclaimed like Einstein's E equals MC squared?
Well, why hasn't the fact that the United States government's been flying anti-gravity ships since 1956 been acclaimed?
So I'm going to keep moving because I'm running out of time. You've seen some of these graphs. The most important book, I Wrote a Flying Saucer by George Van Tassel, is, I feel, the most interesting in terms of the download. It was his first book and has quotations from his communications with them. The important part, I felt, was in 1952. He receives this message: your Pentagon will soon have much to muddle over. We're going to give the globe a buzz, and I hope they do not intercept us from in front. Well, interestingly enough, he spent 1.5 years trying to get contact mentally with these ETs, and then gets the human visitation from one of the crafts 1.5 years later in the beginning of 1952. Well, by July, they then tell him that the message from April should be sent to the Air Force Space Command and the office, and they're communicating why they want to come in force, in other words, more than one ship to fly over Washington, D.C. And they said, well, the uranium bomb doesn't matter to us, but hydrogen is life-giving, and we are very concerned because you could turn this planet into a cinder, extinguish humanity, and this condition already happened in the solar system before. To me, that was shocking, and I found other UFO books describing, ET books that talk about the asteroid belt previously being a planet, which astronomers admit could have been possible. Well, this communication seems to give you that history, and over billions of years, obviously, civilizations could have come and gone. Recently, Dr. Brandenburg has found evidence of atomic bomb explosions on Mars. There's actually the xenon-29 residue that can only come from an atomic explosion. And here we have the first hydrogen fusion bomb happening only a few months after July. This is July to November, and all of a sudden we're exploding a hydrogen bomb in the Pacific. So these guys figured, oh, well, we'll make ourselves known, and then this planet will understand that they should cower down and basically not get too aggressive. Well, unfortunately, it seems to have had the opposite effect. Our Air Force is very aggressive. And it only took 3 days of flyovers for Washington, D.C. until in July 29th, this was 20th, 22nd, by 29th, the orders were sent out to shoot down the flying discs. And here's General Samford explaining what happened. And this is probably the best military video I've ever seen in terms of letting
in July of 1952, an event happened in Washington, D.C. that shook the city to its core. Many unidentified flying objects flew over the Capitol in a display of perfect formation.
In Washington, ghost-like objects dart across the radar screen at the CAA Traffic Control Center at National Airport for several hours, traveling more than 100 miles an hour. Air Force jet fighters spend several hours chasing the objects plotted on the radar scope. General Sanford, Air Force Intelligence Director, confirms that the objects are not secret American weapons and reiterates the Air Force's obligation to investigate.
This is an artistic rendition of what it looked like. There's a book, for example, just recently printed and doesn't admit that the Van Tassel prediction actually was involved in the episode. So here's General Sanford in a much better video. In the meantime, I'll launch a couple UFOs.
Air Force interest in this problem has been due to our feeling of an obligation to identify and analyze to the best of our ability anything in the air that may have the possibility of threat or menace to the United States. In pursuit of this obligation, since 1947, we have received and analyzed between 1,000 and 2,000 reports that have come to us from all kinds of sources. Of this great mass of reports, we have been able adequately to explain the great bulk of them, explain them to our own satisfaction. We've been able to explain them as hoaxes, as erroneously identified friendly aircraft, as meteorological or electronic phenomena, or as light aberrations. However, there have been a certain percentage of this volume of reports that have been made by credible observers of relatively incredible things. It is this group of observations that we now are attempting to resolve. We have, as of date, come to only one firm conclusion with respect to this remaining percentage, and that is that it does not contain any pattern of purpose or of consistency that we can relate with to any conceivable threat to the United States. We can say that the recent sightings are in no way connected with any secret development by any agency of the United States.
Well, if he's admitting there's no secret development of United States projects, that basically tells you it must be ET. Anyways, I thought that was very nice of them to tell us that back in the 50s. And George, of course, is very excited about the fact that the saucer beings timed it that way to let the Air Force know the information is authentic. He sent postal mail to the Air Force ahead of time before this buzz happened. And the Brookings Institute asked a lot of questions. And I essentially have chapter 13 asking intelligent questions about ETs and UFOs. And here's that email about if the Earth is basically only 4.5 billion and the universe is 13.5, there's obviously a lot of time for ETs to have developed. And there's the website integrityresearch.org if you want more info. Thank you very much.
Sorry about that. Okay, I'm going to stop sharing. I'll bring the gang back on. And we have Mr. Brandenburg with us. So everybody, I guess he's not with us today, but we should put our hands together. Let's give a hand to Dr. Tom Valone. And I'm going to try and get, I will try and get a link to that video. I mean, worst comes to worst, I don't know what the rights are in terms of that, but I've got a copy that I could upload. You guys could watch it without the interruptions or the stops or any of the fun stuff that we've had to deal with. Let me apologize again for that. So let me see. Do you guys? It's 3:42. Do you want to talk about Tom's stuff for a few minutes? Then we can go to John. Yeah. So what do you guys thought? What are you guys' thoughts on everything? I think that some of Tom's claims, Tom actually mentioned you in it, John. I think he did. He mentioned the isotopes on Mars. John's muted. There we go. John, you're muted, my friend. There we go.
Looks like there was a thermonuclear holocaust. Oh, can you hear me?
I can now. Yeah.
Oh, okay.
Yeah, you were saying
What
it
we
looks like
doing?
there was a thermonuclear holocaust on Mars.
Yeah, I'm afraid so.
Yeah.
Which
well,
shows
and
that the rest of the universe is just as fouled up as this planet is. That's what it shows us.
we are not fouled up. They are fouled up. It's their fault. We just live here.
No. We have plenty of stuff that we do ourselves, but it's just I tell people. Well, one of my good friends, David Pfaff, calls it Mars is a metaphor for the rest of the cosmos and our situation in it. That the cosmos can be a dangerous place sometimes. Sorry. I wish, I wish killer whales. I wish killer whales did not eat dolphins and seals, but they do. Yeah. Well, anyway, yes. So I was very flattered he would say that. I was also amazed that the Air Force received a message before the detonation of the first hydrogen bomb, and that that they were going to buzz Washington D.C. And that that event actually occurred before the detonation of the hydrogen bomb out in the Pacific. So that was that's a new piece of information to me.
Yeah, there were a lot of tidbits in there. That's why I thought it might be worth discussing this a little bit.
Yes, I think. Well, anyway, those are the 2 points that I also liked him being nice to Philip Corso, who I think gave us a wealth of information. But so I'll just say that I was flattered he would mention my work on Mars, and then it's news to me that the Air Force received a message saying we're going to buzz DC because we don't like your hydrogen bomb test coming up. We might spoil the planet and make it an unhealthy place for them to settle later. That's my interpretation.
Problem is they didn't land on the lawn. Everybody always wants them to land on the lawn, and the one time they do visit the White House, they don't stay.
Well, can you blame them? We're shooting at them. That's why
they're just worried we're going to.
And they didn't just buzz it once. They buzzed it twice over the course of 2 weeks. They were buzzing in the White House.
Oh yeah, and well, here I worked in Washington D.C. for 15 years. The story I heard was that after watching these things fly over Washington, D.C., the Air Force didn't say anything about them for a while, and then finally announced, okay, the thermal inversions you've been seeing, we're going to start opening fire on them. And they did. They blew a chunk off one of them, which led to the invention of composites, because it was a piece of interesting alloy with all these little spheres of some other kind of stuff in it. They recovered the piece that they shot off, this thing with like 20 millimeter cannons. It was, and then, by the way, once they started opening fire on the objects, the thermal inversions over DC, they quit showing up. So that tells you something right there.
Yeah, that's what happens.
Yeah. We kind of raised the ante there, and they decided to fold and find another card game.
Well, in all fairness,
that's just my view. That's just my own viewpoint.
In all fairness, space aliens are probably commies, and therefore we shouldn't have them here anyways. You know what they say, better dead than
Some
red.
of them are commies.
I think all of them are commies.
Well,
they're
let me
either
put it
commies
this
or
way.
pinko commie sympathizers.
The rumor I heard was that the
Maoist Martians.
yeah,
Yes,
the
them too.
aliens who
That's another
wiped out
group.
the Martians. The aliens who wiped out the Martians were Republicans, and the Martians were Democrats. So, you know, there. I just wanted to make that real, you know, and make it.
We need
let me put it this way. My view is there's a principle in SETI. It's called the principle of mediocrity. And it says that the Earth and its biosphere and ourselves are typical of the cosmos. And if you think about that, that means if you want to know what intelligent life acts like in the universe, just turn on the news. I'm sorry. We all hoped that the rest of the universe would be, you know, more enlightened and better than this place, but apparently it has its own issues. That's my own considered belief. You know, it's not just based on things like Washington, D.C. UFO flyovers, which was, you know, a blatant piece of geopolitical intimidation, in my view. But also the rather unpleasant aspects of UFO phenomenology, the abductions and the mutilations, both animal and reportedly human, that are occurring. So, my friends,
well,
I'm just
John,
saying, if you're looking for some extraterrestrial Godot to land here on the White House lawn and show us a better way, they haven't shown up yet.
Let me offer a couple of thoughts.
Yes, please do. Please do. I'm going to shut up now.
Well, I'm not a scientist like yourself, right? And so, you know, I will get beat up if I offer too much, but I've done a ton of interviews. And one of the areas that I've been really excited about is doing interviews on SETI. So let me see, Dr. Robert Zubrin, founder of head of the Mars Society, with the Mars Society.
Oh, great guy, great
He
man.
said to me, I've picked up so many bits and pieces. I probably need to write a book on what Zubrin had said was, and this goes to your thought on we are typical of the universe. One of the things for me, this has been eye-opening, I guess. One of the things that I've realized as I interface more with the traditional scientific community is this idea that maybe Earth is unique, maybe Earth is, you know, somehow different than other planets. And we can't prove, for instance, we can't prove that other planets exist outside of the solar system until we discover them, right? There's this hubris almost. I wouldn't even call it hubris. I would call it
slightly more to Tim. I'll just interject one thing, then I'm going to shut up. I was talking to, I was trying to get an article published about, not about advanced civilizations on Mars or anything, just microbial life from meteorites that apparently come out of Mars, and also other evidence like the seasonal methane and oxygen emissions. But I was trying to get this article published in this mainstream scientific journal in the United States, and this one reviewer said to me he says, these supposed evidences of life on Mars, it's nonsense. He says, when we want to prove that there's life on Mars, he says, we're going to send rovers there to prove it, he says. Meaning, until we say it says Haynes, nobody can say it says Haynes on the
yes, and that's the hubris. So going back to Robert Zubrin, what Zubrin had said to me was, and this is a fact, right? This isn't his opinion. The four most plentiful compounds in the universe, elements, are oxygen, hydrogen, helium, which is inert, doesn't interact with anything, and carbon. And
Yep.
3 of those 4 constitute pretty much all life and most of our biosphere here on Earth. So in terms of chemical composition, the Earth is incredibly not unique, right? We for
No,
for
we're
where
not
we're
made
at
out
now,
of anything special.
no, we're not. I mean, you know, I mean, these are the
This is
3
not
of the 4.
unobtainium here, you know.
Yeah, these are the most plentiful elements, and that constitutes pretty much everything that makes us human and our planet a planet, right? I mean, our biosphere and all that. It's, you know, it's water, it's oxygen, and you know, it's carbon-based life, and those are super common. So part of it's that, but then this other idea of, as we begin discovering all of these exoplanets, the more we look, the more we find, and the more we find that, I mean, I'm reading about a lot of surprises, right? Like a gas giant that's a heck of a lot closer to that star than they thought was possible. But at the same time,
Especially considering that gas giants are made of hydrogen, you'd think getting hydrogen that close to flame would be a bad idea.
what's interesting to me though is, you know, at I mean 100 to 400 billion stars in the Milky Way alone, you know, again, this goes back to the Drake equation. Even if only a tiny fraction of them are like us, you've still got potentially millions of planets,
I know.
millions or tens of millions with some kind of life, and potentially thousands or tens of thousands with advanced civilizations. So, you know, I mean, the odds are heavily in the favor of extraterrestrial life and UFOs. I mean, heavily in favor of it, you know? That's just my 2 cents, but.
Oh, I think that's very good. These are all very defensible opinions.
Yeah,
I look out at the night sky now and I realize just about every star I'm looking at has planets around it. You know, it's like hens and chicks, you know, every one of them has, every one of them is like the gas giants in the solar system. I mean, Jupiter and Saturn in particular, they just have a whole plethora of moons around them, and they're solar systems in miniature. And so apparently that just is a recurring pattern in the cosmos.
Yeah, the only caution that I would have, especially with a lot of Tom Valone's stuff that he was talking about, was a lot of those stories, like the fellow who was talking about Venus and things like that. People were interpreting whatever experience they had, right? Real, fake, dream, hallucination, whatever that was. They were interpreting it through the knowledge of their time. And so some of it, like that star map, that was a really interesting idea where, okay, this is, you know, our constellation, but it's viewed from a, you know, that's something that wouldn't seem to be easily faked. But some of the other stuff, like, you know, I saw a man from Venus and he told me that they were going to do X, Y, and Z. To me, it's like, okay, that could just be a product of storytelling, which happens, right? We're human beings.
Or let's just say you're from outer space and you want to have a good story together for the natives. So you say, see that really bright star over there? I'm from there.
That's another important
Venus,
point.
because Venus is, you know, Venus is the brightest object in the sky, and at the time when it was done, you know, it was so covered in clouds, we didn't know what was on its surface, so it was very mysterious at the same time.
Yeah, well, and it's communicating in the context that people can understand. Imagine getting out of your spacecraft and you see a farmer in a field on an old John Deere. He's like, "How does that thing work?" You know, it's a warp drive. Let me show you. Come on in. Here,
we'll come on in.
You know. So, you know, I mean, yeah. I think what you're saying is
the farmer will say, "Well, does it run on gasoline or diesel?"
It runs on anything, man. It runs on anything. It's like Mr. Fusion from Back to the Future. Yeah, that's right. Well, so John, we're at the top of the hour. Did you want to do your presentation on?
Absolutely.
On
I want to demonstrate to you guys that space-time.
Okay, and you have a PowerPoint too.
Oh, I'm terribly sorry. Here, let me get that PowerPoint loaded up here.
Okay, yeah. Load that up,
what
and I will
my
hide.
Concentrated on, like Hal Puthoff, he gave honorable mention to the work of Hal Puthoff and let's see. Oh, here.
Oops, where's that?
Pardon me.
Esoteric Gold. It runs on the beer in the can.
Let me do this thing right here.
I remember that. Remember Back to the Future? He was pouring beer into it at one point.
That's right.
Although maybe it runs a little different.
Yeah, that was right in the Back to the Future. And
there was some eggs. There were some eggshells. I think he was.
Okay, here. Oh, hold on. Okay. Well, anything with water in it, is what he was doing. He was just looking interested in the water, and all right.
That's right. So you can. I'm
all
just
right.
thinking, if it's a real fusion generator, then you can just pee in it if you get stuck.
Oh boy, great vacuum tank. I get excited when I see a good vacuum tank like that. You know, means there's all sorts of possible experiments. And when I was working in the lab a lot, people told me that the saying about me was that no microwave oven was safe around me. I would take them apart, turn them into high voltage spark generators or ball lightning makers, or I actually turned one into a rocket engine, and it was in the microwave tube, and it was great fun. Okay, so have you gotten an upload?
It looks like it is not uploaded yet.
Okay.
It should show up down that.
Here, let me be quiet and actually do this thing right. Okay, I'm going to my computer. Okay, and it says upload file. Okay, so I'm going to do a PowerPoint, and here is the presentation.
John, I just have to say real quick, I remember when I came and visited you, and I saw about a dozen microwaves new in the boxes ready to get taken apart.
Absolutely. The guys I was working for, they wanted to make sure I had plenty of material to work with. Let's see. Okay, did we get anything?
It's not there yet. So you got to upload.
Okay, well here maybe it says I have to share the screen. Maybe it's up there, but I haven't shared the screen.
No, it should be there.
You gotta hit share screen.
It should be there. Okay,
okay.
What's that?
Oh yeah, no, Bernie is actually the master of StreamYard.
Yeah, see, you got to hit the present and then share the screen of the one the file that
the
you
one
opened.
that I uploaded.
Yeah, you got it.
Okay, share screen. Okay.
And I'm just looking for a copy.
Select a window or screen.
Yeah, it might be under window, or if it's it might be under a tab if you've opened it under your internet browser.
Okay. Here, I think I see it.
Okay, and I can upload it if you want, John. I just got mine.
Yeah. Let's see. Okay, it says allow.
Yeah, there you go.
There we go.
Okay. Very
Perfect.
good. Very good.
Wait.
We're making progress here. Okay, here it is. The KB hypothesis confirmed.
Oh, I think maybe
And
you
it
have to
won't.
open that file first, and then you might have to reshare it afterwards.
Yeah.
Then I might have to share a screen. Okay. Well, here I'm opening. Can you see me? Okay, there's
No, so you're gonna have to hit stop share again and then reshare with that. Now,
John, why don't you?
Okay.
Here, I'll put it up. Why don't you just let me know? We get 17 slides, something like that. Just let me know. Just say next when you're ready.
perfect.
Okay.
Well, actually, I
Without-
have I actually have a slightly updated file. Could I send it to you, the very updated file? I'll label it 2.
Yeah. Go send it on over. Send it on
Yeah,
over.
let me send it to you updated. So let me send you the
Okay.
updated file. Here, I'm going to rename it as KB Hypothesis Confirmed 2. Whoops, pardon me. You guys, sometimes guys, you got to just play it as it lays. You know, you got to. Oh dear, what happened? Okay, here we go. Okay, I had that thing up. Okay, this I want to save it as number 2. Okay, save as, and I'm going to call it version 2.
Okay.
V2. Didn't mean to make it sound like it sounds, but
Is it
okay.
is it a lot different?
So now
'Cause
I'm going to ship that. No, it's not a lot different. But here, let me now here. Just let me quickly.
Okay. I only
close
ask
it,
for time,
and then I'm
I
going
do
to.
have a.
Oh no, this one is not very long. So here, let me. Doggone it. Yeah, I know we're.
It's okay. Don't stress out. We'll get there. We'll get there. I know the countdown stress that makes it worse.
Stressing out here. Okay, here. Let me. I'm gonna send this right now to you.
Okay, and
And
we'll
we
do
can,
some
you
game
can
show
just open
music.
it.
Dun 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 dun.
Of course.
Dun 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 dun.
Okay.
Hey, it could be worse. Remember when Mark and I did Christmas
Okay, I'm
hats?
trying to do. Here, let me. Okay, let me just.
Okay, hold on just a sec.
I have wrestled all of my career with computer problems like this. Okay, and it's
Okay, sorry about that.
Sorry, guys. I have my streaming going on at the same time, so I'm slowing my machine down. Oh, fortunately, the file is not.
Well,
very
John,
long.
why don't I? Oh, is it working? Because I could just put the one up that you already sent me.
Okay, here. Let me just try this. It's starting to respond now. And okay. I think it seems to be working just fine now. Let's give this a shot, and then otherwise, if that doesn't work, then we'll go with your the version you already have.
Okay. Yeah. Again, no stress. No stress.
Okay, very, very good. Here, let me just send. Okay, it says StreamYard. It's reference StreamYard link, and it's only a 1.7 megabyte file.
Yeah, there we go.
So it should be. Oh, okay. Oh, very good. Very good. See, we did it.
Yeah, and let me.
The finest minds on Earth.
Give
The
me
finest
just
minds
a
in the
sec.
galaxy. Like I said, this is. I'll move through it rather quickly. It's not very long.
Oh,
But
I
think
was
it's very
more.
important, you guys.
Yeah, I was more worried about keeping the audience waiting for the. Okay, so anyhow, we're just about there. I converted it to PDF very, very quickly, and I'm going to add it now. That PDF
Excellent.
solves. Yeah, StreamYard does have a few little bugs. Okay, So let me just tell me when next or whatever, and I will take myself out.
Okay, here, okay, it says, excuse me. Okay, yeah, okay, the title of this talk is the KB Kernsunoglu Brandenburg hypothesis. That's why I abbreviated KB. And Q-gem theory is confirmed. And you'll see the identity of the people I have pictured there in a minute. Next slide. Okay, there was a very brilliant fellow. He was Turkish, and he was an ardent student of Albert Einstein, particularly his pursuit of the unified field theory that Einstein was trying to do, where he's trying to take the two long-range forces of nature, you know, the weak and the strong force. There's a short-range operated at nuclear distances or subatomic distances, and the E&M and gravity, of course, reach all the way across the universe. So he followed Einstein's idea that those two forces could be, you know, kind of separated from the rest of them and unified. So there he is with Einstein. And he also predicted several types of neutrinos, which he got a lot of credit for. So he was a brilliant guy. Next. Another fellow who's very important is Sabayan Chandrasekhar. He was the discoverer of the black hole. That's what he called it. And I think he may have come up with a name. And he got the 1983 Nobel Prize in Physics for discovering that. Now, because of their supreme importance in physics, which I'm going to shortly demonstrate, it's time to retire the name black hole and name them something more in his honor, because he was the great discoverer of them. And for a while was ostracized from the community. They considered it a very nightmarish idea that a star could crush itself out of existence, and that not even light could escape. And so he had a really difficult time early in his career. But later, because his work was so good, he managed to rebuild his reputation. And he was also from India at a time when Indian scientists were very rare. And but anyway, so I'm going to call what we call now black holes are going to be called Chandrasekhar objects, abbreviated as CHO, which is something you shout in Chinese table tennis, as it turns out. When you make a good shot, you go CHO. Anyway, Chandrasekhar object. Next. Why am I calling them Chandrasekhar objects in his honor and retiring the old name of black hole? Because they are going to assume a central place in physics in this coming decade. They confirm the Einstein gravity EM unification is possible. Next. That's why they're so important. Okay, I'll quickly run through this. The Q-gem quantum gravity theory, which I recently developed. The KB hypothesis, what's called the chirp, which is the gravity wave signal from two Chandrasekhar objects or black holes merging, and the flash, which is apparently this very brilliant flash of E&M radiation that happens when two objects which don't emit any light combine. You're getting light from pure vacuum. So now there's been a recent event, a gravity wave event, and they also found an optical signal at the same time that was very bright. It was like a very bright supernova, but lasted only a very brief time. Supernovas shine for weeks. This one only lasted like a day. And then I'll summarize. Next. Okay, I won't bore you with all the details, but gravity EM unification can be done. The gem theory, I've been publishing on that for years. This is Einstein, what I call the Einstein unification problem, separating out gravity and E&M and unifying them separately. It uses the Poynting vector, which is the radiation pressure vector from E&M to unify gravity and E&M. It also points, recently I've discovered that since E&M fields can be quantized into photons, we can use this gem theory as a backdoor into gravity theory and quantize it. So I recently, as you know, talked about that, and I've been posting, I'm preparing an article for publication on that. What happens in gravity theory is that if you have, gravity theory is inherently unstable when you try and quantize it, you end up with a whole bunch of little micro black holes forming. And so, or Chandrasekhar objects. And so these micro COs or micro CHOs, Chandrasekhar objects, are unstable to Hawking evaporation. In other words, Hawking showed that a isolated a black hole would evaporate into pure E&M gamma rays after a period. And so, in other words, you take something that's made of pure gravity, there's no matter there, it's all pure gravity, and then it evaporates into, finally explosively into pure electromagnetism. So it basically is already verifying that E&M and gravity can be unified. Next. Gravity field, as I said, is unstable. You don't even have to do a quantum gravity thing, but you can find out that gravity disturbances scatter off each other, and they do something very similar to what's seen in hydrodynamics, where you have a transition from laminar flow down a pipe to turbulent flow. And here it is, a light from a Bunsen burner seen in infrared. Infrared radiation, you see the flame is creating a column of rising hot air, and as it gets faster and faster, suddenly it goes unstable and forms a bunch of it goes from being a low frequency kind of spatial frequency thing to being a bunch of high frequency turbulence. And the same thing happens in fluids and also happens in gravity theory. And the final step is that you form little miniature black holes or miniature CHOs. Next. Now, those little miniature CHOs or black holes then evaporate into pure E&M waves. So you start out with a bunch of turbulent gravity. You start out with big gravity fields, gravity waves, and they go turbulence and break up into a whole bunch of little teeny gravity waves that then break up and break up and break up and finally form little miniature black holes or Chandrasekhar objects. And those then, because of Hawking, evaporate into pure E&M. Next. Okay, out in space, we'll have pairs of burned out stars, and they form Chandrasekhar objects, black holes. And they are actually orbiting each other. And as they orbit each other, they radiate gravity waves more and more, especially the closer they get. And this causes their orbits to decay. So they do what's called an in spiral. And they start going faster and faster around each other, approaching the speed of light. So first phase is you have this two tremendous objects that don't make any light. And by the way, they sweep the surrounding space clean of matter. So it's just bare vacuum, like a big vacuum cleaner. And so they're orbiting each other. And they start orbiting at faster and faster frequency as they approach each other because they're losing energy to gravity waves. Next. Okay, stage 2. They're starting to orbit closer and they're going faster and faster. It's like spinning up. like that. Gravity waves are starting to shift to higher and higher frequencies emitted from it. Next. Now they're getting really close to each other. These things are both black holes or Chandrasekhar objects. They are starting to move close to the speed of light around each other. And what happens then is what happens in electromagnetism. When you start getting things moving in orbit, circular orbits, or even elliptical orbits around each other in electromagnetism at near the speed of light, you get what's called synchrotron radiation, which means that not only is the basic frequency getting faster and faster and faster, it's spinning up, it's getting more higher and higher whine, like you're spinning up turbine, but it's also starts to make harmonics, higher harmonics of the high frequency. So it's this cascade to higher and higher frequency, which means shorter and shorter wavelengths because they have the same relationship as the gravity waves move at the speed of light. So anyway, they start doing what's called synchrotron radiation. So it accelerates this move to high frequency, short wavelengths in the gravity waves near the objects as they start spinning around each other at near the speed of light. Next. Finally, according to the theory that I have proposed and what is seen in simulations of gravity waves, in these sort of strong dynamic gravity waves, dynamic gravity fields start going turbulent. You have a high frequency cascade. It's already going to higher and higher frequency. It's like a turbine spinning up, going higher and higher, finally goes ultrasonic. And then you start getting harmonics on top of that. It goes higher and higher. The dogs all start howling in the neighborhood. So it then breaks up into turbulence, a whole bunch of micro CHOs, black holes. Next. Hello. Next. Tim. Is anybody home?
Wait, can you hear me? Can you hear me now?
Tim, next.
Yeah, I think, you know what? I think your connection may have stalled out, John.
He's asking.
Well, here I am on the screen.
He's asking for the next slide. No.
Yeah.
Is it not advancing?
No. Okay. Now it did. Now it did. Okay.
Oh, that's
now.
Weird. Because okay, that is the weirdest thing. I hit next like 4 times, and it seemed like it was maybe.
Okay. You know, well, we're also supposed to be under attack by our major trading partners, the Chinese.
I kept hitting next. You're like next. I'm like next.
Yeah.
Like, what? No.
So here is the signal from 2 gravity wave detectors of the merging of these 2 giant Chandrasekhar objects or black holes. One of them had 100 times, they can only estimate this, of course. One of them had close to 100 times the mass of the sun. The other one was about 60 times the mass of the sun. These things were just incredibly massive. And they start chasing each other like yin and yang, and 2 squirrels chasing each other. And it's called the in spiral. And you can see that the basic frequency gets higher and higher and higher. It forms a gravity wave chirp just before it merges. And then so it goes, it spins up, and then boom, suddenly it rattles around a little bit and then quiets down. And that's the end of it. You know, it goes, and then bing, and then the two things merge, and then they form one giant black hole that shakes around a little bit like a bunch of jello, and then finally quiets down. Now, when it does this, it identified that it loses it started out by about 160 solar masses, total mass, but it loses about 6 solar masses due to just gravity waves. I mean, this thing is converting mass into energy of gravity wave radiation. And it's all pure gravity. There's no matter there. The space is just bare vacuum. Next. So they've seen this. They've seen this. Now, what happened with this event, GW 19521, collision of 2 massive black holes, or Chandrasekhar objects, is they saw from the same part of the sky, and you can see where the little blue cross is, that was where they identified the flash. The orange area, especially with the dark areas, where they thought the gravity wave signal came from. They're almost on top of each other, and they happened about almost the same time. They got this tremendous flash of light that lasted like about a day before it settled down. And it has not been repeated. And there was no flash of light like that ever seen before that from that part of the sky. They have telescopes pointing it all over the sky now. They watch these things. They'd never seen anything like this before. And it is not repeated. The models for people trying to figure out what had happened said, well, one of the big black hole then ran into a cloud of gas around another black hole. They had to invoke another big black hole, and that the new merged black hole, the small one, was in the disk of a giant black hole, even bigger black hole, and it would go through the disk and make all these X-rays and gamma rays and things like this, causing the flash. Well, they said if that was true, then it should repeat in about 2 years. But it's been that the event was seen in 2019, and it's 2024. There has been no repeat, just like there's been no repeat of the gravity wave signal from there. The E&M signal and the gravity wave signal both happened at the same time, and they were singular events. The chirp of the gravity waves and the flash. So the flash was not repeated. So those models that they had, that it was a black hole orbiting through an accretion disk of another bigger black hole, those have failed. So they're almost certain now that the flash and the gravity waves came from the same place in the sky at the same time. Next. All right. As it turns out, gravity carries entropy with it. A Chandrasekhar object or black hole has a surface entropy. That means it can only expand in time. Now, when these two things merge, they radiate part of their mass into gravity waves. And that means you start out with like 160 solar masses, but you end up with only about 154 masses in the final black hole, because the rest of it gets turned into gravity wave radiation, shaking the place up. And so it loses all of this mass energy due to the gravity waves because they're so intense. Now, this also creates entropy. But as it turns out, gravity waves are not very good at carrying entropy. What's really good at making entropy is the very short, these gravity waves are mostly long wave. What you really like to get for entropy is short wave E&M. And the short wave part of the gravity fields all turn into black holes and turn into E&M. So we can make an assumption that the entropy loss, so it loses mass, but it also loses entropy, which goes as mass squared. So we have a way of estimating how much energy would go into the E&M flash. And I call this the light filament model. It's like a old tungsten light filament. You know, it's creating a lot of entropy, but the entropy is not staying on the filament. You turn off the filament and it just goes back to being a filament as the entropy doesn't change. It's all the entropy was in the electromagnetic fields that went out, the light. So anyway, we can actually make an estimate, and it turns out about 10% of the mass loss should go into pure E&M radiation. Next. So this thing was started out, it's light from darkness. According to this proposal that Kernzalagu and I had two very stimulating conversations where we basically put together this hypothesis together for an upcoming conference. And unfortunately, he then had a heart attack before the conference. So I ended up presenting the whole paper. And basically, we said that two colliding black holes would generate this enormous flash of light because they would, and it was basically the theory I just presented, but we didn't have the quantum aspects worked out. Anyway, next. So we can estimate how much was the E&M flash energy. The measurements indicated roughly a solar mass was converted into light energy. That's equivalent to a very, very large supernova. This thing outshone the galaxy it was in for about a day. Okay, we have a formula, it's just an estimate formula, approximate, making the assumption that the entropy is all carried by the electromagnetic waves out of the system. And they start out as gamma rays, by the way, and then they get redshifted as they fly away from the Chandrasekhar object and redshift. And what ends up happening is you end up with about half a solar mass, according to the predictions. So that's actually pretty close. Using the numbers which they got from the gravity waves, you can actually estimate the masses involved. And and then according to this model or this theory, we should get about half a solar mass. It looks like the E&M flash energy was close to a solar mass. So we actually have sort of a confirmation of this theory. Next. Okay, and sorry about the fine print, but here. Okay, in summary, the KB hypothesis as cuboid gem theory has been supported. Einstein unification is confirmed. We have an event that converted for the first time that we can see by direct observation. Hawking evaporation was entirely a theoretical idea. But now we have seen Hawking evaporation converting pure gravity waves or gravity fields into pure electromagnetic fields. So the Einstein unification of gravity and E&M is confirmed by this event, along with the KB hypothesis, as Barham would have loved to see. And so both Barham and I had worked on unifying gravity and E&M according to Einstein, and I think that I've succeeded with this Einstein unification. I can now quantize not only, so then since E&M is quantized, I can quantize gravity. Quantizing gravity leads to these micro CHOs or Chandrasekhar objects, being the end result of the cascade of unstable cascade to high frequency gravity waves, and then finally turning into E&M waves by Hawking evaporation. And so we saw this great event out in space. It was 11 billion light years away. It was a really long distance away, which means it was back in time, back in the early universe. And so this event, which showed a coincident enormous gravity wave signal and then an enormous flash of light equivalent to a very large supernova happening simultaneously, is, first of all, it's the first direct observation, I believe, of Hawking evaporation of black holes or Chandrasekhar objects. And by implication, it is a confirmation of Einstein's unification of gravity and E&M. So thank you very much. That's my talk.
John, thank you. Thank you. Thank you. Thank you. Thank you. Thank you. And okay, let me take that down. I'm going to bring everybody else back in. John, thank you, sir. Thank you. No, that was absolutely wonderful.
Privileged to be even addressing you all.
John disappeared. Yeah, let me apologize to everybody. I feel like I'm missing cues today. I am all over the place. So. Oh, look, and there's Mr. Perone.
Finally, better late than never. John, great presentation. I was just like watching it double speed on YouTube. And
where's Mike?
Hey.
Oh, there's
He's
Michael
down
P.
there.
Okay,
it's like
good.
the Brady Bunch.
Good.
He's the lower left corner.
Michael Perone. He's a super guy. He's a super guy. He did super things.
John, I have to get you in touch with Ken Griggs. He's been studying a turbulent model of gravity as well. And some insights that can be a benefit to you.
Great.
Yeah.
I'm sorry. Who is this again?
Ken Griggs.
Ken Griggs. He studied at MIT or something. I forget. It was no, he was
great.
Jim Gates' student at some point, I believe.
Yeah. Now Ken has presented before at APEC also. I think he's done 2 different presentations.
Yeah, you should check those out too.
Yeah, and then one of his, I think a friend or colleague.
I will check it out
as well.
I'm part of a group effort. Obviously, Barham, Kozlegu, and Einstein, of course, worked 30 years on this problem. God. And he just knew he was right. He just couldn't get the math to work out. And for one thing, he hated quantum mechanics. And it turns out quantum mechanics is the key.
Okay.
So I've had imaginary conversations with Al Einstein.
I did too, but he beat me up, and so I quit talking to him. I'm kidding. Jared, go for it.
He told me God doesn't play dice with the universe. Yeah.
I had a question about the flash that was observed. I found one research paper on it, and that was it, and it wasn't detailed enough. I'm really curious about the wavelengths that were observed during that flash. Did the wavelengths chirp up as well?
If you take the numbers of the event, there's an optical event and then a gravity wave event. And if you do Google those 2 events, they'll pop up all these papers now that are studying it.
What is that?
Drew, you're unmuted.
Yeah, I'll
John,
mute him.
Thank you, John. I'm wondering, do you know whether or not the frequencies of those lights shifted during the flash, or did they remain steady?
I studied several articles on it, and I could figure out that they were, they didn't give information on it. It was, and they wouldn't even, it was really hard for them to even just say, okay, how much light did you see? Finally, I found one paper that basically said, oh, we saw this much light, but it was obviously beamed right at us, searched right. They were trying to minimize the brightness of it. But if you said, oh, if light was emitted in every direction, it would have been equivalent to a very large supernova. they're very embarrassed by this thing, by the way, because this was not what they predicted would happen. And because everybody knows you can't turn gravity into electromagnetism, right? I mean, that's a heresy right now. Even though that's what Hawking evaporation is. So
there's the Gershenstein effect, right?
The academic community is like treading through a minefield right now. They feel like they're in a haunted house because they don't. I mean, they predicted there would be another flare about a year later, and then it didn't happen. Then they said, well, maybe it'll happen next year, and then nothing happened, and now it's been 5 years. But so
even the Wikipedia article on it.
Haunted house. What's that?
Even the Wikipedia article on it admits that they were expecting it and they still haven't seen it, and so now they don't know. And if Wikipedia can admit, that something's off.
Oh yeah. Oh, something's wrong.
So now we would have to look for similar
function.
So now we would have to look for similar optical events during other black hole mergers when we see them, I guess.
There might have been something very special about this particular one because of the sizes. They said it was the first time they'd ever seen the birth of a.
Yeah, that may play a role, but it's still good to be on the lookout. If that's
Well, actually, the very initial first gravity event they saw with the gravity wave detectors looks like it was the merger of two black holes or Chandrasekhar objects. But, and there was an optical flash reported, but other people couldn't confirm it. So they said, when two black holes collide, they don't make any light, of course. That's nonsense. So they just said, well, we can't confirm the observation of the light. One satellite picked it up, another one didn't. And so that was the very first event they thought actually may have created one of these flashes, but they couldn't confirm it. This second one, though, was like, the first one was just like a little firecracker. This one was a cherry bomb. It rattled windows. All the dogs in the neighborhood started barking after this thing went off.
Wouldn't the event horizons hit each other before the black holes did? I mean, the event horizons are
yes. Well, the black hole surfaces are basically the event horizons, and
so basically, if you had one coming in like this and the other coming in, you're slamming matter into matter at the speed of light. Maybe it was just if the two event horizons coming in and hitting each other, they're spinning, this thing's spinning, whatever. They're gonna intersect in some way, shape, or form. Wherever they come together, you've got matter moving.
That's pure. It's all pure gravity.
Slamming into matter and traveling near the speed of light. Why couldn't it just be matter incandescing? I mean, you're slamming matter into matter at near the speed of light. Maybe you got fusion.
Where's the matter going to come from? You've got these two huge black holes. They've swept the space clean.
The event horizon.
If we assume that they still have some accretion disk, even if it's maybe a small amount, then that could do something weird during the merger, maybe.
Right. I'm saying the accretion disk has to still have matter in it.
That's certainly possible, but they attributed it to encountering a accretion disk of an even larger black hole that was nearby. So they had to. The models didn't just say, "Oh, these things had accretion disks," and they obviously disrupted during this thing. No, they didn't. They said, "Oh, it had to have been these two black holes had to be orbiting each other inside the accretion disk of a much larger black hole."
So it just so happened that this gravity wave
into the 8 solar masses, something was one.
So it just so happened that the gravity waves generated EM in the visible light spectrum. Did it generate it anywhere up into the gamma or any way down into the infrared or just in the white light spectrum?
I think Jared asked something similar, but definitely the spectrum that it emitted would be very important.
Well, it's one of the things that happens.
Sorry,
absolutely. And I could not find a lot of information on the spectrum. That the original paper by Hawking said that you would just get like photons, and then if the little black hole was big enough, you'd start getting positron electron-positron pairs, which of course when they unite make gamma.
John, you seem to be lagging on my end.
Not getting anything out of what he's saying.
The problem is, though, since they're near an out and they actually get redshift from the black hole, out with something like gamma rays, it would end up looking just like blue or red light by the time it got out.
Maybe he should turn off his video. Maybe it's me.
So
no, it's
closer to the
John. You're
so yeah, and it's going to require some very detailed modeling.
John, I think you're cutting in and out. You may want to
try turning off your video. Try turning off your video,
or reduce the bandwidth requirement.
Yeah, I think his video kind of runs hot and cold. But a lot of that usually happens due to Wi-Fi.
Yeah,
I've noticed that.
Let me try and kill a bunch of processes. I have going on my.
Oops. I'm sure he'll be back.
Okay, now we know what those processes were. this one's using a lot of RAM and bandwidth.
Yeah.
No, I'm really excited to have John with us. And again, guys, let me apologize for today is my day for goofs. So,
Tim, did John say what observatory or what space telescope saw this flash?
He mentioned it to me on the phone, but he was really excited and talking quick, so I didn't catch it. Let me see.
Because some observatories are like dedicated to certain wavelengths, like some observe only gamma rays or X-rays.
Yeah.
I have I linked a paper in the private chat. It's an archive paper that says the two telescopes that they used.
And then unless there's a multispectral, that's kind of what they put up with the James Webb. They'll have a way to bend the spectra.
They
large.
did it with the Palomar Samuel Ocean Schmidt telescope, 48-inch, and then it looks like there was another one. There's another one with a 0.7 meter survey telescope.
So those sound like they were visible light, or in that range.
Tim, I just wanted to say you did great today, as it's 4:20 and you're in California. So
yeah,
that's like being in Canada.
Yeah, I saw that in the notes. Somebody's everywhere. Somebody said it's 4:20 today. There's like our chat is just baked. I'm like,
right? If the wind is coming from the east, then you have like the East Coast, then like the Midwest, and then all of the West Coast, all coming to you by.
So you're calling this you're saying this is a proximity high. Proximity high in Seattle.
Exactly.
Hey, Tim,
that's not really BC wildfire smoke, is it, Bernie?
No, that's exactly BC wildfire smoke. Let me tell you what. There's the.
Okay,
So
it's
Tim,
time
if you
to find
wanted,
out
I
what
could give.
I'm sorry.
It's time to find out what
hold on.
Jared's done. Jared, go back and start talking about your
hold up.
Graviflyer thing.
Hold up. Before I do that, let me share the paper that I'm talking about real quick to show the wavelengths that were observed.
Okay, yeah. And then let's go to Curtis after that. I think that we've lost John, and that's totally cool. I mean,
Tim, is Tom still around, or did Tom come on at any point? I was hoping to network with him a bit.
Tom Valone.
Yeah.
No, he had me play a video, which I also screwed up. Today's my day to shine.
Well, I guess we can connect via email afterwards, but I was wondering about some of his work with integrity research and had some questions. But anyway. I guess Jared's up? Or Curtis?
Yeah, Jared. Yeah. So Jared is going to... Jared, sorry. Let me add that to the stage.
There you go. I just wanted to share this paper so that you could see the wavelengths that were observed. So the top of this paper, here you go.
And John is back. I'll add him in, but he doesn't have video on.
Hopefully less bandwidth used.
Yeah.
All right. Yeah, I think I saw that article. And you can see that there's, just a spike of light. And but the thing is, they don't say.
I'll be right back, guys.
Oh, interesting. So what are these three frequencies we're looking at? Or no, that's something else.
I read through the articles. I couldn't figure out what the hell they were saying. They just showed these graphs and they gave weird units for everything, and that I wasn't familiar with. And I only found one article that actually gave what the how many watts per centimeter squared the signal was.
Is this from a paper where they were measuring the gravity wave?
So
no,
yeah,
they were measuring both.
These dashed lines here are from when they had the merger, right? And MJD, I think that's days. And they're saying that down here in this one, that every single one of these points is a 3-day interval. So you can see around here at the, 58,650, right? Where the dashed line is. That's the spot where you get this big old dip down here on this bottom one, which is a light curve. With G and R band data, I don't know if that's green and red or gamma.
They weren't very. I found the articles to be rather opaque.
Those might be magnitudes on the far left. Those might be absolute magnitudes on the far left. 18, 19. That'd be a really dim dot.
Oh, there's the wavelength graph. There was.
Yeah, I'll go back down to the wavelength one here in just a second. But yeah, the magnitude here, and you can see the change in magnitude. I think is what this one is. G and
I think
R.
that's what that is.
G and R. So then going back down here to the wavelength one.
So assuming that's still a Boltzmann distribution with peaks in it, then that's really hot, right?
But they didn't identify to me what the peaks were.
Yeah, those seem to be like elements or something, element formation or something during the. I don't know.
Okay, so
that's
it's
interesting.
4,000 to 8,000. That's across the whole white light spectrum.
So this
it was a broad spectrum of light. It wasn't
right.
It's red and blue elements were pretty much balanced. So it was a white flash.
Oh, spikes are like ionized oxygen and ionized sulfur. Well, sulfur would be a little further out, but yeah, that's doubly ionized oxygen, neon.
Can you show that caption? The caption, can you read? Can I see the caption
hydrogen
below?
data.
Other than
That's
fading by
deep red.
30%, there is no strong spectral changes over the intervening decade.
So yeah, these two lines are 2006 and 2020. So the blue line is from 2006. The black line is from 2020. So it's before and after the merger, right?
Yeah.
So we're not actually seeing anything of the actual moment of the merger, but it still does give you some good information.
No, we're not.
It still gives you some good information on where energy was lost or gained.
Okay. And I just did a quick back of the envelope calculation. That's about, if that's a Boltzmann spectrum with a peak at like 400 nanometers, then that's probably about 7,500 Kelvin.
Oh, yeah.
Just off the top of my head.
So you can see there is a lot of data there. I would, I'm still studying this stuff, but, the bottom line was that they said, oh, this has got to be a collision with some cloud of matter generating this, but they didn't. They said that would repeat then, and it didn't.
Yeah,
It would orbit through the cloud again,
astronomical events.
What's that?
Oh, unfortunately, a lot of astronomical events don't repeat. So it's gonna.
Hey, this thing was 11. The estimates I heard of the range of this was 11 billion light years from here. I mean, this is. We can't exactly get in our cars and drive over to where it happened.
Anyway, it's an interesting idea, gravitational turbulence. I guess what remains is to see if it happens again with another collision at some other time, and hopefully we can get better data on it when it does.
Well, Michael, I'm not going to sit still for another 5 years waiting for another repeat of this. I'm getting on this horse and riding it because we predicted this thing in 2003, and now it apparently has happened. And
John, sorry. John, I was wondering if you could say anything. So Kerr black holes are black holes that have, spin and big magnetic fields. And all that.
Oh, absolutely. These things. That would. Yeah, they're unfortunately much more complicated than non-spinning black holes, and the final surface. In a Kerr black hole, the event horizon kind of splits into two things, and you can end up with surfaces that you cannot describe in 3 dimensions anymore. They're actually tesseracts, and things get. You better bring along Alice from Alice in Wonderland when you start exploring these Kerr solutions. And of course, if you have two objects like this spiraling in on each other, like two squirrels chasing each other faster and faster, of course, the final object is going to be really spinning. And one of the ways that the gravity waves carry off energy is they're partly carrying off some of that angular momentum.
Is it possible? Sorry, keep going.
Yeah, I was going to mention one of the other things that the people who modeled this flare as being due to flying through the accretion disk of a much larger nearby black hole, they said, the reason it was so bright that we could see it was beamed preferentially at the Earth. And, Occam of Occam's razor would have immediately gotten upset and pulled out his straight razor. They invoked a lot of things to get this model to work, but but I just think it was just as a pretty much big flash, like from a supernova going in every direction, and the numbers I worked out seem to work. I'm in this very early model seem to work, but Einstein had a saying. He said, "Seek simplicity and then distrust it," because the universe is a complex place. Once you start throwing in Kerr solutions and I haven't even actually studied the Kerr solution much because it gets very complicated very quickly, and I'm basically just a plasma physicist. And
yeah,
but,
John, have you seen Kerr's recent paper about singularities?
No.
Okay, you should probably take a look at it. It's on archive.
Whose paper is that?
Kerr, the guy that did
Kerr
that.
did some work on singularities.
No, Kerr, he did the solution for a rotating.
Oh yes, yes.
Yeah, he did a paper
Brilliant
late
guy.
last year. He did a paper late last year, basically saying that the singularities don't exist.
Yeah. Well, guys,
if you can't see them, you can't prove that they don't exist. That's for sure.
So we're at 2 minutes. We're at 2 minutes until the top of the hour.
Oh, okay,
John,
yeah, and I'm gonna have to. I've been invited to dinner someplace at 6 o'clock, so I'm gonna have.
No,
to...
that works. So, John, let me thank you for your time, then, man. Thank you once again.
Thank you, guys.
I'm
You
gonna
guys
put
do
my
me
hands
great
together.
honor.
Dr. John Brandenburg, thank you, sir. And John, I do hope to see you in the next month or so in person. But if not, we can arrange another trip. I'm just taking the train down the coast.
Okay.
So it should be
Hey,
pretty
Michael, keep being super, but don't end up mad as a hatter. Some of the stuff you're working with.
Okay. Well, John,
I'm telling you that is the March Hare. The March Hare is giving advice to people to avoid being
John,
mad
before
as a
you
hatter.
disappear, you want to see a plasma discharge that shuts down a warp
I
reactor?
always love to see plasma discharges.
Okay, hang on a second. I have a completely. Give me a second. Share screen. I hate technology.
Microwave ovens are not safe around me for good reason.
Getting there. Give me a sec.
Okay, Drew.
Oh, I see something lighting up. I see his face lighting up.
Okay.
There we go. Okay.
All right.
Oh.
All right. Let's see it.
Hang on. It'll be right here. That blue glow, that is a warp plate shorting out to about 9,500 volts. And the pressure is a little high for that kind of voltage. Does it have blue wispiness right here?
I love it. I love it.
Give it a second. It'll happen again. Right about now.
There we go.
And the sad reality is,
right.
if you see plasma in your chamber, you are not making warp drive.
Okay, well, guys, it's exactly 5 o'clock. So, John, thank you one more time. What I want to do is, as promised, I'll go to Curtis and then Brian Sinclair for lab updates, and
Thank
then
you,
we'll
Jim.
take things from there.
Thank you
Absolutely,
all
John.
for.
Thank you as well, John. Okay, I'm going to remove everybody back out, and we will just go to Curtis. Okay, Curtis, welcome, sir. You have lab updates for us.
Yeah, so let me start the slide.
Oh, okay.
There we go. All right. So, okay. So basically, there's been some progress in the lab. We have upgraded to a high-speed camera, 525 frames a second. It's a standard definition. But we're basically not really using that to record the raw video. We're going to be doing screen captures. We had upgraded the monitor to 240 FPS, so that's the frame rate we're actually capturing video at. So there's a second look where I basically used a microphone stand. I was having trouble finding something to hold this camera because it's meant for use with telescopes. It fits it where an eyepiece does. And so luckily I found a camera or a microphone holder that could fit that barrel and hold it nice and snugly. And also I'm using this light right here to illuminate, because when you're going at that high a frame rate, you need a lot of light. Your exposure times are very small. So that's the main thing. So we have some recent runs with the updated. We do have the updated devices that I covered last time. And as you can see, the blue here is center of mass. You can see we're getting the torsion arm to swing over really reliably. Like I said before, these new bearings that are a composite, a plastic composite bearing, don't have the thrashing that the previous ball bearings have, and it's reliable basically when it's moving. And sometimes you see there's over time this thing has been in the actually chamber for a while and been run a lot. So today we took it out to get it re-lubricated and refreshed. But yeah, it's reliably running, and we're trying to, of course, figure out further improvements. But we're actually making several of these devices currently, and we're looking at the next steps of doing variations of the experiment. And here is so this actual sweep is a broad sweep of you can see down here at the bottom, 37.5 to 32.5 kilohertz in 10 seconds. So you can see that we're sweeping past the resonance. We go through the resonance, and you get those motions, those large motions. And here's an example of where, and the thing about that, even though we see a preferential movement on one side that is kind of unexplained with traditional mechanics, it's not a one-way motion. So what we have here is a short sweep at the resonance. This is down at the bottom. You can see 35.5 to 34.5 kilohertz and half a second sweep. So a similar type of sweep rate as before. And you see initially that it kind of just both move, both the blue and the red. The red is the torsion arm. The blue is the device. They both move initially in the same direction. So that's kind of the thing we're looking for. And of course, half second, it's kicking off and then coming back. So that's where the spikiness comes in, where we have it zeroing back up. But yeah, it's looking like we're able to reliably push and get a net force in one direction with this. So it's still not perfect. And the other thing about it is we are on the torsion arm, so we're looking at actually doing an experiment where we're going to clamp the torsion arm and mount the device with its frame on a rod, so that when we do runs, we can actually just go one direction, not have a torsion arm type of pendulum motion back and forth. We're trying to avoid that and show that in vacuum with some, a second set of bearings on a rod, on a fixed rod, that we can get the device to move. And then what we're going to need to do is have a mechanical means of recentering the device. So that's something that we're currently working out how we're going to do that. But yeah, and you can see right here near the end, there's a place where the device doesn't necessarily go back to center. It kind of like gets stuck somewhere, but it's still there's back up. So there's, like I said, this device has been run quite a bit, and it's not always, it's not always perfect, but it's much more reliable than previously. So I can, if I can share my screen, I can show you guys some. Share screen, some run. Let's see here. Entire screen.
Oh yeah, Curtis. I'm going to have to remove the slideshow. I'll just take the slideshow out and then just do a screen share.
Yeah, let me do that, and then I can bring up. Here we go. So here are some videos. This is a run that was done yesterday.
There we go.
Okay. During our lab meeting, and you can see this happens to be about a 10-second run. I don't have the data is not right on there. It's just the raw. This is the raw video. You can see on the bottom left, that's the spectrum, and in the middle bottom, that's waveforms of the blue is voltage, the green is current, and the other is the acceleration, the red, and in the top left, that is the red is the movement of the field tech sensor, which is distance. The blue is the rectified voltage, and the gold is the actual accelerometer. It's basically a piezo disc. One of the piezo discs is not. We don't put voltage on it. We actually measure voltage from it to measure how much compression it has. So I'll run that again for you guys. You can see that thing moving around like crazy there. So that's and this is actually very similar to the graphs I showed earlier in terms of the run. It looks like it's a 5-second run, and it's it's pushing like crazy. So there's quite a bit going on, and I do have an example of the 500 FPS frame rate. You can see it looks very different, almost black and white. And you can see when the motions happen, it's very slow. So you're getting a much slower motion here. This is a similar run, and you can actually see some of the movement of the wires that are there, and you can see vibrations and stuff like that. So this is a good tool we might use in the future if we need to. Hopefully we don't need to go too high speed and get further cameras. Hopefully this is enough. But if we do need that, that's something we can pursue in the future. I think if I have another video, let's see. Okay, this is a video I'd like to show. This is what we call tracker, where it's the same type of video, but you can see that on the right there's actually a point being moved around where the actual position of the torsion arm, which is in red, and the device in green. You can see those moving around, and you can see the blue is the center of mass. So that's what a tracker video looks like when we process it. So that's about all I have here. Let's see, stop sharing. There we go, and go back here. Okay. Let's see here. Let me bring up my slide again, if I can. Oh, no. I'm going to bring up my slide. Stop my video. Are you guys still there? Am I connected?
Yeah, I'm still here with you, Curtis.
Okay.
Yeah.
I'm trying to go back to the slide.
Oh, okay. Sorry, let me put that back up for you.
Oh, okay. Okay. There it is. So let's see. So yeah, so that's the video of the recent runs. And basically, I just want to briefly reiterate the stuff I've been talking about in terms of physics. Is I've been thinking a lot about the physics in the theory side of this, and I've been talking to Jim about actually us making an effort on that side. I think that's something that there is focus on the experimental, but I do think that we want to have a reasonable idea of what the physics might be that's going on, and why this is happening. So again, the thing we got to ask ourselves is what's fundamental, and what the theory could be that's describing this. And for those who haven't seen the last presentation, I covered this more recent observations of parity symmetry violation in the large scale structure of the universe. So these are talks that you can find on YouTube. It's a channel called Cosmology. I think it's called Cosmology Talks, if I remember right. But basically, people give presentations of their papers, and they're very, very well done papers. So I would highly recommend looking at that. And of course, as we know, for the weak force, there is parity symmetry violation and time symmetry violation, or CPT symmetry, as being the symmetry that we're finding that is there. Is something we've known since 1956. So the thing we got to ask ourselves is, if general relativity was developed before all this symmetry violations were discovered, what would that unified field theory have looked like? So, the other talk I would recommend is this Einstein's six paths to the metric tensor, to get an idea of, how Einstein was going about thinking of the unified field theory, and what he would have, what path would he have taken. So if you guys, and of course, as we know, the one of the fundamentals is the Mach principle. So the Mach principle is something that Carver Mead brought up in terms of this experiment that was done in the 70s, where it's found that neutrons diffraction can show that neutrons actually know, preferentially, how they're moving in the universe. So that goes to the heart of matter and inertia. And I did also want to comment on something that was brought up before in terms of gravitational and inertial mass. And those two are so far have been found to be equivalent to a very high degree of accuracy. So, the fact that there's mass shielding was something that was brought up in a previous talk. How that happens doesn't necessarily violate gravitational inertial mass, but going to the heart of the mechanism of how you can shield mass, or how you can reduce inertial mass locally, that's something that you guys, for those who haven't seen it, go back and look at my first APEC talk, and I cover that near the end from a unified field theory that can explain that basically the only difference with the program Einstein did was taking into account the parity symmetry violation and time symmetry violation. So that's the key thing. There's nothing else that you need to really extend or assume for the physics. Anyway, so that's about it. I think I can.
Awesome. Curtis, thank you, man. Thank you so much for the lab update. That is super, super cool. So, and again, you were always welcome to come back on. Always welcome to come back on the conference. So
I'll let you know when I have something ready for the. I've been asked to do certain things, and it's taking some time to work them out. So I've been pretty busy.
No, that's totally cool. And you know what? Now that I'm starting to travel, I'm thinking, maybe I should take a train down to you guys at some point.
Oh yeah, that'd be great. And actually, one thing I was going to mention is that, in terms of this physics stuff, it would be kind of nice to have some dedicated physics kind of panels and discussions. I was looking at other people's work out there, and there's people doing some interesting things. And maybe we can get like some discussions where, we can all kind of brainstorm.
And give some thought to that. So some thought to that. Send it over. I'll get it scheduled. So
sure.
Okay. Well, let me bring Brian St. Clair on. So Curtis, thank you yet again, sir. And let me see. I'm going to bring Brian on. Brian, my apologies for the delay. You had an unexpected update for us.
That's okay. Can you hear me okay?
Yeah. And for people who don't know, again, we have a lot of new people today. You have heavy duty, heavy metal inertial propulsion drives. These are seriously cool. So
yeah, we've been working for several years now on the PI system, the pulsed inertial engine. That transformed into the Trammel engine. The two are similar enough that I kind of relate the PI to a dump truck engine, versus the Trammel is going to be the Ferrari.
Well, let me take myself out, and that way it'll just be you. And if you want to show a video or something like that, just let me know, and we can.
Yeah, this is going to be really short. I'm building a new PI. It's taking the best of some of the older ones and putting them together into a new system. It's also taking some of the things that we've learned from the Trammel and putting it back into the pie where it all started. So behind me, I have what's going to be the Pi 6. Right now it's just the 6.XX because I don't know what version we're even going to be starting out at. Kind of like the Pi 2, it's a double deck, and it is capable of either being synchronous between the two tops, or between the top and the bottom, or it's able to be asynchronous at a 90-degree angle. So by asynchronous at a 90-degree angle, it's actually able to turn one or the other for part of its cycle. What we found out through a lot of experimentation is that if either one of these was pulsing and trying to go forward at the same time the next one was winding up for its pulse, it would diminish the wind up for the pulse, and then we would have a very, very weak state. If we lined everything up so we only had 2 pulses per full revolution, then we had a very, very strong state. That is why we were able to do the 90-degree offset and use it in a motor vehicle and watch the results, because there's so much mass in the motor vehicle that it absorbed that pulsation. When it's on its own like this, if I was just set this on wheels and they're locked at 90-degree offset, it's going to have very, very weak pulsation movement in any way, shape, or form. So what we want to do is we want to be able to independently run these. I don't have the motors attached to it yet, and it's going to be 2 motors. I don't have the motors attached to it yet, but this drive system that's in between the two, it's only going to allow them to go just so far before the next one has to work along with it, and that will keep the timing within a specified range, so that they're not interfering with one another, and yet they're not overrunning one another and pulsing against each other. The other thing that we found is that in actual physical motion of the entire unit, that part of that pulsation causing the problem at the 90-degree separation point, that might be able to be gotten away from if we were to put this entire unit on a rocker with a pivot somewhere right in the middle between the upper and the lower sections, so that it would actually rock slightly one way and the other while it's pulsing. That way we'll still get a forward momentum. We'll still be pushing on the external framework that this will be attached to, and yet it won't affect the other in any way, shape, or form. So that's really about it at this point. I'm really kind of excited to take a lot of and I'm not going to really point out some of the things that the Trammel has taught me, but I'm really kind of excited to take some of the Trammel stuff, put it into the Pi, put the Pi back together. I just kind of borrowed some of these from the Pi 4, because these are still the dead blow weights, and the rest of it is all built from scratch all over again. So honestly, Tim, that's really all I've got for tonight.
Brian, that's awesome. That's awesome. Thank you.
And hopefully within the next few weeks, we'll have something that we can show running.
Okay. Well, so why don't I do this? I think that was probably it for lab updates. Let me bring everybody back in. The only well, let me see. Drew, do you have a lab update?
Yeah.
Oh, okay. Well, let me do this then. Let me take everybody back out. I will go just to Drew, and then we'll do open discussion after that. Okay. My apologies, sir. Go for it.
Not a problem. Just once again.
And you and Dr. Bueller
technology.
are getting you guys are getting some attention this week.
Yeah. Well, Dr. Charles is, because it's his team, you know. Your
Oh,
buddy stole our team down the river, man. It made him look like the whole universe. That's okay. We're not upset at all.
well, no, Charlie has he has always been very open about the critical
Okay.
role that you play.
If you go and read the article that came out on Dr. Charles this week, you'll see this picture or something very similar to it. This is our current configuration inside of our vacuum chamber. And basically that's our test article back there. Oh, sorry. That's our test article back there in the back. And you're looking in, our chamber's only 3 feet long and 2 feet in diameter. So it's it's back there. This is the force meter right here. This thing is pretty crude. There's some string that connects the digital force meter to the thing. It's a pendulum. It pulls that way when it's pulling negative, and it pushes this way when it's going positive. Anyhow, that's our current configuration. This is what's been in the chamber for about the last 3 years. We have hundreds of runtime tests with this. This is the last weekend for this configuration. We are now stepping up to, well, this is like a very typical example of what that configuration can do. Basically, here's the 0 line up here. This is 0 force, and the red line is the power. So we bring up the high voltage, and the black line is thrust. In this particular case, it was pulling down against the unit. Doesn't really matter. Anyhow, the cool thing about this whole thing is it's right about 2 millinewtons of thrust on about 700 milligrams of material. So it's less than a gram, and it's making 2 milligrams of thrust. It's somewhere right around 28 to 30% Earth unity, maybe a little higher. There's nothing special about this test except this is a back-to-back, so the plates are, as close to together as they need to be for high density manufacture. But that's important isn't really that. It's that we are moving towards a whole nother coolness. So the future for us is going to look like the teeter-totter. Basically, the counterweight lives on this end, the thrust producing system lives on this end, and we'll have a little fake moon here, and when we switch on the propulsion system, it'll pull up, and the little lunar lander will appear to launch into the heavens. And when we turn off the system, the thrust will abate, and the little lunar lander will appear to land back onto the moon. So we're very excited about this. This has been a long time coming. And if you are completely insane and you have a master model maker on your team, you even have little tiny spacemen at 160:1 scale that you're going to put in your little tiny lunar lander in your little tiny diorama. So that's very exciting. We can't wait to put our little tiny lunar lander astronaut dude in the space diorama. And although it's nowhere near done, this is our future. This is a 5-plate warp engine right here. It's still just the thruster test article, but it'll have 5 plates on it. And this is the little counterbalance. So that's what's going on in sunny Florida.
Drew, that's amazing. That is absolutely amazing, man. Oops, sorry about that. Yeah. Well, I'm blown away. So you guys are just absolutely pushing forward. That's super cool.
Yeah, we got some interesting guests coming into the shop very soon.
Okay, so I'm going to get everybody
gearing up for some awesomeness.
Oops, it looks like Bernie's not here. Okay, so yeah, guys, I think that was everything that I had. You guys want to do open discussion, maybe half an hour, close things off at 6 p.m. Pacific tonight?
I want to hear from Jared.
I'll tell you about mine after you answer my question. I was just talking to a physicist friend yesterday because he was getting all excited. He hadn't heard about you guys before. I was like, oh yeah, I talk to Drew all the time. So he was wondering though, and I'm really curious about this. What do you think is the time frame, ballpark min max, before you have a terrestrial lifting craft? We talking 1 year, 6 years?
No.
3 years?
When you say a craft, I don't really think about building a craft until I am not working for someone else 12 hours a day. So we have to get self-funded. We have to get funded and we have to get out on our own so we can actually and we got to get a customer. But we've already built materials that can lift their own weight. I'd say that the next big milestone that has any hope of happening in the near future will be within 3 months. We'll have a stack that will probably make, I'm going to shoot for 100 millinewton stack, and it'll probably be Unity. We'll probably have 100 millinewton material Unity stack here before long. So it'll have whatever that it works out to be, whatever 100 millinewtons worth of mass works out to be. I don't know what that is, 10 grams or something like that. Probably that's 3 months away. You know, we were talking about how we were going to get our demo unit into space, and short of buying $1 million ride, you know, we were kicking around the idea of just self-launching. So end of the year, maybe. End of the year, we might have something that looks a lot like a balloon, just doesn't stop going up. Don't know.
And what do you think the ballpark cost would be to make like a 10 foot by 10 foot like platform of your panels?
Pricey. The problem is the metallization, the metal vapor system. You know, right now I can do a metal vapor section about this big. That's why my test article is a 5x5 piece of plastic. Maybe I could do an 8-inch circle, but a stack of 8-inch disc would be, you know, 100 feet high to get enough thrust to lift the weight of the plastic that goes around it at the scale I'm at. So my problem is I got to scale up. A couple of months ago, I showed the little plastic things. I had the little one and the big one and the whatever, the 18-inch one. I would need to scale up to that, which means I need a metal vapor deposition system to scale up to that. That's $100,000. I got it in work. You know, I got about 60 grand into it already. It's coming up with that last 40 grand to and the 3 months it's going to take to build the thing. And that's going to be a roll to roll so that I can actually manufacture 16-inch diameter or 16-inch wide thruster plates, because the thruster plate, the problem is the edge of the plate. It tries to short out around the edges because it's high voltage and, you know, it's 10 to the 8th field, and it just tries to short out. So you want to have the maximum amount of area for the minimum amount of edge. Well, the edge is always about 1/2 inch. So I need nice big plates with little edges. Right now I have little plates with little edges, or big edges, whatever it is. So, you know, it's all about money and time. And this, you know, and I don't know if it got mentioned in the article, but we are 100% self-funded, and we're not out there seeking money from, you know, a Kickstarter program or something. We're out there looking for a real customer, you know, somebody who wants to, you know, go pick up little metal cylinders on Mars or something, you know, realistically at something less than $12 billion in 25 years or something ridiculous. But, you know, those customers are few and far between, and, you know, we're out there beating the bushes.
Nice.
Awesome. Well, yeah. So again,
you
just
for
open
sharing.
discussion. You guys take it and run with it, and maybe we'll close things down about half an hour at 6.
So Tim, I got a picture that I want to share with you guys. Share screen. No paint.
Yeah. So we've been doing this for 5.5 hours today. So anyone who's new to APEC, we have totally scared off by now. They're long gone.
So Tim, if you could share that share screen I got. There we go. So I was working on trying to make a block diagram for the Graviflyer because it's way past due. There's so many interacting parts with this thing and things that affect other things that affect other things, that it's been rattling around in my brain for years, and it's been giving me headaches. So I finally banged this thing out the other night. It's caveat, disclaimer. I'm not going to say that this thing is completely accurate. This is just how I understand it at this moment. I won't really go through all of the lines and everything, what all they mean, other than red is magnetic and blue is electric, and then green is mechanical, right? And white colored, that's mechanical. But the gist of what I'm getting at for this block diagram is that it seems like all of these things, they all feed into creating their own like RF spikes or voltage spikes or some kind of electromagnetic spikes. And those spikes, when you do things just right, those spikes can line up. And when they line up, you get an amplitude bump on that. And so that lining up is getting them in phase. So you have a electromagnetic phase that you're trying to align. But then there's a mechanical phase that you're trying to align as well. The edges of these discs, I've got a disc right here. The edges of these discs are, they're vibrating, they're fluttering at certain harmonics. And the amount of force that is contained within that flutter, I can estimate by using a force gauge, lift up the corner of my disc while it's on there and go, okay, so I'm getting, a Newton or 2 Newtons at 3 millimeters of deflection. And I've measured, okay, I'm getting about 3 millimeters of positive deflection during these harmonics, these flutters. So my guess, and I'm hoping Curtis will join us because I think this kind of relates to the Mega Drive a little bit. My guess right now is that for the top disc, if we only think about the top disc, when it's doing that flutter, when it pushes up, when the edges flutter up, it's going unimpeded. But when it goes down, it's pushing against these fields that are on the center disc, the eddy current and the electric interactions there. And so in a way, it's somewhat analogous to those toys that maybe some of you played with as a kid. It looks like half a ball and it's made out of rubber, and you turn it inside out and you set it on the ground. And after a couple of seconds, the thing unrolls and it pops up, right? So in this case, the top rotor is like acting kind of like that. And instead of pushing against the ground like the pop-ups do, this thing is pushing against the electromagnetic fields, and that ends up getting transferred to pressure on the center disk, as well as added energy in the electromagnetic field, which then also propagates through the system. So last thing I'll say on this is all these dashed lines that I have here, these are all of the functions that seem like they are backwards propagating through the process, right? So yes, you're turning the disks with RPMs, right? But those have magnets on them, so they're creating magnetic fields. But then the magnetic fields of one disk is affecting the magnetic field of another disk, so then it's affecting the RPM. So now you have this feedback system. So all these dashed lines here are all the feedbacks. Anyways, and then over here for actual lift thrust, that's when you have the mechanical flutter edges of those discs, which are fluttering at about, call it 400 to 600 hertz. And if it takes, 2 Newtons to lift it up that much, and assume you're only getting half the cycle for lift, that means that you're getting 1 Newton at 600 hertz. But you're not completely efficient in your electromagnetic field for being able to transfer that into lift, to extract that flutter energy into lift energy. So my math suggests that for Big Bertha here, weighing in at 2.5, 3 kilograms, that I need to be at least 5.5% efficient for my flutter. And Alexei with his, he was probably at least 2.5% efficient. And that percentage efficiency changes depending on how you're affecting the flutter, which is strongly affected by the Tesla coil eddy current, as well as the ultrasound frequency. So when he's adjusting the ultrasound frequency, he's adjusting the damping of the flutter, which is adjusting the efficiency of the lift extraction. So that's what I got for now.
When's it going to jump off the ground?
Now I need to make Big Bertha lose some weight. He's go on a little bit of a 3D printing diet. So hopefully, also, what this suggests is that using larger discs is actually harmful because it takes a lot less pressure to get that much deflection on a large disc than it does on a smaller disc. Or I could use thicker discs that are harder to bend, and thus those magnetic fields from the eddy current that are causing the flutter will end up causing flutter on a stiffer disc, so you get more energy storage of that flutter that you can extract. But it comes down to being able to effectively couple the electromagnetic pulses timed properly to be something to get pushed against during the down flutter.
You're telling me you're setting up some kind of a magnetic flutter, some kind of a magnetically induced flutter in that aluminum pie pan?
If you give me a few seconds.
Where do you live? I may have to come and watch this. What state are you in?
So Jared is in,
Oregon.
without giving too much away, Jared is in the Portland area of Oregon.
Okay, I got good friends in Portland. That's where I used to do my computer-controlled telescope seminars every year.
Yeah, here, let's spotlight Jared. Solo layout.
So the camera frame rate kind of misses it. Actually, I can do this.
All right, so basically the spinny thing on top and the spinny thing on the bottom are setting up some kind of weird looking mechanical oscillations in your pie pan?
Yeah, so right now I got these plastic like rings around the rim to prevent the pie pan from vibrating. Because I thought I wanted to dampen that. I need to take those off now. And then the frame rate isn't great, but the edge of this spinning disc, right now it is fluttering about plus minus 2.5, 3 mil. And part of that is a little bit of an optical illusion because one edge of the disc is bent up 1 millimeter. But still, the whole thing, also the spindle of the hub there, those bearings have a little bit of play, so it allows the whole thing to kind of, wobble around.
Okay, what do you think that's actually achieving? You got a wobbly disc that's charged up to a couple of thousand volts, sitting over what? Is their center thing grounded? Is that big pie pan thing grounded or what?
Yeah, so I have this wire here that's connected to the vertical rod here. The other end of this is going to my workbench, which is grounded.
Okay, so basically the 3 metal vertical rods that tie this thing together are all grounded. The metal pie pan in the middle is grounded, and the black frame on the top is what? Just a printed frame? Can't tell what that is.
Yeah, this guy here.
No,
that is a
up
3D
higher.
printed. Oh, this.
The triangular thing, yeah.
Yeah,
What's
these
that?
are just These are 3D printed PETG cross rods to prevent these vertical rods from doing this.
Okay.
Which they do when this whole thing is bending and these guys are, going up and down.
Okay, so all right, so so the thing in the middle is grounded and your spinny plate is high voltage. So you're setting up a potential you got an electrostatic field. Of course, you've got RF going in there. You might have an electromagnetic field.
Also, don't forget, these magnets are spinning. So I have a magnetic field as well. And that magnetic field is creating an eddy current in the center disk. And that eddy current in the center disk is creating a secondary eddy current in this top disk. And that secondary eddy current then interacts with the primary eddy current. Very nonlinear.
Yeah. Yeah.
Very feedback. I counted 6 or 7 feedback systems in this device.
I gotta tell you, Jared. I can't talk about it, but you need to ping me offline. We need to get you and Charlie talking because we got some very interesting feedback information this week on our design, and we think we know.
Would love that.
We really think we know what's going on with that thing. Really, we do.
Excellent.
Yeah,
I would
ping
love
me
to hear your
offline.
input. Will do. Put your email in the private chat so I can reach out to you.
Sure. I have no idea how to do that.
Okay. So let me see. I'll remove you from solo layout. We'll put it back on. There we go. Yeah. Yeah, well, let me thank everybody. You know, this has been a pretty good conference, and I'll tell you a little bit of chaos. So next week, because we're pushing things forward, we have APEC open mic next week, and then again on May 20th, I'm hoping to head down. Jared, is that cool? May 20th through the 24th.
Yeah.
Okay, I'll bring the camera. I got a new tripod, got a new suitcase, got a new camera bag. Got all the fixings there, you know, and really my goal is just to get high-res footage. I mean, interview footage for yourself and high-res footage for the Graviflyer and be able to get that up online for folks to see. So no ulterior motives.
Posterity's sake.
Yeah. Well, you know, Zoom does, I mean, like Zoom does so much of the grunt work for us, right? I mean, the vast majority of what we need to communicate, we can do with Zoom and StreamYard and things like that. And I think that's one of the things that's making things move forward is this community now is able to get together and chat and interact with Zoom. And it's really useful. So the higher res stuff is just so that people can see inside your world a little more.
Hey guys, I'm back.
Hey Curtis. So yeah, I think we have about 15 minutes left if that's cool with you guys.
Okay. Yeah, I was listening in with Jared and there at the end there. I think and I heard what you said, Drew, that you guys might have an idea with the Graviflyer. But it does sound.
We know what's going. I'm telling you, we know what's going on with that thing, and it has nothing to do with spinny ass magnets, by the way.
Yeah, I'd like to talk as well because there's a lot of similarities to what the Graviflyer is doing and what the Woodward drive is doing in terms.
All right, Curtis, why don't we set up an offline thing where we all just get together and chat? I mean, we can do it tonight. You know, right after this thing goes off record. Or I have
an appointment in 15 minutes. I got a hard stop. I got to go, but the boss has priority with my time. So, we should set something up. That'd be great. But I was going to say in terms of like the Woodward effect, there's a lot of similarities. There's the vibration. Also, when we were running it in air, and you have those vibrations in air, you can't get an impulse. And so what's interesting about that is there's the interplay with the impulse of the air and the vibrations. So I highly suspect that what's going on there is mostly electromagnetic and mostly air effects. That's what it looks like to me.
Curtis, on the Mega Drive, remind me again, have you guys ever charged up either or both of the moving parts?
So we don't monitor the charge if the reaction masses, when you say moving parts, I mean we have a reaction mass and we have an aluminum plate, and the aluminum plate and the reaction mass are free to move as free as we can get them. We don't necessarily measure the voltage of those. We're not applying voltage directly, but there's voltages applied to the piezo discs in alternating polarities to get them to expand and contract. So they could gain charges, But the piezo stack, definitely there's voltages going into the piezo stack. And with the vibrations, I mean, the kind of the sound vibrations, we know that that there's movement at the ends of the surfaces back and forth. Now, in the Woodward drive, the mass fluctuations are supposed to be occurring in the stack with the piezo disc. So when you put energy in, the net mass is greater, let's say, in terms of like, not when you're putting energy in, but the term, if you look at the mass fluctuation formula that Woodward derives, it's dP related to dPdt. So the change in power over time. So that's why, and that needs to be coincidental to the acceleration. So that's why the frequency, the resonant frequency, is so important in the Woodward drive to get the thing to actually move under the effect that we're
what's the Woodward drive again?
The Mach effect
Mach's
drive.
principle.
It's based on Mach's principle and based on
that has nothing
Woodward's,
to do with those. It has nothing to do with what you're talking about. The forces they're getting have nothing to do with what they think that's generating them. We know exactly what's going on with that silly thing.
You're talking about the Graviflyer?
No, I'm talking about that. You're talking about that thing where it's got the truncated cone that goes up. It's got a little circle here and a big circle here. And is that the thing we're talking about?
No, that's not the Woodward drive. No.
Okay, I'm sorry. I thought that's what it was.
That I think what you're describing is that EM drive, maybe
Scheuer M drive, Scheuer drive.
Yeah, the M drive is not.
That's what I thought you're on. So what is it you're talking about?
No, this has to do with the Mach effect and Woodward's derivation of basically that there could be mass fluctuations when you have energy, when you manipulate matter and energy in such a way where you get a large change in power going into and out of the system. And so you end up with a mass fluctuation that you can use to preferentially kind of basically violate conservation of momentum.
Yeah. Sure. Okay.
So that's why, by the way, this is one of the reasons I keep emphasizing in terms of the physics side, the symmetries in physics, because if we're making, and ostensibly we are making devices that can preferentially move and violate conservation of momentum, then we're breaking the symmetry, which is parity symmetry. And so there has to be a deep reason why we're doing that. And we're seeing, like I said earlier, is that parity symmetry is broken in the universe, and so there might be subtle ways of doing that.
If you think you're going to violate the forces or the conservation of energy, you are diluting yourself.
No, so
you might be stealing energy from somewhere,
there's something called,
but you're not going to. You're not violating the conservation of energy. You just got to figure out where you're stealing your energy from.
So conservation of energy is a subset of Noether's theorem, right? So Noether's theorem basically ties symmetries of nature with conservation laws. So when you talk about conservation of energy, that's related to the time symmetry in nature, right? And time symmetry is something that we know is violated in the weak force. Okay, so what does that mean? We can extract energy? Well, it's not that straightforward of a thing. So what ends up happening is that in Noether's theorem, you say if a symmetry is violated or if conservation is violated, then that means a system is dissipative. Basically, there's an asymmetry there, and you might be able to do something about it, but it's not necessarily getting energy from nothing. Likewise with momentum, right? If we're violating momentum, then or creating something that can move, and momentum is not necessarily. It looks like it's not conserved. Then what we're doing is
you're violating momentum. What you're doing is you're not seeing the expected result. Well, that means that you're either doing something that is amazing, or you're stealing energy from somewhere, and you're actually not violating the conservation of momentum, but you haven't figured out where all the energy in the system is that you're tapping into. So I totally believe that your little machine is going to move someday, or whatever.
Yeah, I don't know if it's going to move.
The trick is you've got to broaden your horizon and say, okay, where are we stealing this energy from? Because the universe is a pretty tricky place. You can steal energy from all kinds of different places. We do it all the time. I don't know where we're stealing it from, but we're stealing energy because we're using it to make thrust. And we ain't putting it into the system because we can turn our thing off and walk away for 4 days and come back and it's still making thrust. So we obviously stole energy from somewhere. So the real trick is figuring out where you're stealing it from.
Well, okay, so there's two concepts here. There's energy and then there's momentum, right? They're not equal. They're different. They're different. They're related to different symmetries. So time symmetry is basically, a system going forward and backward in time, looking the same, right? And parity symmetry is what we get, conservation of momentum from, for example. So it doesn't mean that you can get energy out of the system. I agree with that. That if there's parity symmetry breaking happening in a system, it could be a microsystem, it could be a macro system. In microsystems, those are seen, right? In particle physics, you can do experiments with cobalt-60 was the first one they did, where they saw that there was a preferential motion where, a radiation happening in one direction versus another, and parity was violated. Okay, that was a big deal back then because until 1956 we didn't think that happened in nature, and it does in the microscale. Okay, and now we're seeing that in the large scale structure of the universe that looks to be the case, that parity is broken in large scale structures. So what you're right in terms of the energy. It's not a free energy thing. It's not none of that stuff. Okay. But what I'm saying is that if we're getting something where we're seeing momentum being violated, and I don't think necessarily the Graviflyer, it's an air. So like first thing I would say is that it's likely an air effect. And there's a really high, I heard mention of, these high energy electromagnetic fields flying all over the place. So it's very likely that stuff is what's causing it. Likewise, with the Woodward drive, we do have components in there where we're having step-op transformers, even though they're small, tiny off to the side. It could be an electromagnetic effect that we're getting. So those things, like you said, need to be basically, we need to do the experiment in such a way where the power source is moving with the device so that we can eliminate those factors, right? It has to be eliminated. We can't say yet with the Woodward drive that we're doing that until we get those power sources on there and we get a place like, in space where it's moving. And even then, it could be electromagnetic because there's an electromagnetic field in space. So it's going to be it's going to take more than one, in my opinion, more than one configuration of the experiment and us to understand the mechanism of why it's working, for us to reasonably say what we're doing and whether it has to do with inertia, right? So I agree with you. There's more to do experimentally to prove the physics.
Yeah. Well, guys, we're doing pretty well. Again, we got about 5 minutes left. So,
did you have something specific for me, Jared? Did you wanted to ask?
There was one thing besides the charge, is the solid mass, right? That's getting pushed up against, right? That thing, you ran finite modeling on that, right?
Yeah, COMSOL multi-physics model. And it was shown in air, we would get about Newton of force with that tiny little thing, that tiny, less than an inch wide.
So the reason why I ask is because, if I'm not way off the mark here with this flutter thing, with that pop-it analogy thing, I just wonder if the mass itself is getting, any vibration and deflection in it. And if somehow maybe the eddy currents are doing some of that asymmetric damping or something, right? If somehow physical vibration of a round disc and damped on one side, electromagnetically damped on one side, might allow for some kind of thrust. So for your thing, it's relatively thick, right? And relatively small, so super stiff, super high frequency, not going to be easy to bend at all. Also, the pressure points where the forces on the other side are being applied, those aren't dead center, right? Those are like 2 points side to side off of center axis, right?
Well, it's basically these piezo stack is like flush up against the reaction mass. So that reaction mass is basically being vibrated. You can think of it as a vibration, and it's traveling at the speed of the sound and the material through that vibration energy, and it's hitting the back and resonating. And that's why we talk about resonance with this thing, because for us to get the right effect or the maximum effect, what they had done is they had taken these brass reaction masses and done different sizes of them, different lengths. They were the same radius. It's a cylinder, but they were different lengths. So they tested different lengths and found one that was optimal, and that was all done, I believe, in air. So because they were actually optimizing for the air effects when they sized that.
Curtis, we did a full console modeling of our system, and it showed that we should have been making, I don't know, on the order of newtons of thrust per square inch of our system. And of course we weren't, and we were very sad. And it took us about 3 years to figure out there's a thing out there. I gotta read what it is because I have no idea. It's called the fine structure constant. Have you ever heard of that thing?
Oh yeah.
It's basically 1 over 137.
Yes.
And every time a system as complex as the stuff we mess around with, that whatever that silly thing is, it seems to be tied into the universe like the Fibonacci shape or whatever it is. So you gotta be real careful when you're messing around with those COMSOL models, because they just assume that you're putting in information that's not it's not wrong. We did an extraordinary set of modeling, and we have world-class modelers, and it turned out we were off by a factor of 10,000, which just so happens to be 1 over 137 squared. So
yeah. So
you might want to keep in mind
this COMSOL model was done in air to find out if air is likely the culprit of the motion we were getting. It's not meant to model what the Woodward what the Mach effect is supposed to give us. It was meant to validate the air experiment, which to us said, okay, air effects with a COMSOL model given 1 atmosphere of air, because we were doing at the time they were doing the experiment in air, and I wasn't in agreement. I wanted it back in vacuum, so that helped us kind of prove that we got to get this thing back in vacuum if we want to see what the Woodward effect is. And the Woodward effect has been done with those calculations, not with the multiphysics model. That we have not done that.
Well, guys, on that note, it is 6 p.m. Why don't we wrap things up for today? It's been a little bit quicker, but with some shorter presentations. I want to thank everybody for attending APEC today. We have an open mic coming up next week, so this will all be to be continued. And I want to thank all of you guys for presenting and showing us your updates as well. So this has been APEC for April 20th, 4/20, 2024.